Yeah, hi everyone. So we will see the solution, but before that, important announcement that all these states are now active. All these All India mock tests are active now. So you can attempt it absolutely for free. You can simply go to our website, you will and then go to our test series section. There you will be getting Concept X, Killer X, Booster X, and Replica X. So if you did not attempt it yet, you can attempt all of them. Okay. Now we will be getting started with the solution. Sir, what was the paper level? As per me, it was on the moderate to tougher side, less on the tougher side, but I would say it is moderate. Near to GATE 2024 examination, I have tried to set it up. Okay. Few questions were lengthy as well, but easy questions were actually very easy. If someone try to get sir around 40 to 45 marks, then he can easily get 40 to 45. But if you go on solving a lot of questions, then a lot of minor mistake you can do and end up losing the marks. So this kind of paper I have tried to set up, right? So we will see the video solutions along with that. What was the marks of toppers and all these things, all these analysis, just like the previous examination, we are going to do at 6:30 p.m. But even if you haven't attempted the test, you can still attempt all these papers. Okay, all these question paper in the best possible manner. We have framed those question paper. We have provided the video solution as well. So all of them you can attempt. All of these question paper you can attempt. Concept X, Killer X, Booster X, and Replica X for both EC and electrical students. Okay, so let's get started with the solutions now.
Yeah, let's solve this question. All the workers are hereby instructed to reach the factory by 8:30 am. So this is a statement. Now the statement above assumes which of the following? 1. Some of the workers do not arrive at the factory in time. Is this a correct assumption? And second point is workers will follow the strict warning given in the notice. So the first point tells me that we are assuming that workers do not arrive in time. This is not a valid assumption, right? So we are giving a notice that all the workers are hereby instructed to reach the factory by 8:30 am. So we are giving you a notice, right? How do I know whether workers come in time or not? This is just a notice to let the workers know they should arrive by 8:30 am, right? It may happen that they already arrive in time, right? So this first assumption is incorrect, right? According to the given statement. Second assumption is correct. Workers will follow the strict warning given in the notice. That is the reason why I am giving the notice, right? This is the reason that my assumption would be that after giving this notice, workers will follow the strict warning. This is a warning. So in this case, option 2 is correct. That is my assumption. That is the reason why I am giving a warning, right? So that they can follow the given notice. So option 2 is correct in this case, that this is a correct assumption. Option 1 is not correct. I don't know whether workers arrive in time or not, right? So option 2 would be the correct answer for this question. Below are two analogous groups, group 1 and group 2, each having listing words in decreasing order of intensity. So intensity is getting reduced. Identify the missing word in group 2. So here we see ecstatic, then happy, then content, right? So ecstatic is like very high intense, right? You are very happy, like you are jumping in joy and stuff. Happy, you have a smile. Content is just you, like it's normal, right? It's not even happy or something. It's just normal. Your face is normal. So obviously intensity is decreasing. Here we see loud and audible. So audible is you're able to hear the person. Loud means like I'm shouting, right? That is louder, like more noisier. Here something must be there that is very high intensity. One is noisy, and like what? Let's see the options. Deafening means like whatever audio is coming, right, that can make your ears deaf. Noisy, very like high noise, that's why noisy. Silent and whispering are basically they are lower intensity, right? But I need a word that is higher intensity. So either it can be deafening or noisy. That is a doubt, right? So here something must be there that is of very high intensity. We see ecstatic is like very happy, jumping in joy. So which has more intensity? Deafening has more intensity. Why? Because it can make your ears deaf. If I say the neighbors are noisy, is there a possibility that ears can go deaf? No, right? They are noisy, they are very loud, that is there. But the more intense word here is deafening, right? So deafening would be your correct answer for this question. A trader buys potatoes of two different varieties P and Q. So there are two different varieties P and Q. Let's assume he is mixing it. So they are in the ratio of P is to Q and mixes them with a certain ratio, that is, let's assume P by Q, right? And sells them. So the selling price is 192 per kg. Now the cost is this for P. So what is the cost per kg of P? It will be 160. And what is the cost of Q per kg? It will be 200, right? Simply divide by 5 and divide by 4, dividing them by their weights. If the trader makes an overall profit of 8%, what is the ratio of the mixture P and Q? So the trader makes an overall profit of 8%, right? So if he makes an overall profit of 8%, we know how do I calculate profit? It is percentage 1.08, because it is 8% profit into the cost price will be equals to my selling price, right? Basically your selling price minus cost price will be the profit percentage, that is nothing but the profit on the cost price, right? 8% of CP, right? That is how we compute the profit. So it's very simple. So yeah, now how to compute that, right? How to compute that? Yeah, we got this. So what is my cost? Because I have to compute my cost price, right? Because they have given me the selling price and this ratio. So what is the cost price that I am currently incurring if let's say P is getting utilized by P ratio? The ratio is, so P by Q, right? That is the ratio. P by Q is the ratio. So what will be the cost per kg? What will be the cost per kg? It will be 160 into P plus 200 into Q. If I assume P plus Q equals to 1, right? It's very simple, right? If let's say I am taking P amount of P only and I am taking Q amount of Q, and both of them are adding up to 1 kg. So what is the cost per kg there? It is 192, right? Very simple arithmetic I'm doing. That's all, right? So cost of P per kg is 160, and then I'm multiplying by the amount of P getting used, that is P only, and cost of Q per kg is 200, and amount of Q getting used, that is Q only, right? I could have changed this to X and Y, things would have been same only. Now this will be equal to my cost price, right? So what is my cost price? Let me compute the cost price here. So cost price here would be selling price divided by 1.08. So 192 divided by 1.08. Let me compute that. 192 divided by 1.08, that is 177.78, right? That is my uh, yeah, that is my cost price, right? Yes. Now so this value will be equals to 177.78, and P plus Q is also equals to 1. So let me divide this whole equation by 40, right? If I divide this whole equation by 40, this will be 4P plus 5Q, and this if I divide by 40, this will be 4.44. Now if I multiply this by 4, this will be 4P plus 4Q equals to 4. Now if I subtract, this will be Q would be equals to 0.44, and your P would be equals to how much? 0.56, right? So what is the ratio? They are asking me the ratio. So this would be almost 5 is to 4, very close to 5 is to 4, right? Very close to 5 is to 4, because if you divide, like basically 0.55 is, if I approximately write this as 0.55, right? This will be almost 5 is to 4, that is present in option A. Okay, there will be some points like, but it will be very close to 5 is to 4. So option A would be the correct answer in this question. Read the following information carefully. A, B, C, D, F, G are sitting around a circle and are facing the center. So all of them are facing the center, right? So let me make a circle, and all of them are facing the center. So let's assume this is the center, right? Now let's read the statements. G is second to the left of C. So G, this person, is second to the left of C, right? So let me make C, and to the left of C. Now which side is left? If I'm facing on in the center, right? To the left would be on this side or this side? It will be this side, right? So second to the left of C, that will be somewhere here, right? G would be here, and somewhere in between there would be some other person. Now continuing on that, who is to the immediate left of F? So if there is a continuation, right, who, then this who is basically the most recent person that was discussed. C was discussed, so they're talking about C here, right? G is second to the left of C. Who? That means they're talking about C. C is who is to the immediate left of F. So to the immediate left of F, C is there, right? So if I assume F to be here, then the left of F is this. So to the immediate left of F, there is C. This diagram is absolutely correct. Now let's go to the third statement. A is third to the left of E. A is third to the left of E. So third to the left of E. Currently, nothing is mentioned. I don't know where A and E will be. So let me just mark them randomly. A is here, and to the left of, sorry, A is third to the left of E. Sorry, first I have to draw E, right? So E is here. Left would be, I'm facing towards here, so left would be here. Third to the left of E. So A is somewhere here, and in between there will be some other person. I don't know. This diagram may be incorrect because I have yet to read the fourth statement. So B is between D and E. So B is between D and E, right? So B would be between D and E, right? So this is not a correct position for B. B would be somewhere here, right? Because if I place my B here, then it will be between A and E. That is not possible. So B has to be somewhere here. It will be between D and E. So D has to be the immediate right of B, right? Okay. So this is a rough diagram. Now how many people are there? So A, B, C, D, E, F, G, H. So A, B, C, D, E, F. Now this one person was missing here, right? So that means our diagram is still not complete. So we can place E over here, right? If I place E over here, so to the immediate left of E, A can come here, and then B can come. Sorry, B has to come to the immediate right of E. That is not possible. So no, this is not possible. Actually, what is possible? So D can come here, right? D can come here. So all this can be shifted to the in the anti-clockwise direction, correct? So D can be between C and G. That is totally valid. Now B will be here. I'm just shifting everything to the anti-clockwise direction. That's it. That is what I'm doing. I'm just shifting everything to the anti-clockwise direction, right? Okay, and A is here, but A is to the second right. Okay, this is also not valid, right? Because A has to be to the second left of E. Sorry, A is to the A is to the I read it wrong. A is to the third left of E. I'm sorry. So A is to the third left of D. Okay, things have gone a bit wrong. Okay, this is, let me keep the D over here. So sorry, there will be 2% in between, right? 2%. Okay. So where can I keep E and B and D? So if I shift everything there, that is not valid. So if E is here, B has to be in between. They've talked about G. G is to the second left of C. That is correct. Who is to the immediate left of F? Okay. So, okay. I got it. So what, I can shift everything to the clockwise direction, right? I can shift everything. I can shift A to here. If I shift A to here, what will be happening? So then E can come here, right? Don't worry, I will place everything. Then I will explain you after arranging what is happening. So now all the arrangements are correct. Okay, all these arrangements are correct. They are not spaced, but they're correct. So let me read the statements once again. So G is second to the left of C. So G is second to the left of C. So first and then second, right? So second to the left of C. Yeah, this is the left of C, and the second person is G. That is correct. Now, who is immediate left of F? So left of F is C. Correct again. A is third to the left of E. So third to the left of E, right? So this is the left, right? This is the left hand side of E. E is facing this side. This is the left hand side of E. So 1, 2, 3. Yeah, third person is A. Correct. Then B is between D and E. So B is between D and E. Again correct. So all the arrangements are correct. Now you're proper. Now you will answer the options. A is fourth to the right of E. So no, A is okay. To the right of E, right? So here 1, 2, I'm to the right hand side, meaning anti-clockwise, correct? It is facing this side. So 1%, 2%, 3%, 4%. Yes, First option is correct. A is fourth to the right of E. This is correct, but they have asked you to mark the incorrect answer, right? False. Be careful while reading the question. They have asked you to mark the incorrect. G is to the immediate right of D. G is immediate right of D. Yeah, I'm facing this side, and to the right of D, I have G. That is correct. So this again not your answer. F is third to the right of D. Okay, so I'm facing this side. Right of D would be 1, 2, 3. Sorry, hold. F is third to the right of D. Sorry, to the right of D, right? So I'm facing this side. Right of D would be 1, 2, 3. No, third person is C, not F. So this option is certainly your answer. Let us read the last option as well, just to verify. B is immediate left of D. So uh, okay, D is facing this side. Left of D would be this. Yeah, B is to the immediate left of D. Absolutely correct. So option C is your answer for this question. In a school, the periodical examinations are held every second month. In a session, okay, every second month there are examinations that are held every second month, right? In a session during April 2010 till March 2011, a student of class 9 appeared for each of the periodical exams. The aggregate marks obtained by him in each periodical exam are represented in the line given below, right? So each exam, how much marks is he getting, it is represented. In which periodical exam did the student obtained the highest percentage increase over the previous periodical exam? So basically, in which particular month was the highest percentage increase, right? How do I calculate percentage increase? It is the final value minus the initial value upon the initial value, because they are asking me over the previous periodical exam, so it will be upon the initial value into 100. Obviously that will give you the percentage increase. It's very simple, nothing to think about. Graphically also you can see, like, there is a huge jump here, right, and there is a quite a jump here, but these jumps are very low, right? So it intuitively makes sense the percentage increase, right, would be somewhere here. That will be maximum. It will be either uh, October, August, like October 2010 or December 2010, right? So if we see one thing intuitively how we can do, I will tell you. So there is an increase of 5, there is a jump of 5. So these are same, right? Here also there is a jump of 5. So these are not that high. But I see there is a jump of 15. There is a jump of 15 here. Great. Both these jumps are same. Now, if both these jumps are same, that basically the final minus initial for both these cases is same, that is 15. The denominator is different. For this case, in October 2010, the denominator is 370 for the first case, and for the second case, the denominator is 385 for this case, right? It is 385. So certainly this one is lower, right? So overall, if the denominator is lower, so overall this ratio will be higher in October 2010. So your answer would be October 2010, and you can safely calculate it. So it will be for October 2010, it will be 15, the difference, final minus initial. Final is this one, initial is this one, upon the initial value 370. You can compare this value into 100, obviously. Compare this value with the next one, right? This one, 15 upon 385. Sorry, yeah, 385 into 100. If you compare, obviously this one will be higher, right? You can calculate the percentage. This one will be higher. So option C will be the correct answer for this question. The memo service has trains going from Mumbai to Pune. So I'm going from Mumbai to Pune, and Pune to Mumbai every hour, right? So every hour, every 1 hour, I have trains that start both from Mumbai to Pune and from Pune to Mumbai as well. Okay, great. The first one from either station starts at 6 a.m. So my starting point or time on both the sides would be 6 a.m. The trip from one city to another takes 4.5 hours. So this time duration distance is around 4.5 hours, 4.5 hours basically. And all the trains travel at same speed. Okay, so all of them it will take 4.5 hours. If a train starts at 12 noon, so I'm starting at 12 noon. Okay, from Mumbai towards Pune. From Mumbai towards Pune, I'm starting from 12 noon. Okay. How many will it pass during its entire journey? So how many trains will will this current train pass? So I have a train here, right? That is traveling from Mumbai to Pune. That starts from 12 noon, and every hour there are trains that start. So of course it's a 4.5 hour journey. So it will meet some trains. What will be those trains? That is what they are asking me. Correct. So basically they're asking me how many trains will it pass during its entire journey. So what is happening, right? One train, there are two tracks, right? Memu service, there will be two tracks. One train, like one train will be going from Mumbai to Pune, and the other train will be coming back from Pune to Mumbai, right? There are two tracks parallelly. So once this train goes from Mumbai to Pune, it will obviously cross the trains that are coming back, sorry, that are coming from Pune towards going towards Mumbai, right? So okay, so it is starting from 12 noon, correct? If I see a train that starts from 6 a.m. from Pune, this 6 a.m. train would reach here at what time? At 10:30 a.m. So the first Pune train that will reach at Mumbai will be 10:30 a.m. Next train would reach at 11:30. So till this point, right, my train has not even started. So of course, my this train, right, that starts from 12 noon, it will not see this train. Now, the next train, right, that starts from what time? That starts at 8 a.m. The train that starts at 8 a.m. that will reach here at 12:30 a.m. Sorry, p.m. So certainly somewhere in the middle, right, it will reach at the station at 12:30. So it will be somewhere in the middle here, right? Once my train starts from Mumbai, this train, it will somewhere meet this 12:30 p.m. wala train, correct? Now, what about the next train? Now, this train will finish its journey when? At 16:30 p.m. Right, 16:30, like we should actually not provide 16:30 here. So it's a 12 hour. So 16:30 basically means PM only, right? Or you can say 4:30 PM. Same thing. Don't worry. Right? Okay. So I have to calculate how many trains are actually crossing or in there on the track in this whole period from 12 to 6:30 PM, right? So this is one train. Then another train that will start at 9 a.m., right? That will reach here. So that will also be on, that will somewhere meet, that will reach here at 13:20 p.m. So this was also one train. So one, two trains. Then again another train is there that will reach here at 14:30 p.m. 310, right? Now, okay, this will 1, 2, 3, 9 a.m., 10 a.m., then 11 a.m., 12 a.m., 13. So what is happening? So I have to, first of all, I have to find out the starting point from where this train will see the trains that are coming from the Pune side. The starting point is 8 a.m., right? Because the 8 a.m. train will reach at 12:30. So somewhere in the middle it will meet. And this train, right, that starts from Mumbai at 12 noon, this will reach at Pune at 16:30, right? That is basically 4:30 p.m. So I have to compute from 8 a.m. till how many trains are there till 16:30, basically 4:30 p.m. All those trains will somewhere start from here and somewhere meet the this train in their track, respective tracks, right, in the in the track, right, somewhere they will meet in the middle. Okay, so from 8 a.m. to 4:30 p.m. how many trains I have? So how many hours is that from 8 to 4:30? It is basically 16 minus 8 plus 1, right? This is the amount of hours, that is 9 hours. You can calculate between 6. So if I start from 8 to 16, I have 9 hours. Cool. So how many trains will be there? Each hour there are trains. So total I have 9 trains. Correct. So here 9 trains will be answered. Like you can solve this very easily, very quickly. I'm just explaining you all this, but all this is not required. You know, there are trains that will start from Mumbai to Pune, Pune to Mumbai. Or they have told you that my train starts from 12 noon, and they're asking me how many trains will it meet that are coming from the other side. Right? Pass. So basically what is happening? Basically, right, I have to compute the starting point. Because if I see 6 a.m. train reaches here 10:30 a.m., my Mumbai train does not even start there, right? So it will certainly not meet. I have to see the starting point. I saw that at 8 a.m. it is reaching here 12:30 p.m. So somewhere in the middle they must meet. So 8 a.m. is the starting point. Then I will compute till 4:30 p.m. because my Mumbai train is reaching its destination Pune at 4:30 p.m. So before that, whatever many trains are there that will start, it will obviously meet the Mumbai train that is coming from Mumbai. So I will calculate the number of hours from 8 a.m. to 4:30 p.m. that is 16 minus 8 plus 1. Very simple maths, arithmetics. So 9 hours, and every hour I have a train. So there will be total 9 trains that this Mumbai train will cross. So answer would be option C. Yeah, this is a good question. ABCDF is a regular hexagon of side 6 centimeter. What is the area of triangle BDF? So this is a regular hexagon. Now they are asking me what is the area of triangle BD and F, right? So if it is a regular hexagon, do you know what are the angles of each of this? So it's a regular hexagon, right? So all these will be same angle, theta, 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 and theta. Okay. So do you know what is this angle? This angle also will be theta only, right? So it's very easy for you to remember. So if I have a triangle, what is the total sum of angles? It is 180. If I have a square, what is the total sum of angles? It is 360. So there is this formula, right? 180 into n minus 2. This I have told you in aptitude as well how to remember it, right? So it's very simple. When my n is 3, addition would be 180. When my n is 4, addition would be 360. So this is how you remember, right? You remember it for triangle and square. Then you remember the formula. You write it down. Okay, you write it down. Write down the formula and verify whether they are matching. Or if even if you forget, right? Okay, I have forgotten. But you know somewhere it is something like 180 into something, right? What is that something? How can you derive it? So you can derive it by examples. You draw triangle, you draw rectangle, and okay, you say okay, there are 3 sides. So it is something n minus something. I don't remember. So it will be n minus 2 because here if it is 180 into n minus x, right? X has to be 2 here, otherwise it will not be 180, right? That's how you remember the formula. Cool. So in this case, it is a regular hexagon. So I have 6 sides. So it will be 180 into 4, that is 720, right? And if I have 6 sides, I will have 6 angles. So each angle will be basically 720 divided by 6, that is nothing but 120 degrees. So each angle would be 120 degrees. Cool. Each angle is 120 degrees. That is fine. Now what is the problem? This is 120 and okay, so all these are 120, right? All these are 120 angles. Okay, and this is also 6 centimeter. This is also 6 centimeter. So these two sides are same. If these two sides are same, these two angles has to be same, right? We know simple property of triangle. If the sides are same, angles has to be same. I hope you remember it for the same triangle. Again, here also this will be theta. This also will be theta. This also will be theta. This also will be theta. Now this whole angle is what? 120, right? And which is equals to what? Let me assume this as y. This will be y plus 2 theta equals to 120. Y plus 2 theta equals to 120, right? And do you observe all these triangles are congruent? So how do I congruent? So these two sides are same, these two angles are same, this angle is also same, right? Side angle, side angle, side. All these 3 triangles are congruent by side angle side. So that means this side also will be same. Now if all the sides of a triangle are same, that means these angles are also same. That is what? It is a equilateral triangle, that is 60 degree, 60 degree and 60 degree. So your theta comes out to be this 60, right? Y is 60 degree. So your theta comes out to be 30 degrees. So this is 30 degrees. We got to very good amount, because what do I have to calculate? I have to calculate the area of this triangle, right? For that I need to calculate the side. I need to compute the side. I am getting there. So this is 30 degrees. Now how will I solve it? Now what we know, this I have a triangle here, right? And this angle is 120. If I drop a perpendicular bisector, right, and this angle is same 30, this angle is also 30. So we know if it's a perpendicular bisector, this will be divided x by 2, this also will be x by 2. If this whole length is x, right? So all I am doing is I am taking this triangle and this is my x. So this will be x by 2, x by 2. This side I know, this is already 6 centimeter, this is already 6 centimeter. So this is 6, this is 6, right? We know, like, if I drop a perpendicular bisector, right, again you can use the angle, so side, this side, an angle. So angle, side angle, or side angle, side, right? So they will be again congruent, correct? If they're congruent, that means these two sides must also be same, correct? So okay, so that means this overall is x, and if these two sides are same, that means each of them will be x by 2 and x by 2. Cool. Now you can simply use trigonometry. So this will be 90, right? So trigonometry would be uh, cos of 30 would be equals to what? Would be equals to base upon the hypotenuse. So x by 2 upon the hypotenuse, that is 6. So that would be x by 12, and cos 30 is root 3 by 2. Root 3 by 2. So x would be equals to 6 root 3. So x is equals to 6 root 3. Now what you can do is, now what you need, this is a equilateral triangle and you have got one side. All you need to do is calculate the area of this triangle. Again we can use the same property, whatever I taught you just here. I can use the same property. Again, if I drop in a perpendicular bisector here, I know the side, although there is a formula, right? I know there is a formula and I know you know that, but still without the formula, if I want to do it, so this is 6 root 3, this is 6 root 3. It is an equilateral triangle. Again, this is a perpendicular bisector, so they will be divided equally. So this is also 6 root 3 actually, but as they are divided equally, this will be 3 root 3 and 3 root 3. Now I think it's pretty simple to calculate the area of the triangle. I don't know this side, right? Because I need, for area, what do I need? I need half into base into height. I do know what is base. Base is this 6 root 3. What is height? So again we can use the sine of this. So this angle is 60, right? It is an equilateral triangle. So this angle is 60. So sine 60 will be equals to height upon the hypotenuse, that is, let's say x upon, I'm assuming this to be x now, upon 6 root 3. Sine 60 is root 3 by 2. So this will be 6 will go there, 3 into 3, that is 9. So x would be equals to 9. So that is basically height would be equals to 9. So half into, this is 6 root 3 into 9, that is 3 root 3 into 9, that is 27 root 3. So 27 root 3 is your answer of the question that is present in option B. So option B is the correct answer for this question. The following pie chart shows hourly distribution in degrees. So hourly distribution in degrees of all the major activities of a student in a day. So these are all the activities of a student in a day. It is a distribution, hourly distribution, right? They have represented it in terms of degrees. If the time spent in game is equal to the time spent in homework, so time spent in game is equals to the time spent in homework, okay, in all other activities, and time spent in all other activities remains constant except sleeping, then percentage increase in time of sleeping would be equals to what? Okay, so what is the amount of sleeping here? What is the initial amount of sleeping? So theta sleeping, right? So overall this should be 360. So this is 45 plus 105, that is 150, right? 150 plus 60, that is 210, plus 60, that is 270. So remaining would be my 360, that is 90. This would be 90 degrees. So this is 90 degrees. Okay. Now uh, this is 90 degrees. So initially the sleeping period was 90 degrees, because obviously it will be proportional to the hours, and degree will be proportional to the hours, right? Because this represents the hourly distribution. Okay, initially it was 90 degrees. Now what are they telling me? If the time spent in game is equal to the time spent in homework, so time spent in game and homework are equal. So both of them are x now. So this is also x, this is also x. And time spent in all other activities remain constant except sleeping, right? So time spent in homework is how much? It is 45 degrees, right? Now it is equals to time spent in game is equals to, sorry, time spent in, sorry, what is the time spent in game? It is 60 degrees, right? 60 degrees is equal to the time spent in homework. So now they're telling me the new time spent in games should is equal to the time spent in homework previously. So I should mention in the question, this will be mentioned, don't worry, that when they're talking about the homework, they're talking about the previous time. They are talking about the previous time, right? This, so the student is changing the time spent in game, new time, to the previous time, right? Time spent in homework previously it was 45 degrees. Now time spent in game also will be 45 degrees only. So both of them will be 45 degrees, right? And all others are same, this and this are same. And time spent in all the other activities remain constant except sleeping. Okay, sleeping can change. So if there is a delta, what has changed? This is constant, games has reduced by 15, so obviously sleeping will increase by 15, right? Because this all has to add up to 360. So sleeping will now increase by 15, so it will now become 105. What are they asking? The percentage increase in the time of sleeping. So percentage increase would be the change, that is 15, upon the initial value, that is 90 degree, into 100 percentage. So 1 by 6 into 100 percentage, that is 16.67 percentage, that is option 4. So option 4 is the correct answer for this question. To do a work independently, B requires 6 more days than what A requires. So B requires 6 more days than what A requires. So what is the efficiency of B? It will be 1 by B. And what is the efficiency of A? It is 1 by A, where A is the number of days required to complete a particular work. So if I relate the efficiency of B with respect to A, it will be what? Because B requires 6 more days. How many days A requires? A. So B's efficiency would be 1 by A plus 6. Got it? So this is the first step. Now what are they asking me? If they are working together, it will take them 2 days less than what A requires alone. So if they are working together, right? So basically 1 by A plus 6 plus 1 by A, it will take them 2 days less. That is, what is the efficiency? It will be 1 by A minus 2. So per day efficiency would be 1 by A minus 2, because the work will be completed in A minus 2 days. Now what are they asking? B, now they are asking me what is, in how many days B alone can complete the work. Basically they are asking me this value, right? Okay, this is B value. So first let us solve this, and then we can find A, and then we can solve for B as well, because B is nothing but A plus 6. It's very simple work time problem. Okay, so so how to solve this? There is no other way than to solve and than to do cross multiply. Okay, uh, so let me multiply these things. This will be A plus 6 into A minus 2, and on the other side will be A into A plus 6. So this will be 2A plus 6, 2A plus 6 into A minus 2, that is A square plus 6A. So this will be 2A square, this will be 2A square minus 4A plus 6A minus 12 equals to A square plus 6A. 6A will be cancelled. Now what will happen? So this will be a square minus 4a. 6a has been cancelled. Okay, that these things will go on the others. Okay, this is correct only. A square minus 4a minus 12 equal to 0. So this will be my 4 plus minus b square minus 4ac. Okay, b square 16 minus 4ac, that is plus 48 by 2a minus b plus, yeah. Okay, so what will be this? This will be basically 64, right? So 4 plus minus 8. So of course it has to be 8 only, plus 8 only. It cannot be minus because a can, like days cannot be negative. So this will be 6 days. So a is equals to 6. So b will be equals to a plus 6, that is 6 plus 6, that is 12. Right? So option A is the correct answer of this question.
Yeah, so did you solve this question? Look, there are three perfect logicians or professional logicians. They are going into a bar and the bartender is asking them, do all three of you want a drink? So three guys are there and he is the bartender who asks them that, do all three of you want a drink? Okay, what he's saying? He's saying, I don't know. What does that mean? It means that yes, he wants a drink. Why is that so? What is the question? Do all three of you want a drink? That means this particular guy, if he was not wanting a drink, if he doesn't want a drink, then he would have simply said no. Did you understand this point? That he is asking all three of you want a drink or not? All three of you. If he knows that, sir, I don't want a drink, that means the answer would have been no. That all three of us don't want a drink. I don't know about these two, but surely I don't want a drink. What does that mean? That all three of you want a drink? No. That would have been the answer. But if he is saying that I don't know, what does that mean? That means yes, I want a drink, but I don't know about these two guys. Is that understandable to you? Three answer could have been there. Yes, no, I don't know. These three answer could have been there, right? If this particular guy did not want a drink, then his answer would have been no. Why is that so? Because he is asking, do all three of you want a drink? If he doesn't want a drink, that means all three combined doesn't want a drink. I don't know about these two, but if I don't want the drink, that means all three are not wanting the drink. Two of them wants the drink. It might happen that two of them wants the drink, but all three are not wanting the drink. Is that understandable to you? So his answer would have been no. If he doesn't want the drink, that means he is wanting the drink. Same goes for the other guy as well. Yes, he is also wanting the drink. He is also wanting the drink. And he is the perfect logician. That means he has already understood that yes, this guy wants a drink, this guy wants a drink. Then depending on his mindset that, sir, if I want a drink, then he would have said yes. If he doesn't want a drink, then he would have said no. That means this guy knows that these two guys want a drink. That means now it's up to him. Now it's up to him. If he wants a drink, then he would say yes. All the three guys are wanting the drink. If he doesn't want a drink, then he would say no. That all three doesn't want a drink. These two guys want a drink, but I don't want a drink. Is that understandable to you? So either yes or no. Is this logic clear to you? Three guys are there. Bartender is asking, all of you wanting a drink or not? All of you. So first one said that I don't know. That means I want a drink, but I don't know about these two guys. If he was not wanting the drink, what he would have said? He would have simply said no. No, all of us doesn't want a drink. What does that mean? That means two guys may be wanting the drink. I don't know about them, but surely I don't want a drink. Then he would have said no. But he is saying I don't know. What does that mean? If he is saying I don't know, that means he is not sure about these two guys. At least he wants a drink for sure. Same goes for the other one as well. Now the last one would either say yes or no because he knows that these two guys are wanting the drink. Is that understandable? Okay. So this was a good question, and sir, Why would you frame this kind of question in aptitude? Yes, these kind of questions are asked, not in this manner. We guys are engineer, right? If someone would have been there from class 11th, 12th or class 10th class guy, then I would not be asking this particular question. First, I thought that I should be putting coffee here, but we guys are engineers, so I know about you. Okay, so drink would work for you. So yes or no would have been the answer. I hope it is clear to you. Let's go to the next one. Yeah, so this was a very good question. Hardly, I guess, 3 to 4 people would be able to answer it. Like people will be comfortable with this option, but they will be struggling here. So let's first prove the first two options which was there in our class notes only and would have been there in all the class notes, right? Because this is very standard thing that if your xt is real, if your xt is a real valued signal, what does that mean? If xt is real valued signal, then what about the phase spectrum? Phase spectrum would be, sorry, not phase spectrum, magnitude spectrum. Magnitude spectrum would be even. And what about the phase spectrum? Whatever the angle you get at positive frequency plus whatever the angle that you get at negative frequency, both should be even multiple of pi, or you should say multiple of 2 pi. Both should be, addition of both of the angles should be multiple of 2 pi, or you can call it even multiple of pi, right? This is the scenario. Some people remember it that they will simply put it equals to 0. Then they will say that, sir, magnitude spectrum would be even, but angle spectrum should be, phase spectrum should be odd. That is absolutely baseless. Why is that so? 90 degree minus 90 degree. You would say, sir, it is a odd spectrum, right? It is a odd spectrum. But what if 90 degree minus 90 would be written as 270 degree? Is it looking like odd? Would you call it odd spectrum? But it is actually odd only because 90 and minus 90. That's why we should never say that phase spectrum is odd. This statement is baseless. Phase spectrum is odd. This doesn't make any sense. What we should say? Let us say this was omega 1, so this would have been minus omega 1. This is omega 1, this would have been minus omega 1. So whatever the angle that you are getting at the positive frequency plus whatever the angle that you are getting at the negative frequency, if you add both of them, what you are getting? 360 degree. If you add both of them, what you are getting? 0 degree. Is it a odd multiple of, is it a even multiple of pi? Yes. Is it a even multiple of pi? Yes. In place of n, you put 0. This is something you will be getting. In place of n, you put 1. This is something you will be getting. That means, yes, it can work for real signal. Is that understandable to you? So, saying that phase spectrum is even or odd, that doesn't make any sense. In a lot of notes, I have seen this particular thing. Okay. They write down that phase spectrum would be even or odd. That doesn't make any sense. This is how we should remember it. Angle at positive frequency plus angle at negative frequency should be equal to 2 and pi. Although that even odd theory will work here. Right? This is even and this is odd. This is even, this is odd. So, both of the options would be correct. But ideally, we should check that at this particular frequency, at positive frequency, whatever the angle I am getting, at the negative frequency, I am just getting the negative angle of that. Let's just say at this is your omega 1, this is your minus omega 1. So at omega 1, I am getting, at omega 1, let's just say I am getting angle 70. So, sorry, minus 70. Then this angle would have been plus 70. So minus 70 plus 70 would have been 0 degree angle, which is a even multiple of pi. Right? So this option would be correct. Same goes for this option as well. This option would also be correct. Because here, let's just say at omega equals to 1. And here omega equals to minus 1. So here the angle I am getting is minus 3. And here angle I am getting is plus 3. So plus 3 minus 3, what that would be? That would be 0. So that would also work. Right? So this option and this option, both of the options would be working. That means these two options are correct. This option is correct and this option is correct. What about these guys? Sir, real part of x of omega, imaginary part of x of omega. Sir, what it is? So x of omega is written as real part of x of omega plus j imaginary part of x of omega. Do you understand this point? Surely you understand this point. If your x of t is real, then what would be the scenario? This would be the scenario that x of t should be equal to x conjugate t, or you can say that x of omega would be equal to x conjugate minus omega. Now if this is x of omega, then what would be x conjugate omega? Just take the conjugate of this. That means conjugate of this. What will be the conjugate of j? That would be minus j. What will be the conjugate here? This will be the conjugate. What will be x conjugate minus omega? X real conjugate minus omega minus j x imaginary conjugate minus omega. This is equation 1. This is equation 2. Both should be equal. If xt is real, if xt is real. Did you understand this point? I am just taking the conjugate. That means this quantity could also, like basically, I am taking the conjugate of this. plus plus j would be replaced as minus j and then taking the conjugate of this. But the thing is that this is the real part, this is the imaginary part. Both will be real quantity only, no? 3 plus 2j. Is it a complex number? Yes. This is the real part. Yes. This is the imaginary part. Real part is 3 and imaginary part is 2. So real part is also real and imaginary part is also real only. So this will be real only. Although x conjugate of this conjugate will not make any sense. But still let's put it there. Okay. Although this conjugate will not make any sense, but let's just put it there. Now if your xt is real, that means equation 1 would be equal to equation 2. What does that mean? That means x real of omega should be equal to x real conjugate of minus omega and x imaginary of omega should be equal to x imaginary conjugate minus omega, and then there is a negative sign as well. Just compare negative sign as well. So these two conditions should be satisfied if your xt is real. So imaginary part, is there any meaning of conjugate? No. So imaginary part should be even. Sorry, real part should be even. Real part even. There is no meaning of this conjugate sign because this value will also be real and this value will also be real only. Because this is the real part, this is the imaginary part. So they have to be real, no? I just gave this example, 3 plus 2j. So this is real, this is also real. Right? So what does that mean? There is no meaning of this conjugate. So can I say that real part has to be even? Because x r of omega should be equal to x r of minus omega and imaginary part has to be odd. You are not going to mug it up. In this manner you are going to derive in the examination. So this case we are getting for xt equals to real. Who knows, they may ask xt equals to imaginary. Then will you again mug it up? With this also you will mug it up. Then for even odd also you remember some results. So nothing we are going to mug up. In this manner we are going to derive in the examination. Okay. Who knows, I am asking something, they can ask something else as well. So you should have the aptitude that sir, I will be able to write down x of omega, x conjugate of omega, x conjugate of minus omega, and in that manner I will be able to solve it. So this real part has to be even and the imaginary part has to be odd. This is real, sorry, this is even, this is also even. Not correct. This is even, this is neither even nor odd. So this is also not correct. Is it even or odd? No, this is neither even nor odd. Don't get confused with this 2 pi. People will be thinking in the direction of angle. This is not the angle, this is the magnitude. Okay. This is 2 pi, not the angle. What is the angle? Here, what is the angle provided? Minus 180 degree. Here, what is the angle provided? 0 degree. Right. So basically, positive means 0 degree angle. Negative means minus 180 degree angle. Right. Or plus 180 degree angle. So don't think about the angle. Just simply we have concluded this particular thing that real part has to be even and imaginary part has to be odd. So both are not correct. Only these two options are correct. If I wanted to make it real, then what would have been the scenario here? That this should be somewhat like this. Imaginary part should have been somewhat like this. If this is the scenario, then your job would be done. Say yes or no. Right? If this is the scenario, then your job would be done because this part is now odd. So this would have been real. But here, this is the scenario. Well and good. I hope you have understood. You have understood something new here. Let's go to the next one. Yeah, separation between the quasi-Fermi levels of electron and hole is 10 kT, which is very straightforward. I don't need to make the diagram, but still I am making it. Conduction band is there, valence band is there, intrinsic Fermi level will be somewhere in between. EFI would be somewhere in between. Quasi-Fermi levels are there, so this would have been my EFN and this would have been my EFP. This would have been EFN, this would have been EFP. What this is your EFI. What is this gap and what is this gap? This total gap is given as 10 kT. This total gap is given as 10 kT. Can you let him know? Let's just say this is x, this is y. What is x? X is nothing but kT ln number of electrons divided by Ni. What is y? Y is nothing but kT ln number of holes divided by Ni. X plus y equals to 10 kT. So what you are getting? KT ln addition of both of them, ln x plus ln y. So ln x into y, 10 kT. So kT get cancelled out. Np is coming out to be, sorry, this would become Ni square, no? Multiply of both of them. N into P divided by Ni square. So this is becoming Ni square e to the power 10. There you go. Very straightforward question. Ni square into e to the power 10. That's the answer. Let's go to the next one. What about this question? Sir, initially capacitors are shorted, no initial voltage is there. Initially means at t equals to minus infinity. I'm talking about at t equals to minus infinity. In the capacitors are shorted, no initial voltage is there. 15 voltage will be applied at t equals to minus infinity. What does that mean? Sir, here there is 0 voltage if I apply the open circuit test, and here there is 15 volt. That means this diode would be turning on. If the diode is turning on, then what will be the circuit? You know the circuit, but what I need to care about? I need to care about the circuit at t equals to 0 minus. At t equals to 0 minus, what will happen? So steady state would be reached. In the steady state, capacitor will be open circuited. If the capacitors are open circuited, let's just say this voltage is V1 and this voltage is V2. So what will be the V1 V2 voltage? So V1 voltage would have been, sir, 40 divided by 40 plus 20 plus 15, or that would be 75, right? Into whatever the voltage was applied, 15. So 8 volt. And what would have been V2? This is simply the half of the resistance, so it would come out to be 4 volt. Now at t greater than 0, for t greater than 0, at t equals to 0 plus, what will happen? Sir, this is having 8 voltage, this is having 8 voltage, and sir, this guy is having, arey bhai, 4 volt. That means, sir, here 8 volt, 4 volt, here total voltage is 12 volt. But sir, what is the voltage applied? 3 volt is applied here. What does that mean? This will be turning off. Right? Open circuit test I am applying. Open circuit test I am applying. That means no current will be flowing here. So there will not be any drop across to 15 kilo ohm. So 12 volt here, 3 volt here. This will be turning off. If it is turning off, then what will be the circuit? R, C, 4 volt initial charge, R, C, 8 volt initial charge. So this kind of circuit you would see, right? This capacitor is 5 microfarad, 5 microfarad. Both are same capacitance. So 5 microfarad, 5 microfarad. What is the resistance? R to R. So 20 kilo and 40 kilo. This is the scenario. This is charged to 4 volt, other one is charged to 8 volt. This is charged to 4 volt, other one is charged to 8 volt. Now see this circuit. Now what will happen? This 4 volt will be discharging. How it will be discharging? If from this capacitor I current is flowing, so this current will also be I. This current will also be I. If in this branch I current is flowing, so this current also has to be I. This current also has to be I. If in this branch this current is I, so this current also has to be I. What does that mean? In the whole loop I current is flowing. What did I say? From this capacitor if I current is going, then this current also has to be I. Both branches are in series, so this current also has to be I. This is also I, this is also I, and this is also I. So in the whole branch I current is flowing. That means this capacitor is getting discharged through this 20 kilo ohm resistance only. What about this capacitance? From here there is no current coming. If this current is I, this current is also 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 I. That means in the whole loop I current is flowing. So this capacitor, C capacitor, is discharging through 40 kilo ohm, and this C capacitor is discharging through 20 kilo ohm. Is that understandable to you or not? And what is your output voltage? This is my output voltage V naught T. So I need to write down V naught T. What will be the expression of V naught T? This capacitor is discharging through 20 kilo ohm. What does that mean? This 4 voltage will be discharging. 4 voltage will be discharging completely. So 4 e to the power minus t by 2. What will be the time constant? At 150 millisecond I need to find out. So 100 millisecond. Plus 8 volt will be discharging. 8 e to the power minus t by 2. So 200 millisecond. Now I just need to find it out at 150 millisecond. So just put the values, I will get the answer. So 150 divided by 100, that would become 1.5. So 1.5, and then calculation we need to do 1.5 plus minus e to the power into 4 plus bracket on. This would become 150 divided by 200. What that would be? 1.5 by 2. So that would be 0.75. So 0.75 plus minus e to the power 0.75 into 8. Then bracket close. 4.67. You are getting 4.67 volt. There you go. So is there any option? Yes, sir. This is the correct answer. So this was the only good thing here, that this capacitor will be discharging through this resistance only, and this capacitor will be discharging through this resistance only. So it will become a first order circuit, not the second order circuit. Okay, then let's go to the next one. Yeah, what about this one? Were you able to solve this one? Look, it is not tough if you just read it out. What this block is doing, what this F block is doing. This F block is taking the input and calculating its Fourier transform, then inverting it, multiplying with 2 pi, and then omega is put as t. This is what it is doing. Are you able to understand this point? Take its Fourier transform, What is the Fourier transform of x of t? That is x of omega. So take its Fourier transform, then invert it, and in place of omega put t, and then multiply the result with 2 pi. This is what this block is doing. Now this particular input 2 pi x of minus t, 2 pi capital X of minus t is going as the input to this f block. So what it will do? First it will take its Fourier transform. So do I know the Fourier transform of capital X of minus t? It is not the small x, it is the capital X. So do I know the duality property? If this guy comes here, what will happen? This omega is replaced as t. Then what will be its Fourier transform? 2 pi x of minus omega. What will be the Fourier transform of x of minus t? So that would be 2 pi x of plus omega, right? If here minus t you are putting, here also minus sign you need to put. And what will be the Fourier transform of small x of minus t? That will be capital X of minus omega. Now what it will do? Whatever the input is there, take its Fourier transform. What will be the Fourier transform of this one? Sir, 2 pi as it is. X of minus t is having a Fourier transform of 2 pi x of omega. So 2 pi square it would become x of omega. X of omega. In place of omega you need to put minus omega, and then in place of omega you need to put t. Is that understandable to you? Take the Fourier transform. What will be the Fourier transform of 2 pi x of minus t? If x of minus t is having this Fourier transform, then what will be the Fourier transform of x of minus t? So that would be 4 pi square x of omega. Just multiply with 2 pi here, multiply with 2 pi here. So this is what we are doing, 4 pi square, sorry, small x of minus omega, small x of minus omega. Small x of omega, small x of omega. But what this is doing, whatever the Fourier transform you are getting, it is putting the negative sign. So putting the negative sign, then omega is replaced with t. Omega is replaced with t. So this is the output we are getting, and then whatever the scenario you are getting, that will be multiplied with 2 pi as well. Fourier transform of this one, in place of omega you are putting minus t, then multiply with 2 pi. So as of now the scenario is that I am getting 8 pi cube x of minus t. Now it will be again fed to f. It will be again fed to f. What is fed? 8 pi cube x of minus t. Say yes or no. Now x of minus t will be having a Fourier transform of capital X of minus omega, and this 8 pi cube is constant value, so 8 pi cube would come. X of minus t will have a Fourier transform of capital X of minus omega, capital X of minus omega. But in place of omega, what I need to put? Minus t I need to put. So here what I will be getting? Plus t. In place of omega I was putting minus omega, so here in place of minus omega I will put plus omega, and then in place of omega I will put t. So this is what I have done. Along with that, I need to multiply with 2 pi as well, right? Because this is multiplying the result with 2 pi as well. So what we are getting? 16 pi to the power 4 x of t. There you go. So this is the answer. Okay, so I just wanted to check the duality property. For checking the duality property, this question has been framed. Okay, you just need to know the Fourier transform of capital X of t. If you know this particular thing, then this question was cake for you. But you just need to think here that what this particular block is doing. Whatever this block was doing, just keep on writing it down and you will be able to get the answer. Okay, again a good question. Hardly 10 people will be able to solve it. Let's go to the next one. Like very straightforward. Everyone should be able to solve this one. Okay, everyone should be able to solve. Here you are applying 10 volt, 2 milliampere current you are getting. What is this voltage? Simply you can see that, sir, here I am voltage conversion I can do. So this was my network. Here I am applying 5 milliampere into 1 kilo ohm. What I will be getting? Resistance of 1 kilo ohm and battery of 5 volt. So 5 volt, 1 kilo ohm. And this is the scenario. Load is also the same. 500 ohm and 500 ohm. So this is 1 kilo ohm load only. So only thing that has changed is this 10 volt has become 5 volt. So if this has become 5 volt, then this response would have been becoming 1 milliampere. So here how much current would be flowing? Here how much current would have been flowing? 1 milliampere. Now this 1 milliampere will be flowing here as well. 1 milliampere current will be flowing here as well. So what will be the value of Vx? Vx value will be 500 ohm into 1 milliampere, that would be 10 to the power minus 3. So what will be the answer? 0.50 volt. Very simple thing, right? 10 volt, 2 milliampere, 5 volt, 1 milliampere. 1 milliampere will be flowing through this 500 ohm. So answer would be 0.50 volt. If you were not able to solve it, that means you lack problem solving skills. You need to solve more and more problems. Okay? Otherwise, this should have been solved. Let's go to the next one. Yeah, so in your examination, this was MSQ. But only one option is correct here. So, sir, does this happen? Yes. In the gate examination, a lot of times, like in 4 to 5 questions, this has happened that the question is MSQ, but only one option was correct. Okay, it feels like that, sir. Here, one of the SNR option would have also have been correct, no, but only one option is correct. Okay, so what is there? FM value is given 6 kilohertz. Nyquist rate 25% higher than the, sorry, sampling frequency is 25% higher than the Nyquist rate. That means it is 1.25 times of Nyquist rate. What is Nyquist rate? That is 2 FM. So what I will be getting? 2.5 FM here. So 2.5 FM, 6 kilohertz. So 15 kilo samples per second. This is the value of fs I am getting. What is the value of a bit rate? So just we need to notice that if they talked about the sampler or not, like it could be parallel out or parallel in serial out. So if they are not talking about it, then simple formula. If they are not talking about it, then simple formula RB equals to NFS. So 10 into 15 kilo. So bit rate would be 15 kilo bits per second. This will be your bit rate. Okay, 150 kilobits per second. Okay, so this is the bit rate. What about the SNR? Since the input is sinusoid, so I can directly apply the formula 6.02 n plus 1.76. So number of bits are 10. So 60.2 plus 1.76. What that would be? 61.96 dB. So this would be the SNR. This option is not there. This option is also not there. This option is also not there. So this would be the answer only, but it was a MSQ. Only one option is correct. Okay then, well and good. It was very simple question only. Let's go to the next one. Yeah, let's see the solution of this one. What we need to find out? Probability of symbol error. What is the formula? Q of under root ED by 2n naught. But this is for single channel. If there are 4 channels, here there is written there are 4 IID AWGN channel. So what will be the formula become? Under root 4 ED by 2n naught, right? Along with that, there is a oscillator is having a phase offset as well. From between the transmitter and the receiver, there is a phase offset of theta. So what will be the formula becoming? These are very standard, right? Very standard block it is. In the gate examination as well, 2 times question have been asked. So for those standard blocks, we have developed the formulas. So this is the formula that we got. So this we have already seen. Surely if you did not study from here, then also in your class notes as well, this would have been there. For K channel, it would be K ED by 2n naught, and then there is an offset of theta. So here cos square theta you will be multiplying, right? So this is the scenario. Now what is the value of theta? 45 degree. So what you will see is that Q of under root 4 ED by 2n naught, cos 45 will be 1 by under root 2, so this will be 1 by 2. So answer would come out to be Q of under root ED by n naught. This is the scenario, right? This is the answer we are getting. 4 of this 4 and 4 getting cancelled out, ED by n naught. Now what will be my difference signal? Difference signal will simply be difference of these two. So let's just call this as A. So this will be minus A. So both will be simply added, right? So it will become 2 under root 2 EB by TB cos 2 pi FCT between 0 to TB, right? This is your difference signal. Can you find out its energy? Yes, sir. What will be its energy? That will be your ED. That would be this square by 2. So what will be the square of this? 4 into square of this would be, this is your amplitude square. So 4 into 2 EB by TB divided by 2, multiply with the width TB. So what will happen? TB get cancelled out, 2 and 2 get cancelled out. What is the answer you are getting? 4 EB, right? 2 and 2 is getting cancelled out, TB getting cancelled out. So 4 EB answer you are getting. So what is the probability of symbol error you are getting? Sir, under root 4 EB by n naught. 4 EB by n naught. What is the value of EB by n naught? EB by n naught is 8. Just go step by step. If you remember any other formula, just only one formula you need to remember, that's it. After that, it is signal system. Find out the difference. Find out the difference signal. This is the difference signal. Can I find out this energy? Yes. Can I put it here? Yes. 4 channels are there, multiply with 4. Along with that, there is an offset as well between the transmitter and the receiver oscillator. Then just simply multiply with cos square theta as well. All job done. Just go step by step. What we are getting? Q of under root 32. What is under root 32? 16 into 2, right? So 4 under root 2. There you go. That's it. Very straightforward. Just go step by step, like sir, all this theory and everything. So this is the standard receiver block. You can read it. Symbols are equally likely. If equally likely symbols are there, then I can apply this formula. If equally likely symbol is not there, then you cannot apply this formula. Then you have to go by the method. Complete block you have to solve. That also we have seen in our class notes, right? But although I'm not framing this kind of question in a test series, right? Otherwise, like it will be very tough to solve. But in the class notes we have solved. At the receiver, the signal from each channel is processed using a correlator based receiver. Meshed filter is there. Then there is a local oscillator which is having a phase offset. So very standard block is there. Till this date in the examination, in gate examination, always the question has come from standard block with both of the symbols are having equal probabilities. But who knows, in the examination they can change the probabilities as well. But we will be able to solve it by the method that we have studied in the class. But they will very rare chances are there that they will change the probabilities. Why is that so? Because it will be very lengthy. It will be very lengthy to solve. Okay. So yeah, answer of this question would be q function of 4 under root 2. Let's go to the next. This one again very straightforward. What you need to find out? You need to find out the voltage gain and R out. So what will be the small signal voltage gain? First, what will happen? This will be gone, right? If this is gone, then let me know one thing. How much input current this would drive? 0 ampere. How much current would be here? 0 ampere. How much current would be here? 0 ampere. From the upper side, this is gone. Like the circuit is somewhat like this. This is the scenario. Here V is connected, and then this is the scenario. From downward, 0 ampere current is coming. R naught is infinity only. It is given in the question. So if this current is 0 ampere, so how much current would be flowing here? 0 ampere current. Say yes or no. So here how much current is flowing? 0 ampere. Now if this is V in, this node is V in, and this node is V naught. This node is V in, this node is V naught. So how much current this MOS should be driving? So this MOS would be driving small signal current of GM V in minus V naught. Right? This is driving GM V in minus V naught. So GM V in minus V naught current it is driving, that is equals to 0 ampere. What does that mean? V naught equals to V. So what is the gain? Gain is 1. What about R out? Sir, for finding out R out, what we need to do? This V in has to be shorted. Rest all the circuit will be remaining same. If V in is shorted, then what will be the value of V naught? 0 only. Because V out is equal to V in. If V in is gone, rest nothing changed, only V in is shorted. If I need to find out R out, then what will be my R out? Sir, R out will simply be V out by I out. Sir, forget about I out or anything. I just got to know that if V in is 0, V out is also coming 0. So this is 0. I don't care about I naught. What is the answer I am getting? 0. So R out is 0 and voltage gain is 1. That's it. Right? This is a standard circuit, but you don't need to remember the name of this particular circuit, but this is a standard circuit. These kind of standard circuit can come in the examination. 0 current. So this is also 0 ampere current. That means V in has to be equals to V naught. What is the gain you are getting? 1. R out you need to find out. If this is 0, what does that mean? If this is 0, then this also has to be 0. If this is 0, that means R out has to be 0 only. There you go. Very straightforward answer. Okay, let's go to the next one. Again, very straightforward question. What is the input impedance? Infinity. What is the output impedance? For ideal op amp, input impedance is infinity. Output impedance is 0. This is wrong. No current would flow. Input currents and everything are 0 only, because if this is infinity, then that means current would be 0 only. So this is also correct. No open loop, the open loop gain is infinity. Yes, open loop gain is infinity. That is also correct. Bandwidth is also infinity. Yes, for the complete bandwidth, it would give the gain of A only, or that is actually very high. So this is also correct. And what about the slew rate? Output should be changing immediately. That means slew rate would be infinity. Okay. So what is the slew rate? Slew rate is infinity, which is given as 0. So this is also wrong. So what is the correct answer? 1, 3, 4, and 5. These are the correct options. Okay. Let's go to the next one.
Find the power delivered in watts to 20 ohms resistor connected across port 2 if Z parameters of the network is given. Right, so basically the Z parameters of the network is given, and in the port 2 20 ohm resistor is connected, and they are just simply asking me what is the power delivered to this particular 20 ohm resistor. So simply what are they asking? They are asking me P, that is equals to 20 into I2 square. Now here remember, what is the direction of current? I don't know. So here they are telling me the direction of current is this, right? This is the direction of current, right? I2. So this will be plus minus because current always enters the positive terminal for a resistor. Current always enters the positive terminal for a resistor, right? Because resistor can only absorb power, it can never deliver power. Great. So for that I need to calculate I2. So let's do that. So they have given me the Z parameters. So Z parameters are nothing but the like voltage equation. So V1 will be equals to Z11 into I1, that is 40 into I1 plus 60 into I2, and V2 would be 80 into I1 plus 100 into I2. Okay, that is your V1 and V2. Now okay, that is my V1 and V2. Now few more things, right? If I write the KVL equation at the output side, what is the KVL equation in the output side? So this will be minus, I use my KVL equation, you can use your own convention, right? Minus of V2. Then again I observe a negative sign, right? This is a negative sign. So when I rotate in the clockwise direction, whichever sign I observe first, that I write. So minus V2, again I observe a negative sign. So minus into 20 into I2. Correct? So because this is my I2 current direction. So this I2 current direction is with accordance to my port parameters. If you remember, the port currents are always entering into the port. So this will be equals to 0. So from here I get the value V2 is equals to minus 20 I2. You don't need to use that much of brain. Anyways, you can see, right? This is plus minus and this is just opposite. So anyways, it will be negative. But if you want to understand it properly without any confusion, yes, write the KVL equation. So V2 is equals to minus 20 I2. And what about the input side? If I write the KVL equation in the input side, so this is the direction of current in the input side. So this will be plus minus 10 I1. So this will be minus 20 plus 10 I1 plus V1 equal to 0. So V1 equals to 20 minus 10 I1. That is my V1 value. V1, V2 I got. So simply I can use it, right? Because ultimately I need to find out the value of I2. For finding out the value of I2, I need to replace these equations. I will be able to calculate that. So it's just simple equation manipulation. That's it. Here, if I see some things, okay, yeah. So let me first replace this part. Let me replace here. So that would be minus 20 I2 equals to this, and so basically, right, this will be basically minus 120 I2 equals to 80 I1. So from here my I2 value is actually equals to minus 2 by 3 I1. Correct? Okay. So this can be again I can replace the V1 here. This would be 20 minus 10 I1 equals to 40 into I1, and your I2 is equals to minus 2 by 3 of I1. So this will be 60 into minus 2 by 3, that is, so 20 into 2 I1. So from here this will go down to 0. So I1 would be equals to 2 amperes. This will be the answer. I1 is equals to 2 ampere. This is the answer for your question, right? So I1 is 2 amperes. What is I2? So I2 is minus 2 by 3 into 2, that is minus 4 by 3 amperes. That is your I2 current, right? I1 is 2 amperes, I2 is minus 4 by 3 amperes. Got it? I1, I2. So we know I2 value, right? It is negative. What does negative means? Basically, if it is negative, that basically means your initially assumed direction of current is wrong. actual direction of current is this. In our case, it does not matter because we are doing I2 square. Got it? If they would have asked some other parameter which involves the sign, then things would have changed. In our case, it is very simple. All we need to do is 20 into I2 whole square, that is minus 4 by 3 whole square. So if I calculate this value, that is 1.77 into 20, that is 35.55 watt. This is the I2, so this is the power delivered to the 20 ohm resistor. This is your answer for the question. In a series RLC circuit with R equals to 20 ohm. So it's a series RLC circuit where they have given me that the value of R is 20 ohms. This value is 20 ohms. That is fine. And the circuit current, sorry, actually this should be different. The current in the circuit lags behind the applied voltage by 30 degrees. This circuit should not be there actually. Okay, this circuit should not be there. I will remove it. The current in the circuit lags behind the applied voltage by 30 degrees. So the voltage bit, so of course in a series RLC circuit we apply the voltage and we assume the voltage to be the reference. Sorry, we assume the current to be the reference actually, because the current is same throughout, and they are telling me that the current lags the voltage by 30 degrees. So voltage would be somewhere here because it will lead, because current lags the voltage by 30 degrees, right? Lag basically means in the clockwise direction. And if the current lags the voltage, overall the circuit behaves as inductive. Overall the circuit behaves as inductive. So circuit behaves as inductive. We got a lot of information. So in a series RLC circuit, if the circuit behaves as inductive, we know that your XL will be greater than XC. Correct? XL will be greater than XC because the circuit behaves as inductive. The inductive reactance will be more than the capacitive reactance. Okay, and also they have given me the instantaneous voltage drop across the inductor. Okay, the maximum inductance voltage is twice the maximum capacitance voltage. Do you understand what it means? Basically, the peak value of the inductor voltage, right, is twice the peak value of the capacitor voltage. What will be these values? So what will be the peak value of the inductor voltage? It will be simply peak value of the current into the reactance, isn't it? And here it will be the peak value of the current into the capacitive reactance, right? Because like of course VL will be measured across this and your VC would be measured across this, and this will provide a reactance of XC, this will provide a reactance of XL. So yeah, and of course there is a 2 here, don't forget there is a 2, right? 2 into IP into XC, that's all. So of course your IP will be cancelled because the peak value, it is a series circuit, right? The peak value will be same, so IP will be cancelled. So from here we got another information that our XL is 2 times XC, right? And this ratio, right, this, sorry, not ratio, this angle 30 degree, do you know what is this? So this is the angle between the voltage and current. So this is nothing but the impedance angle, right? If you remember, this is nothing but the impedance angle. How do I compute the impedance angle? So how do I compute the impedance? Right, impedance Z, that is equals to what? That is equals to V by I, right? If I see the voltage from here and measure the current from here, the ratio of these two will give me impedance. So V is V angle 0 and I is minus 30, I angle minus 30. I don't know the magnitude of current, but certainly I know the angle. They have told me that the current lags the voltage by 30, so that's why minus 30. So this will be magnitude of V by magnitude of I into angle of plus 30. So this plus 30 is nothing but the impedance angle, right? So impedance angle theta z is equals to what? Do you remember what is it equals to? So if I what is, if I write the Z equivalent, right, impedance, that is equals to R plus J into XL minus XC, because impedance, because inductive reactance is positive, that is the reference, and capacitive reactance is negative, right, XL minus XC. So it is equals to R plus J XL minus XC. So what is the angle here? How do I compute the angle? It is very easy, right? Tan inverse XL, the imaginary part, upon the real part. So yeah, theta z is 30, right? So I can take the tan on both sides. So tan 30 would be equals to XL minus XC divided by R. So tan 30 is equals to 1 by root 3. That is equals to XL minus XC. Okay, so XL is 2 times XC. So this will be 2XC minus XC divided by R. R is 20 ohms. Right, so from here we can actually get the value of XC, but what have they asked? They have asked me the value of L and C, right? Both L and C. So XC I can get, XC value I can get certainly. XC would be equals to 20 upon root 3 ohms. But they have not asked me what is the value of XC. They have asked me what is the value of C. And we know XC is equals to 1 by omega C. So what is omega? Omega can be found from here, right? Sin omega t. Because we know if I am applying an input sinusoidal frequency, the frequency won't change, the phase of the voltage can change, certainly it can change, right? But the frequency would remain same. Frequency would remain same. So frequency is 377 radian per second. Always remember this is actually omega into t, right? Where omega is in radian per second in this particular equation. So here C value would be 377. Okay, so this value would be 20 into 377 into root 3. Okay, so this will be around 230 micro, right? 230 microfarad. So C value is 230, that is present in option A and option D. What about the L value? Again, right? So we know this. Our XL is twice the XC. So XC is this value. But about our XL? XL would be this. Twice this, that is 2 into 20 by root 3. And that is equals to 40 divided by root 3. So this will be equals to 2 into pi into F. Okay, omega into L basically, right? XL is omega into L. Omega is 337, right? That 337 is nothing but 2 pi F. Okay, so L would be what? This would be 40 upon root 3 into 1 by 377. Okay, so 377, where did it go? Okay, it automatically got, okay, something gone away. So let me calculate this. 40 divided by 377 divided by root 3. So this would be 61.25 millihenry. Okay, almost near about the option D, right? Of course, very close. So this would be my answer, right? Option D would be my answer, very close to option D. So option D is the answer, option A is not the answer. So yeah, that's how you will solve this question. So I can solve this in 1 minute as well, right? I have to explain all this, that's why I am taking more time. But you know, like there is this phase angle difference, all these things are there. You will directly arrive at this formula. You will directly use this, right? And from there you will directly find out XC and XL, because you will also know this, right? This thing. So mainly you will use this formula, and then you will derive the relations, and after that you know what is the omega, and you will use that. Right? That's how you solve this question. So for this question, the answer is option D.
The threshold voltage, how it will be depending on oxide thickness and doping concentration, right? So what is the formula of threshold voltage? So sir, the voltage would be going into oxide as well and the surface potential as well. What is surface potential? So surface potential is nothing but 2 kT ln Na by Ni, twice of Fermi potential, right? Now what about the oxide potential? Sir, oxide potential would be nothing but depletion charge divided by COx, right? Now what will be the depletion charge? Sir, QNA XD could be written as 2 epsilon Si. Either you directly remember the formula or you can derive it in this manner as well, because memory doesn't work in the examination hall. In the examination hall you will be blank. So rather than mugging up the formula, I always believe that at least these kind of formulas we are not going to mug up. We can easily derive it in the examination. Very easily we can derive it in this manner. 2 epsilon Si QNA phi s. So a lot of people remember this particular scenario, but I prefer deriving it. From here I can write down the threshold voltage considering body effect as well, right? So this gamma value will not be very tough for me to remember. All these things we have discussed in the class notes. So epsilon OX, what that would be? Epsilon OX will be nothing but COX, oxide capacitance would be nothing but epsilon OX dot TOX plus phi s. Now what they are saying, the threshold value of a MOS capacitor will be decreasing with the increase or decrease in the gate oxide thickness. Threshold voltage is decreasing. So if this guy is decreasing, then this will also decrease. That means here decrease will come. The threshold voltage of MOS capacitor decreases with the decrease in oxide thickness. So if oxide thickness decreases, threshold voltage decreases. If your doping concentration decreases, if doping concentration decreases, then this value will decrease, this value will also decrease, so this will also decrease. So if doping concentration decreases, so here also decreases would come, and here also decreases would come. So if doping concentration decreases, then threshold voltage decreases. If your oxide thickness decreases, then threshold voltage decreases. Understandable? Very straightforward. Let's go to the next one. Yeah, so find out the percentage of incident photon energy that is transmitted through the slab. Okay, so what is the scenario? We are talking about the intensity. It will be proportional to the energy only. So let's talk about the intensity. So intensity decreases in this manner, right? So at z equals to 0, this was the intensity. When you are working, what is the absorption coefficient? That is 10 to the power 3 centimeter inverse. So when you have worked for 5 micrometer thickness, 5 micrometer, that means 5 into 10 power minus 4 centimeter. So when you have worked for 5 micrometer thickness, then what will be the intensity that will be left? So that will be left as e to the power minus 0.5. So 0.5 plus minus. So this is coming out to be, Ix is coming out to be 0.6065 I naught. What does that mean? That means we started, this was our semiconductor which was having a length of 5 micrometer. Here the intensity was I naught. So how much intensity is getting out? This much intensity is getting out. So what they are asking? Determine the percentage of incident photon energy that is being transmitted. So how much energy is being transmitted? 60.65% energy is being transmitted. Okay, intensity, energy proportional to each other, right? So 60.65 percentage intensity is being transmitted. How much is eaten up? How much is absorbed? So how much is absorbed? That is 39.35% absorbed, and this much is transmitted. Okay, straightforward question it was. Here in this particular question paper, tougher question was very tough, and moderate was moderate only, and easy was easy only. This kind of question paper I have set up, and in the final examination as well, this kind of question paper would only come. So whatever the question paper, whatever the questions that are easy, that you need to get correct. Okay, let's go to the next. So we need to avoid the setup violation. So what equation we need to write down? That sir, T clock should be greater than or equals to starting from here. Like, can you go from flope 1 to flope 2? Yes. Can you come from flope 2 to flope 1? No. That means I'm going from flope 1 to flope 2. So T clock should be greater than, start from the clock, 2 nanosecond. What is the delay here? 3 nanosecond, then 2 nanosecond, 3 nanosecond, then delay is 2 nanosecond, then this buffer is having delay of 2 nanosecond, and then when I come here, I will add up the setup time. What is the setup time? Setup time is 4 nanosecond minus the skew. So there is no skew. So sir, answer would be 3 plus 2, 5, 7, 11. 11 nanosecond will be the answer. There is no skew. This is negatively triggered, no? This bubble can be replaced with the inverter. An inverter can give the delay of a plus minus t by 2. Plus minus t clock by 2. Did I tell you this particular thing? So either it can give a delay of plus t by 2 or it can give a delay of a minus t clock by 2. What you will pick here? Something has to be greater than the particular value. That means here you will want to write down the largest value, no? T clock should be greater than the largest value. If it is greater than the largest value, like I want Virat to score 100 centuries. So maximum I will put 100. If he is scoring more than 101, then also I am fine. If he is scoring more than 102, then also I am fine. So here you will put the largest value, no? So T clock should be larger than the largest one. Now if I want it to be largest, then what I will subtract? Minimum I will subtract or maximum I will subtract? If you want this particular thing to be largest, so what you will be subtracting? Minimum or maximum? So will I be subtracting plus t clock by 2 or minus t clock by 2? I will be subtracting minus t clock by 2. Is that understandable to you? So minus minus will become plus. So eventually this value will become more large. So this minus minus will become plus. So this goes here. This will become t clock by 2 and answer would come out to be 22 nanosecond. So answer will be 22 nanosecond. If you are having some doubt, draw the timing diagram. The answer would come. This is a particular method which have been developed by me only. But when we draw the timing diagram, I have verified it. This answer only will come. Okay, you can draw the timing diagram if you are not feeling much comfortable. In our lecture series, I have already explained by making the timing diagram as well. If you are not feeling much comfortable, draw the timing diagram, but remember in this manner. What is the manner? The manner says that this can give me a delay of plus minus t clock by 2. Here what I will subtract? I want it to be largest than the, like it should be larger than the largest one. So I want it to be largest. That means I will be subtracting the minimum. All good? All fine? Okay, let's go to the next one. Yeah, so in this question, what is given? Non-magnetic lossless dielectric is there. Wave is undergoing the phase change of 45 degree, or you can call it a phase change of pi by 4, right? Phase change of 45 degree for 2 millimeter distance. That means for 1 meter distance, how much phase change would be there? Pi by 4 into 2 milli. Say yes or no? This much phase change would be there. Radian per meter. What it is? It is nothing but a phase constant beta. So beta value is given. What is that? 1000 by 8. What is 1000 by 8? 1000 by 8 is nothing but 125 pi radian per meter. Beta value is given. Frequency is given. You need to find out the relative permittivity. What is the formula of beta? Sir, omega by c under root epsilon r. Mu r is 1. Why is that so? Non-magnetic material is there. That is equals to 125 pi. Frequency value is given 2 pi f, 5 into 10 to the power 9, 3 into 10 to the power 8 under root epsilon r equals to 125 pi. This and this get cancelled out. So 10, 100, 1.25 into 3, 1.25 into 3 and then take the square. 1.25 into 3, then take the square. Okay, how did I do it? 5 into 2, 10, 10 to the power 10 it would become, right? So this would become 100, 100 by 3, right? So 125 into 3 divided by 100, 125 into 3 divided by 100, that is the value of under root epsilon r, do the square, 14.0625. So value of epsilon r is coming out to be 14.0625. That's it. This is the value of epsilon r. Okay, let's go to the next. So what this circuit is working as? Clock, how clock would come? Either it would be 1 or 0, 1 or 0, 1 or 0, right? So when it is 1, when the clock is 1, what will happen? The output will be D. When the clock is 0, the output will be the previous state, right? Output Y, it is getting output to be D, that means this new input when clock is 1, and it is getting the output to be the previous state only, the previous state only. Y plus is nothing but Y only. Y plus is nothing but Y only when clock is 0. What does that mean? What it is? It is a latch. Why it is a latch? Because it is level triggered. If it is level triggered, that means it is a latch. What kind of latch it is? It is latching the applied input when clock is 1, and it is retaining the previous value, it is retaining the previous output when clock is 0. What kind of latch it is? D latch. What is the next stage equation of D latch? Q plus equals to D. But this will happen only when high input is even, when input is high, or here we can say that when clock is high, and when clock is not high, that means the previous state will be retained, right? So what does that mean? It is a latch, it is not a flip-flop. Flip-flop is level triggered. Flip-flop is level triggered, but it is not a level, sorry, flip-flops are, flip-flops will be working on the edge triggering. Flip-flops are edge triggered, but latch will be level triggered. So it is a level triggered. When clock is 1, latching the input. When clock is 0, previous state is retained. Clock 1, latching the input. Clock 0, previous state retained. This cycle will keep on going. So what does that mean? It is a D latch, not the flip-flop, because flip-flops are edge triggered. It is not working on the edge, it is working on the level. Okay, let's go to the next one. Yeah, so this is based on Friis equation. What is the transmitted power? 20 watt. It is walking a distance of 0.36 kilometer. So when it walks a distance of r, the power would become the average power would become 20 watt divided by 4 pi r square into the directive gain. What is the directive gain? So directive gain of the transmitter is 30 dB. 30 dB. So 30 dB could be written as 10 log 10 x, that is equals to 30 dB. That means x could be written as 10 to the power 3. So multiply with 10 to the power 3. So this is the time average power at the receiver. Then it will have to go through its aperture area. That would be aperture area of the receiver. That would be lambda square by 4 pi into its directive gain. What that would be? 10 to the power 4.5. That will be its directive gain. Understandable? Right? That's it. This will be the received power. So this is the received power. This is how we understand the Friis equation. There is no polarization loss factor and all these kind of things are not there, right? And radiation resistance is not given, loss resistance is not given. All these things are we are neglecting. Transmission line is not given, Z0 value is not given, so reflections and all also we are neglecting. So all these things are not taken into action. So this is the answer we will be getting. So let's calculate this. So 20 by 16 pi square I can write down. 4 pi square, 4 pi square, 16 pi square into 10 to the power 7.5. So how will you do the calculation in the examination? So this and this you will get cancelled out. Sir, for 20 I have written, 4 pi I have written. So what is left? Lambda by r. So what is the value of lambda? Sir, the value of lambda is not mentioned. Lambda is nothing but c by f. What is the value of c? 3 into 10 to the power 8. What is the value of f? 12 into 10 to the power 9. So what is the answer you are getting? 1 by 4 into 1 by 40. So value of lambda is 1 by 40. Is that understandable to us? This is how you can solve it. Lambda equals to c by f, and I hope free air would be free space. Free space has been mentioned. So lambda equals to c by f, 3 into 10 power 8. F is 12 giga, 12 into 10 power 9. 1 by 4, 1 by 40. This is the value of lambda. So 1 by 40 square divided by r square. What is the value of r? So divided by r square. So divided by r square. What is the value of r? 360 meter. Right? Everything is going into SI. So 0.36 kilometer means 360 meter. So 360 square. There you go. This is the calculation we need to perform. Okay. So what I can see here is that 40 into 360. 40 into 360 into 4 into pi. Then do the whole square. 4 pi into 40 into 360. Then do the whole square of it. Then take the reciprocal, multiply with 20 and then multiply with 10 to the power 7.5. There you go. So it is coming out to be, this is how smartly you need to do the calculation. Here there is very high chance that you can mess up the calculation. So this is the power you are getting. Can I write it down in milliwatt? Surely I can write down in milliwatt. 19.31 milliwatt. But we need to try the answer in decibel milliwatt. So what will be the answer? So for that I have given the formula. In the examination it might happen that this formula is not given. So from now onwards you will remember the formula, because I know that a lot of people does not remember this formula. That's why I have given the formula here. So simply put 19.31 milliwatt divided by milliwatt. 1 milliwatt will get cancelled out. So it is like 10 log 10 power only, just in the milliwatt. That's it. So take log 10 multiply with 10. So what is the answer? 12.85. 12.85 dBm. Okay, very simple thing. Let's go to the next one. Yeah, so were you able to solve this one? This is a gate QIQ only. In gate 125 only it has come. In gate 125 there was a question that xt is being sampled with the impulse train which is shifted by 2s. Impulse train shifted by 2s. Here there is an impulse train. Along with that, shifted impulse train is also there. And xt is being sampled with that. Then we were having a low pass filter, then what would be the output by t? This was the question. And everyone matched it up. Everyone. Not a single guy got it conceptually correct in the examination hall. Not even the AIR one. Right? And even the educator as well. There was only one channel who got the correct solution. You can check out that channel and you will get to know that which channel gave the correct solution of that particular question. Okay. So let's see the correct solution of this question. Yeah. So xt will be multiplied with pt, you will be getting xpt. If I know the frequency spectrum of xpt, then my job would be done. H of omega is simply a low pass filter having a particular cutoff frequency. Then I need to get yt equals to kxt, where k is a constant. So my target is to get xpt, which is nothing but multiplication of xt and pt. Multiplication in time domain will result in convolution in the frequency domain. So xp of f would be x of f convolution with p of f. X of f I already know. P of f I can find out. But just notice one thing. Pt is the addition of two impulse train, P1t and P2t. Say yes or no? Where P1t is the impulse train which is having a time period of 2 delta starting from t equals to 0. Where P2t is also impulse train having a time period of 2 delta only, but starting from, or you can say shifted version with delta. Along with that there is a negative sign as well. So this is your P1t, this is your P2t. Do you agree to this point or not? This is your P1t, this is your P2t. Can I write down the frequency spectrum of this? Yes sir, that would be 1 by t naught summation delta of f minus n f naught, where n goes from minus infinity to infinity, where f naught is nothing but 1 by time period. Say yes or no? Right? So this will be your P1 of f. That can be better written in this manner. Actually, this is the better form. Just I am opening it up. Actually, I should put a minus sign here, this sign here. I have just opened it up. It is dot 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 delta f plus 2 f naught, delta f plus f naught plus delta f minus f naught, delta f plus minus 2 f naught, and so on. This is your P1f. How will you write down P2f? Sir, for impulse train I know, but this is the shifted impulse train, no? So if I define something called P3t, what I am doing, I am defining something called P3t. What is that? P3t is nothing but P2t plus delta. Basically, I am shifting this here. That means again, this delta would come to center. If this delta is coming to center, then I know the frequency spectrum very easily. Just there is a negative sign, that negative sign I can put. And if I know P3t, so can I tell P3f? Yes sir. What that would be? P2f e to the power j 2 pi f delta. So what will be your P2f? P2f would be nothing but P3f multiplied with e to the power minus j 2 pi f delta. Is that understandable to you? So this is my P2f. So I am defining something called P3t, and the P3t is nothing but this particular signal. Just you have shifted this. P3t is nothing but P2t plus delta. Plus delta means it will be shifted backward. So this kind of a waveform you will be getting. So can you write down P3f? Yes sir, very easily. The similar thing that I wrote down here. 1 by time period summation and going from minus infinity to infinity delta of f minus n f naught, where f naught is nothing but 1 by 2 delta. Just there is a negative sign here, so negative sign would also come outward. That's it. Minus 1 by 2 delta. There you go. What will be your P2f? P2f will be nothing but P3f multiplied with e to the power minus j2 pi f delta. What will happen? P2f would be nothing but e to the power minus j2 pi f delta multiplied with P3f. Now, this particular thing will be multiplied with this scenario. So, what will happen? E to the power 1 by 2 pi. Now, all the impulses, all these impulses will be multiplied with e to the power j2 pi f delta. E to the power minus j2 pi f delta will be multiplied with delta of f minus f naught. What will happen? This f naught will come here. This f naught will come here. In place of f naught will come. So e to the power minus j2 pi f naught delta. What is the value of f naught? 1 by 2 delta. Right? I am just simply applying the property 1 by 2 delta. 1 delta getting cancelled out. E to the power minus j pi. What that would be? Minus 1. So here you will get the negative sign. Are you able to understand this point? What I am doing here? So outward there is minus 1 by 2 delta. Inward this is being multiplied. When it is multiplied with delta of f minus f naught came here. F naught is nothing but 1 by 2 delta. It became e to the power minus j2 pi. That means here I am getting the negative sign. What will happen with delta f? E to the power minus j2 pi f delta will be multiplied with delta f. F minus 0. This 0 goes here. E to the power j0. What that would be? 0 only. So delta f remains as it is. What will happen to f naught? E to the power minus j2 pi f delta f plus f naught. What will happen? Minus f naught will go here. What it will become? E to the power j2 pi f naught delta. Minus f naught is going here, no? So minus f naught is going here. So e to the power j2 pi f naught delta. F naught is 1 by 2 delta. It will also become e to the power j pi. That is also minus 1. Now can you let me know what will happen with e to the power? What will happen with delta of f plus 2 f naught? What is written here? Delta of f plus 2 f naught is written here, no? So what will happen with this particular thing? It will also be multiplied with e to the power minus j2 pi f delta. In place of f, what you will put? Minus 2 f naught. So e to the power j 2 f naught delta. What is the value of f naught? F naught is 1 by 2 delta. F naught is nothing but 1 by 2 delta. So it is nothing but 1 by 2 delta. So delta getting cancelled out, 2 getting cancelled out. What is e to the power j2 pi? That is also 1. So what you are getting? Sir, whatever the even frequency components are there, they remain as it is. But odd one are getting negative. And I told you this thing, I don't care about all these even odd components. I only care about this delta f. And I told you this thing in the lecture as well last year when I gave the solution, and in our class notes as well, that even if your impulse train is shifted, nothing will happen with this impulse which is there at f equals to 0. Even if you shift your impulse train, nothing will happen with the DC value. DC value will remain the same. Do you remember this particular thing or not? DC value means the component at f equals to 0. That means this delta f will remain as it is. One is having positive sign, other one is having negative sign. When you add both of them, what will happen? Both will cancel out each other. That means zero frequency component will be gone. When you are multiplying, when you are doing the convolution, in P of f, zero frequency component will not even be present. That means x of f will not even be present in the final output. So how will you be able to get x of t out of yt? Like basically from xp of t, you will not be able to get x of t no matter whatever the cutoff frequency you put. So this will be the answer. Although let's solve it again. But just by looking at the question, if you are able to think, then you will be simply put on this particular option. That sir, even if I am shifting the impulse train, that means look what you need to get. How you would be thinking in the examination hall? That sir, I need to get k into xt. For getting k into xt, I need this component. In xp of f, I need this component. this component between minus fm to fm. This component I require. How would you get this component? When your x of f will be convolved with delta f. That means you want the term of delta f in p of f. This is the requirement. Very basic thing. If you have studied communication system, if you have studied network if you have studied signal system, then this much you will be able to understand, that I require the term of delta f. From here, will I be able to get the term of delta f? Sir, two impulse trains are there. I don't know what will happen to f naught, 2f naught, 3f naught, minus f naught, minus 2f naught, or 3f naught. I know that the component at zero frequency, the component which is coming because of the DC value, it will not be changing. Nothing will be happening with that particular component. That will remain as delta f only, and here also it will remain as minus delta f. Sir, both will be added. That means delta f component will be gone. Although in this particular scenario, all the even components will be gone. When you add both of them, what will happen? Sorry, this particular component, this is your P2F. This is my P2F, this is my P1F. This was my P1F, right? 1 by 2 delta. Here I have written P1F. This was your P1F. This was your P1F. And this is your P2F is coming out to be. Minus 1 by 2 delta outside. Even components, sorry, odd components are having negative sign. Even components are having positive sign. Now you need to add them. So already there is a minus sign, no? So you can take it inside. So this will become negative. This will become positive. This will become negative. This will become positive. This will become negative if you are taking the negative sign inside. So negative sign inside I have taken negative, positive, negative, positive, negative. Now you need to add both of them. When you add both of them, what will happen? This and this will get cancelled out. This and this will get cancelled out. This and this will get cancelled out. This is something you will be getting. This is your P of f. Yes or no? And also 2 will come outward. So 1 by 2 delta, this will become 1 by delta. This is your P of f. Now what you are doing? What will be your xp of f? Xp of f is nothing but x of f convolved with p of f. So x of f will be convolved with this. 1 by delta I can take outside. This is just a constant value. It will be convolved with all these impulses, which is 3f naught, f naught, f naught, 3f naught. So what will be your xp of f? Your xp of f would come out to be nothing but x of f plus 3f naught, f plus f naught, f minus f naught, f minus 3f naught, and so on. And surely 1 by delta outside. Surely 1 by delta outside. So what kind of frequency spectrum you will be getting for xp of f? No frequency component is present at f equals to 0. So here centered at f naught. Centered at f naught. This is your f naught plus fm, f naught minus fm. Then centered at 3f naught. 3f naught minus fm, 3f naught plus fm. And similar thing would be happening in the negative hand side as well. Negative hand side as well. Right? What is this 3f naught? 3f naught is nothing but 3 by f naught is 2 delta. What is given, like, oh, no matter whatever that is given. Now you pass it through a low pass filter. Now you pass it through a low pass filter. No matter whatever the frequency I take, there is no component present here. If no component is present here, there is no way that you will be able to get this particular output, which is yt equals to kxt. Is that understandable to you? Okay. Well and good. Right? All these things, this was just to get you confused, nothing else. Okay then? Yeah. That's it. Let's go to the next one. Yeah, so let's solve this one. What we are doing here. This is the Fourier series coefficient of a time domain signal is shown here, and you need to, and fundamental frequency is pi, you need to find out the signal. Right? So these are the values. C1 value is mentioned, C2 value is mentioned, C3 value is mentioned. So what is your xt? Xt is nothing but c of minus 3 e to the power, c of minus 3 is 3, e to the power minus 3, e to the power minus j 3 omega naught t. Omega naught is pi only, which I will put later on. Then 2 e to the power minus j 2 omega naught t plus 1 e to the power minus j omega naught t plus e to the power j omega naught t plus 2 e to the power j 2 omega naught t plus 3 e to the power j 3 omega naught t. Now you see this guy and this guy. So 3 e to the power minus j 3 omega naught t 3 omega naught t plus 3 e to the power 3 j omega naught t. So 3 you take common, e to the power minus j 3 omega naught t plus e to the power j 3 omega naught t divided by 2 multiply with 2. Okay, so this will become 6. So this particular term is giving you 6 cos 3 omega naught t. So what you are getting, 6 cos 3 omega naught t plus here you will get 4 cos 2 omega naught t plus 2 cos omega naught t. Omega naught value is 5, so this will be the answer. Other ways are also there. This is even. So here even function should be possible. So this is not possible. It is not even. This is also not even. This is also not possible. Then summation of x of k. What it will give you? K going from minus infinity to infinity. What it will give you? It will give you the value of xt at t equals to 0. Right? Xt at t equals to 0. So at t equals to 0, here value you are getting 3 plus 2, 6 value you are getting. But what is the total summation? 3 plus 2 plus 1. 6 into 6, 12. So 12 should be equals to x of 0. So in which of the option it is matching? In this option it is matching. So option is 4. Okay. Very simple question. Let's go to the next one.
Let's solve this question. The block diagram of a standard second order system, right, is shown below. And the below graph is the unit step response of this same system. Now, it is a second order system. Very important point. It is a second order system. Analyze the closed loop frequency response of the system to determine the resonant frequency omega r, and it is basically the specific frequency at which the system exhibits its maximum output magnitude, right? What are they discussing? They are discussing about the frequency response. They are discussing about the closed loop frequency response. Please remember these things, right? This is the step response. This is the time domain response. They have given me the time domain response, and they are asking me regarding the information of frequency response. Okay, two things are different over here. Omega r, if you have studied control system, you'll know what is your omega r. Omega r is basically the resonant frequency of a standard second order system, and for a standard second order system, the resonant frequency formula was omega n into 1 minus under root 2 zeta square. This formula is valid only if your zeta is less than 0.707. Otherwise, your system will never exhibit a peak. If you remember, the frequency response, your frequency response was something like this, right? It used to exhibit a peak and then it used to go down, something like this. This was the frequency response of a standard second order system. Okay, I'm not drawing it like I am not drawing the exact frequency response, but somewhere you will get a peak, right? And that is called as the resonant peak. That is called as the resonance frequency, where the gain of the transfer function is maximum. So that is equals to omega n into 1 minus 2 zeta whole square. Right? Of course, this formula is only valid if my zeta is less than 0.707. So of course, the system has to be underdamped. So zeta will be greater than 0 and zeta must be less than 0.707, then only this formula is valid. Now, what was the value of the peak resonant frequency, right? Peak resonance. Basically, at that particular frequency, what is the magnitude or gain of the transfer function? So, gain of the transfer function, peak resonant frequency, is basically the DC gain of the transfer function upon what? Upon the sine 2 theta. What is the theta? Like these formulas are derived in the exam hall, you will have to use the formula. You don't have any other option, right? So, KDC upon sine 2 theta. So how do I find out 2 theta, right? So basically, we know our cos theta is equals to zeta. All these things I have covered in RPYQ series. So make sure you watch the RPYQ video, time response. There I have covered this. So cos theta is equals to zeta. Cos theta is equals to zeta. So from here you can actually put the values, right? And of course, you have to make sure that your zeta must be less than 7.707. Basically, your theta must be less than 45 degrees. So not less than theta must be greater than 45 degrees. If zeta has to be less than this, theta has to be greater, because cos theta is equals to zeta. So all these relations are there. So this is the thing. We have to compute the DC gain of the transfer function. We have to compute the value of zeta, and we will need the value of omega n. These are the three data points that I need, and I have only been given a single graph, right? In a graph, I see a lot of things that are given, right? First of all, this graph is the response of a unit step, and I see the steady state also is 1. And do you know what is the DC gain of the transfer function? DC gain of the system. So DC gain of the system actually is equals to the steady state output, basically C of infinity upon R of infinity, right? In time domain. In frequency domain, it is basically C of 0 upon R of 0. So we know that S equal to 0 in frequency domain is T equals to infinity in time domain. That is how we compute the final value theorem, if you remember it, right? Final value theorem. So if I want to find out the value at T equals to infinity, we put S equal to 0, right? That is a relation. That is how you can remember it, right? This is a very, very important thing, that if you want to find out the DC gain of a transfer function, all you need to see is the gain at infinity, right? So what is R of infinity? R of infinity is the input, right? It is a unit step. So U of infinity is 1. And what is C of infinity? C of infinity, we see that it is settling at 1 only. So this is also 1. So the DC gain or KDC of the transfer function is 1. So DC gain is 1. So my peak resonant would be 1 by sine 2 theta. Now I see that it is reaching peak at t equals to 0.2 seconds, and also I know the value of peak, right? 1.12. So if you remember this thing, that the peak resonant frequency, the maximum peak overshoot, MPO, is equals to e raised to power minus pi cot theta. Very, very important formula. Again, I have told you in the RPO series how to remember these things. So this is the maximum peak overshoot formula. And do you know what is maximum peak overshoot? It is nothing but the peak value of the output minus the steady state value of the output upon the steady state value, right? It is the normalized value, right? Normalized peak value basically. So C of peak is 1.12 minus 1 divided by 1, that is 0.12, right? And this is equals to e raised to power minus pi cot theta. So minus pi cot theta, from here I will get the value of cot theta, and from there I can get the value of zeta. So let me do the calculations. So 0.12 ln, then divide by pi, then I will take the inverse, and that will give me tan theta. Then I will take the tan inverse, that will give me the value of theta. So theta is equals to 56 degrees approximately. Now what is cos theta? Cos theta would be, that is zeta. Zeta is equals to 0.56. That is my zeta. I got my zeta, which is certainly less than 7, which is certainly less than 0.707. So we are safe in that particular aspect, right? That yes, these are proper values. I will be able to compute omega r and mr. So what is omega r? What is omega r? For that I need the value of omega n as well. I know the value of zeta, so I will be able to easily compute this mr. So mr, if I compute, because I know theta is 56 degrees, so it will be 1 upon sine of 2 theta. So cos inverse into 2 into sine of this comes out to be 0.927. So this will be equals to 1.927. 1.08 mr. So mr is equals to 1.08. Now what about your yeah, so you will see in the options there are two options, right? Option B and option D. Both of them has mr to be equals to 1.08. I was not able to copy the options, but you will see in the options there are two things, option B and option D. Which one will you choose? For that you will need to calculate omega r. So for that I will need the value of omega n, right? How do I compute omega n? So this information is also given to you. This is called what? This is the peak time. So basically what happens, your peak time is periodic. So this again I have derived in my RPYQ, that your peak time will occur in this range 2n plus 1 divided by omega. So let me put this below, divide by omega d. So divide by yeah, pi by omega d. So basically the first peak will occur when at n equals to 0. This is the first peak, right? The second peak will occur 3 pi by omega d here. This is my 3 pi by omega d. So if this is 0.2, then this point certainly will be 0.6. Otherwise this will not be a proper graph. And then the next peak will occur 5 times this, that is at 1 second, right? And this will go on. This will go on, right? Obviously, like after 4 tau you will reach, you will settle, your system will settle almost around the 98% error band, so 2% error band, sorry. So you will not be able to observe it, but that's how the peak time, that's how you compute the peak time. But what we are interested in, we are only interested in the first peak. So when n is equals to 0, if n is equals to 0, this will be pi upon omega d. So pi upon omega d value is actually given to us, that is the first peak, that is 0.2. So your omega d is equals to 5. I know my omega d, I know my theta. One more thing that you know, what do you know? That your omega d is equals to omega n sine of theta. So your omega n would be equals to what? It would be equals to, what is omega d? Omega d is 5 pi divided by sine of theta. So theta is 56 degrees, sine of this. So that would be 18.95 approximately, right? 18.9596 approximately, 18.95 radian per second. And one of the options would be 18.95, the option D, and which will not be absolutely your correct answer, right? Because this is the natural frequency of oscillation. This is not the resonant frequency, the frequency at which the peak occurs. This is not that frequency. So resonant frequency, again we have discussed the formula, it is omega n into 1 by 2 zeta square. So natural frequency is 18 point this, so zeta is 0.56, right? 0.56 whole square into 2 minus this plus under root into omega n. Omega n is 18.94 and something. So which is, okay, sorry, I believe 19.94, sorry, which is 11.56. Okay, almost 11.58, 11.56 radian per second. Right, approximately your options will be matching almost. Option B will certainly match. Right, how you can quickly solve it? So there is no shortcut here. One thing is that once you calculate omega n, then you are certain that your omega r will be less than omega n. That is certain, right? That is certain, because the maximum value of zeta, what is the maximum value of zeta? It is 1 by root 2, right? So this value can be 0 and the minimum value of zeta is 0, right? Okay, minimum value is 0, so okay, sorry, it can be equals to omega n as well, right? So either your range will be omega r will lie between 0 to omega n, And you see in the options, certainly it is not omega n, because it will be equals to omega n when my zeta is 0. So zeta is certainly not 0, non-zero we have computed. So basically it will lie between omega n and 0, and that particular case condition is only present in option 2. So it is not present in any other option, right? So option B would be your correct answer for this particular question. The lag compensator shown in figure B is obtained by multiplying the transfer function of the lead compensator as shown in figure A by a rational function x of s, right? We are multiplying this and we are getting this lag compensator, sorry. What is asking? So like assume that the figure A output is sensed at 2. So whatever transfer function they are talking about for figure A, it is this, right? V over Vi. And then they are multiplying this transfer function with this x of s, and we're obtaining the new transfer function. Okay, and the output sensed for figure B is here, right? Series combination of 2 ohm resistor and 1.5 farad capacitor. Determine the magnitude of x of s at s equal to 2, right? So simply we have to compute the x of s. So what they are telling me, that whatever is this transfer function, let's say the transfer function of figure A is Ta of s. I'm multiplying this with x of s and I'm getting Tb. That is what they're telling me. That's the simple thing that they're telling me through the question. So yeah, we can do that. So what is Ta? And I will prove it to you. Is it a lead compensator or a lag compensator? So Ta, let me first compute Ta of s. So what is Ta of s? So Ta of s, this would be V over Vi in this particular figure, right? In this particular figure. So V over Vi, not that simple. Let me first of all write what is, let me assume this particular part to be Z1. And this particular part is Z2, that is 2 ohm, that is understood. But let me first, so what will be your Ta? Ta would be simply V of s upon Vi of s, right? This would be equals to what? This would be equals to simple voltage division rule, Z2 upon Z1 plus Z2. So Z2 is what? This Z2 is 2 divided by Z1 plus Z2. So what is Z1? Z1 is 1 by Cs into 2, right? Or like basically 1 by SC. C is 1 divided by 2 by S, uh, 1 by S plus 2, right? Yes. So this would be 2 divided by 1 plus 2s. 2 divided by 1 plus 2s, right? So 2 divided by 1 plus 2s, that is my Z1, right? So this will be 2 divided by 1 plus 2s plus 2. So 2 can be taken out of the picture. This will be 1 plus 2s divided by 1 plus, so 2 into 1 plus 2s, 1 plus s basically. So this is the transfer function of figure A. So in the figure A, if I draw the pole 0 diagram, so 0 is at s equals to minus half and pole is at s equals to minus 1. So 0 is more nearer to the origin, right? So it is a 0 dominating system. So figure A must be a lead compensator, as they have mentioned here as well, right? Figure A is a lead compensator, right? Because 0 dominating system, so 0 dominating systems are lead compensators. So just I'm showing you, yes, it is a lead compensator. That is correct. Now what about the transfer function B, TB? TB is simply a lag compensator, right? So let me again find out the transfer function here, TB. Again, this again let us assume this is some Z1, or let me assume this is some Z2 and this is Z1. So TB would be again very simple, VO of S over Vi of S, that is Z2 over Z1 plus Z2. So this would be equals to, okay, so what is my Z2? Z2 is what? Z2 is what? Z2 is what? So Z2 is this, right? Series combination of 2 ohm and 1.5 farad capacitor, that is nothing but 1 by Cs, that is 1.5 S plus 2. As simple as that, right? Simple series combination of 2 ohm and 1.5 farad capacitor, and this will be 1 divided by 1.5 S plus 2. This is my Z1, sorry, Z2, and Z1 is simply 2 ohms. Z1 is simply 2 ohms, right? Okay. So this, if we multiply 1.5s, I have to multiply, right? So this will be 1 plus 3s divided by 4 into 1.5, that is 6s, right? Plus 1. Okay. Now what is the pole 0 here? So I have a pole at s equals to minus 1 by 6, and I have a 0 at s equals to minus 1 by 3. So this time you observe that the pole is nearer to the origin, so it has to be a lag compensator because it is a pole dominating system. That's why it is a lag compensator. So what is my x of s? X of s is this, right? X of s from this equation, it would be what? TB of s upon TA of s. So TB of s upon TA of s. So this will be 1 plus 3s divided by 1 plus 6s, that is my x of s, into TA of s, like 1 by TA of s, that is basically 2 into 1 plus s divided by 1 plus 2s. Now what are they asking? They are simply asking the value of x of s, magnitude of x of s at s equals to 2. So let me put here s equal to 2. This will be 1 plus 6 upon 1 plus 12 into 2 into 3 upon 1 plus 6, right? So this will be simply cancelled. Sorry, this will be 2, 1 plus 4. So things will not be cancelled. So let me compute this value, that is 7 by 13 into 6 upon 5. So that comes out to be 0.646. So 0.646, this will be your answer for the question. The root locus diagram of a control system is shown below. Okay, this is the root locus diagram. At a gain value of k equals to 12.5, the location of the poles are marked P1, P2 and P3. Okay. Given that P1 is this, right? P2 also I can say what is the value of P2. Determine the damping ratio zeta for the system. Okay. So what we know is P1 is this, right? So what will be P2? P2 will be, because of course all the coefficients of my system are real, so P2 would be basically real part will be same, but the imaginary part will be just the conjugate. So this will be minus j 1.3, that's it. Okay, that is what my P2 is equals to, correct? So what we can do, we can use dominant pole approximation, because I can see that this pole, right, the real part is 0.7 and the other pole is somewhere away from minus 20. So the ratio of the real part 0.7 upon 20 is much smaller, or the ratio of the further away pole 20 upon 0.7 is much greater than 4. So we can use our dominant pole approximation. If I use my dominant pole approximation, so approximately I can assume my system to be a second order system, right, whose complex conjugate poles are this. So they are asking me what is the damping ratio. So we know the real part for a second order system, for a second order underdamped system, this portion is zeta omega n, right, and this portion is basically omega d. Okay, omega d is nothing but omega n into 1 minus zeta square, or I can say this will be, this part will be omega n cos theta, where this is my theta angle, and this will be omega n sin theta, right? From here I can easily calculate the tan theta value. So tan theta would be 1.3 by 0.7. So of course I'm just only, this is the triangle, I'm just comparing the lengths of the triangle. Okay, ignore the negative sign. Okay, so tan theta is 1.3 upon 0.7 tan inverse. So theta would be 61.7 degrees. Okay, that is what my theta is equals to, 61.7 degrees. Now I need to find out zeta. Zeta is nothing but cos theta. Cos of this, right, will be zeta basically. Cos theta is nothing but zeta, because zeta into omega n is this value 0.7. So cos of theta would be my zeta. So cos of this value, that is 0.474. Okay, so this will be my answer of the question.
Yeah, so let's see the solution of this one. Parity checker matrix is given, received vector is given. One bit of error is there in the received vector. There is one bit of error. So where is that error? We can find out by syndrome, right? So what is the syndrome? R into H transpose. What is R into H transpose? So R is nothing but this particular vector multiply with H transpose. So this will be your H transpose, which is 0 1 1 0 1 0 0. So yes or no? 0 1 1 0 1 0 0 0 1 1 0 1 0 0. Then 1 1 0 1 1 1 0 1 0 1 0. Then 0 0 1 1 0 0 1 1 0 0 1. So this is your R into S transpose. So what you are getting? 0 XOR 0 XOR 0 XOR 0 XOR 0 XOR 0 XOR 0 0. Then 1 XOR 0 XOR 0 XOR 1, that is also 0 0 1 XOR 0 1. Then 0 XOR 0 XOR 0 XOR 1 0 1 0. सो अरे भाई क्या बात हो गई? 0 0 0 1 0 0 0. So 0 1 1 we are getting. So this is the syndrome we are getting, 0 1 1, which is the fourth bit. So this bit is an error. So what will be the corrected code word? That would be 1 0 0 0 0 1 0. That is the corrected code word. Okay, 1 0 0 0 1 0. This is the corrected code word. What is the value of this particular thing? Summation I goes from 0 to 6 bi to the power I. Decimal equivalent, no? This is nothing but decimal equivalent. Nothing but decimal equivalent. That's it. Corrected code is this. This is the decimal equivalent of corrected code. Just to confuse you. Corrected code. Just to confuse you, this has been written. But it is just the decimal equivalent. If you have just opened it up. B of 0 to the power 0 plus B of 1 to the power 1 plus B of 2 to the power 2 plus B of 3 to the power 3 and so on. What is this? Decimal equivalent only. So we are calculating the decimal equivalent of this. So 1, 2, 4, 8, 16, 32, 64. So decimal equivalent is coming out to be 66. Now what is D? The minimum number of errors that can be detected by this linear code. Minimum number of errors that can be detected. For that what you require? D minimum. So from that H matrix only can you find out D minimum? Yes sir. If first I need to find out if two rows are same. So 0 1 0, can I find out 0 1 0 somewhere? Yes sir. 0 1 0 0 1 0. There you go. What does that mean? D minimum is 2. If D minimum is 2, that would be maximum number of detectable errors. So 2 would be equal to TD plus 1. That means maximum number of detectable error is 1. So what is the value of D? D is nothing but 1. So value of D is 1. So 66 divided by 1. What that would be? 66 only. There you go. This is the answer. Okay, very straightforward question. Just framed it in a tougher manner. Nothing else. Looking like this, what it is. If I had said R is there is some error. Then whatever the character symbol is there, find out its decimal equivalent. That's it. That would be the answer. Or I would have simply asked what is the maximum number of detectable error. That also you would have told. But if I have just asked in this manner, then you are struggling. So it should not happen. That's why it is gate replica. Okay, that's why the name of the examination is ReplicaX. Replica of gate examination. All the questions, everything, I have just taken the reference from PYQs only. Just I am changing it in my way. Okay, questions are changed in my way. Taken reference from PYQs only. Last year only this came, no? G matrix was given. So this time they will give H matrix. They asked D minimum there. Here I asked the detectable error. Right? Let's go to the next one. Input output relation is given. This is output. This is input. Like here I am representing my Rn, Cn. You are more comfortable with Yn, right? Yn equals to minus 1 by 3 x of n minus 2 plus x of n plus 3x of n plus 2. Now in these kind of questions, what you should check first? always you should check first LTI, because that is very easy as well. We have studied LTI system in a great manner. So first we should always check LTI. And if you have got that, yes sir, it is LTI, then for LTI system you have the techniques, no? For LTI system, what do you know? That sir, if you want it to be stable, that means impulse response has to be, you can find out its impulse response, no? Right? If it is LTI, then I can find out its impulse response. Now, regarding the impulse response, I know everything. What do I know? That sir, if it wants to be stable, if it wants to be Vibo stable, that means its ROC should include Z equals to 1 circle. If it wants to be causal, that also I can check, right? LTI is already there. Stability, how will I check the stability? It should be absolutely integrable. In that manner I can check. So basically, if it is LTI, then your question would become easy. So first I will check it is LTI. Yes sir, it is LTI. Non-causal, it is directly visible that it is non-causal. It is depending on the future value. So it is non-causal. That is directly visible. But let's find it out in some other way. Let's find out h of z. So what will be your h of z? Y of z would be nothing but z to the power minus 2 x of z plus 3 z to the power 2 x of z. So y of z divided by x of z, what you will be getting? H of z. What that would be? Minus 1 by 3 z square plus 1 plus 3z square. From here I can sense that there are only two poles, which is at 0 and infinity. If there are only two poles, one is at 0, other one is at infinity. What does that mean? There is only one possible ROC, which will be this one. So this ROC is bounded by two poles. What does that mean? It has to be non-causal. If it is non-causal, that means it is having memory, so there is no chance that it will be memoryless. Now if this is the ROC, that means z equals to 1 circle will be somewhere here. So the ROC is including z equals to 1 circle, that means it will be stable as well. There you go. That's it. So always first check about LTI. If LTI is there, then my job would be very easy for me. I would be able to get h of z, and from there I can conclude everything. Is that understandable to you or not? Surely it is understandable. Okay, then let's go to the next one. Yeah, so this one, lossless dielectric coating is applied on the glass surface. So this is also taken from PYQ only. Similar question has come in GATE 123. So this is your glass, right? This is your glass surface. I need to maximize the transmission. Wave is then I am doing the coating. Here I am doing the coating of some dielectric material that I don't know. And just before this there is air. So from air, if any kind of wave is coming, that should be completely transmitted. This is what this glass want. So this glass is having a intrinsic impedance of neta 3. This is having an intrinsic impedance of neta 2. This is having an intrinsic impedance of neta 1. So now this neta 1 should be matched with this total input intrinsic impedance. What will be this input intrinsic impedance? If you need to do the matching, then this length has to be lambda by 4. Lambda 2 by 4, this is medium 2 I am calling. So if this length is lambda 2 by 4, then what will be your neta in? Neta is the intrinsic impedance here. Okay. So what that would be? Z0 square by ZL. This will be Z0, this will be ZL. So neta 2 square divided by neta 3. That should be equals to neta 1. That means neta 2 would be equals to neta 1 neta 3 under root. Similarly, here it could be written that epsilon R2 could be equals to epsilon R1 into epsilon R3. How did I write it down? What is neta 2? Lossless medium epsilon R2 120 pi mu R under root mu R divided by epsilon R. So simply mu R would be one non-magnetic material we are taking. Is it mentioned? Should be mentioned, but take it by default. Even in the GATE examination, it was not mentioned. So take it by default. Okay, so just simply put it here. Neta 2 is 120 pi divided by 1 by under root epsilon R. Then under root is already there, 1 by under root epsilon R1, 1 by under root epsilon R3. Under root will get cancelled out, and epsilon R2 would become under root epsilon R1 into epsilon R3. Epsilon R1 is 1. Now refractive index is given. What is refractive index? Refractive index is this n. This is not neta. Refractive index is n. That is nothing but under root epsilon R only. Ignore the mu R. Okay. So refractive index is nothing but under root epsilon R. So refractive index is given for glass. That means under root epsilon R3 is given. That is 1.8. right? And epsilon R1 you already know that would be 1 only, which is air. So from here I can get the value of epsilon R2. What that would be? 1.8 square, sorry, epsilon R3 would be 1.8 square into 1 and then take the under root. I am missing out on something. So epsilon R2 is nothing but under root epsilon R3. That is coming out to be 1.8. Under root epsilon R3 is 1.8. Yeah. So epsilon R2 is coming out to be, epsilon R2 has come out to be 1.8. So what will be under root epsilon R2? Why I am caring about under root epsilon R2, you will understand in some time. So under root epsilon R2 would be, or let's not care about it as of now. So as of now, I have got this particular information. Sir, why it is important? Why you are wasting your time? So ideally, I should not have solved it in this manner. What they are asking, that sir, the minimum length was to get the maximum transmission. That means to get the minimum reflection. Maximum transmission means minimum reflection. So to get the minimum reflection, the minimum length required was lambda 2 by 4. And lambda 2 by 4 was coming out to be 0.11 micrometer. That means it was 0.44 micrometer. So for which wavelength? For which wavelength we have designed this particular scenario? This is what they are asking. So I need to find out the value of this lambda naught. I got the value of lambda 2. I need to find out the value of a lambda naught. So lambda 2 value I have got, which is 0.44 micrometer. My target is to find out lambda naught. Now I know one thing. What is lambda? 2 pi by beta. And what is beta? Omega by c under root epsilon r. What does that mean? Lambda is inversely proportional to 1 by beta, which is proportional to under root epsilon r. So lambda is inversely proportional to under root epsilon r. So if I need to find out the value of lambda naught divided by lambda 2, what that would be equivalent to? Epsilon r2 divided by epsilon r naught. Say yes or no. So lambda naught would be nothing but lambda 2 epsilon r naught. You are calling it r naught or epsilon r1, whatever it is. So epsilon r naught is nothing but 1. And what is epsilon r2? Epsilon r2 is coming out to be 1.8. So lambda 2 multiply with under root 1.8. What is lambda 2? Lambda 2 is 0.44 micrometer. So 0.44 micrometer multiply with under root 1.8. So for this particular wavelength, there will be maximum transmission or zero reflection. So 1.8 under root you take, multiply with 0.44, 0.59 micrometer. That's the answer. In the gate examination, what they asked? They asked this particular wavelength, as far as I remember, this wavelength, and they gave the value of this wavelength. I just asked the opposite thing. Okay. So when it came, it was a good question. When it came in the examination, it was a good question. But as of now, this has been like exhausted, because a lot of coaching institutes have asked this kind of question in the test series, right? So I hope most of the students would be able to solve this particular question if they have studied EMFT. Let's go to the next one. Here RL value we need to tell. Z naught value is mentioned. Even if it is a lossy transmission line, Z naught is real. If Z naught is real, what did I tell you? That means it will follow the condition that R by L is equals to G by C. Right? So I can apply all the formulas. Z naught equals to under root L by C and alpha equals to under root Rahul Gandhi. Right? Here we also developed one formula. L by C could be written as under root R by G. Right? So if I multiply alpha with Z naught, what I am getting? R. Multiply alpha with Z naught. Under root G, alpha into Z naught equals to R. So value of R I am directly getting alpha into Z naught, that would be 150 ohm per meter. What about L? Beta value is also mentioned. No? So what is beta? Omega under root LC. What is the value of Z naught? Under root LC. If I multiply both of them, what I will be getting? Beta into Z naught would be nothing but omega L. So L will be beta into Z naught divided by omega. So L will be nothing but beta 5, Z naught 50 divided by omega 3 into 10 to the power 6. So what you are getting? 250 divided by 3. 83.33 micro Henry per meter. There you go. This is the value of L you are getting. Again, straightforward, very straightforward. Let's go to the next one. Function f you need to find out. Okay. So what is that? What kind of quad you are getting? One quad I am getting here, and other one I am getting here. That's it. This would be your function f. What that would be? C bar and B bar plus, for this one it is simply A B bar. There you go. So it is A B bar plus B bar C bar. This is your function f. Like within seconds it should be solved. Okay, it should take hardly 1 minute. You should be able to get this question correct. Let's go to the next one. Yeah, so were you able to solve this question? Did you check the options? This particular circuitry is running between a supply of 6 volt and minus 6 volt. That means the swing of the supply is 12 volt. So if I talk about any node in between, if I talk about this particular node, so the maximum supply this particular node can have, that will be 12 volt only, no? Any node, this node, maximum supply it can have, that would be less than 12 volt actually. The circuit is running between the swing of 12 volt. So this node will have swing less than 12 volt. Less than 12 volt. Here what is the swing? 12 volt. Not possible. Here what is the swing? 16. Not possible. 20. Not possible. Which is the possible option? That's it. Okay. Deliberately I framed these options. In the examination, most probably another option would be there, 2 sin omega t. Although in the examination they will not ask this kind of tough question. Hopefully. Okay. Who knows, they may ask it. But yeah. Now we need to solve it, but I am telling you that how you could have solved it with respect to the options, because if some guy is attempting this particular question paper, he would have surely seen that some questions are very easy. So for the tougher question, you are having more than enough time. So if some guy has spent 5 to 6 minutes here, then just by looking at the option, he would be able to solve it. Otherwise, by the conventional approach as well, it is not that difficult. Why is that so? So first let's check that if it is in negative feedback or not. So if this output increases, this node increases, then this node will increase. This node is also saying that this node will increase. If this node is increasing, this is negative, so this node will decrease. That means yes, it is in negative feedback. If it is in negative feedback, then what will happen? Then this 5 sin omega t could be copied here, and let's just say this current is nothing but I naught current. So what is your I naught current? I naught current would be nothing but 5 sin omega t divided by 100. So this is the I naught current that it is driving. Now here there will be 0 ampere current, so this I naught current will be flowing here as well. So let's ignore this sign. So this is the I naught current that is flowing. What is our target? Our target is our target is to find out V naught. What will be V naught? The current that is flowing here, let's just say this current is nothing but I3. Okay, so V naught will be nothing but 20 into I3. Our target is to find out I3. Right? Let's just say from Q1 I1 current is going. So from Q2 how much current would go? Let's say it is I2. I1, I2 could not be equal, no? If they are equal, then there is no current in the I3. There is no I3 current. That means V naught would be 0. They cannot be equal. Right? So I3 is what? I3 is nothing but I1 minus I2. Say yes or no. So that's our answer. 20 into I1 minus I2, that is our answer. Now I need to find out the value of I1, I2. Here I know that this is the I naught current that I know. If this current is I1, if the current in Q1 is I1, then what will be the current here? You read this particular line. The area of Q1 and Q2 is 4 times of area of Q3. And similarly, Q3, Q5, Q6, Q4 are having the same area. So if this current is I1, this current would be I1 by 4. Here, emitter area is 4 times, so this current would be I1 by 4. And if this current is I2, so what will be this current? Because Q2 is also having 4 times area of Q4, right? So if this is I1 by 4, so what will be this current? This current would be I2 by 4. So at this particular node, if this current is I1 by 4, so this current will also be I1 by 4. Beta you have to ignore. Beta value is not even mentioned, so that you will have to ignore. So if this is I1 by 4, so this is also I1 by 4. What this will be? This will be I2 by 4 as well. So what do you think? What is the value of I naught? I naught is nothing but I1 by 4 minus I2 by 4. Are you able to understand this point or not? This is your I1 by 4. This is your I2 by 4. So I naught is I1 by 4 minus I2 by 4. So from here, what you are getting? I1 minus I2 is nothing but 4 I naught. I1 minus I2 is nothing but 4 I naught. So what is the value of V naught you are getting? Sir, V naught we are getting is I1 minus I2 is 4 I naught, so 80 I naught. What is the value of I naught? 80 into 5 sine omega t divided by 100. So that would come out to be 4 sine omega t. So what is the answer? This is the answer. Again, not very easy to click, okay, but from the options it could have clicked. Right, let's go to the next one. Again, very straightforward question based on counters, right? So all are initially set. Q2, Q1, Q2, Q1, Q0, all are initially set. What will be the decimal equivalent after 10th clock pulse? This is what they are asking. So first let's write down the next state equation. What will be the next state equation of Q2 plus? So Q2 plus is here. That is coming from J2 is, what is the next state equation of JK flip flop? Q plus. That is, this is how you need to remember, J into Q bar plus K bar into Q. One of the bar would come. Cross multiplication, one of the state would be bar. So K bar into Q. So K bar, here K2 bar is 1. So 1 bar will be 0, 0 into Q, Q2 will be 0 only. J2 is coming from Q1. So Q1 into Q2 bar. That is the scenario. What about Q1 plus? So here as well, this will be 1 bar will be 0 only. So it will be simply J1 into Q1 bar. What is J1? J1 is Q0 and it is coming from, you see from here, Q2 bar. So J1 is nothing but Q0 XNOR with Q2 bar. Can I write it down this as, say yes or no, Q0 XOR Q2. Why is that so? Because 1 bar could be taken as the whole bar. 1 bar here could be taken as the whole bar. What is Q0 XOR Q2 bar? That is Q0, sorry, what is Q0 XNOR Q2 bar? That could be written as Q0 XNOR Q2 whole bar. And this is nothing but Q0 XOR Q2. So it is Q0 XOR Q2 multiply with Q1 bar. And what about Q0 plus? So Q0 plus is nothing but 1 into Q0 bar, 1 into Q0 bar plus, what about K0? K0 is coming from Q2 bar into Q0. So it is nothing but Q0 bar plus Q0 into Q2 bar. What this could be written as? This could be written as Q0 bar plus Q2 bar, right? So this could be written as Q0 bar plus Q2 bar. That is Q0 Q2 whole bar. There you go. So this is the next state equations we have written. So now we just need to make the table. Q2, Q1, Q0, Q2 plus, Q1 plus, Q0 plus, Q2 plus, Q1 plus, Q0 plus. Starting from 1, 1, 1, where we are going. What is Q2 plus? Shall I take it to the next page? Because otherwise it will take a lot of time. Q1 into Q2 bar, 0, 0, 0. The next 0, 0, 0. So 0, 0 is going where? For Q2 plus, I need to put my eyes here. Q1 into Q2 bar, 0. For Q1 plus, 0. And here, 1. So 0, 0, 1. What is Q2 plus? Q1 into Q2 bar, 0. 1 XOR with 1, 1. Here, Q0 into Q2, 1. So 0, 1, 1. So Q1 into Q2 bar, Q1 into Q2 bar, 1. Q0 XOR Q2, Q0 XOR Q2, that is 1 with the Q1 bar, that would become 0. Next, Q0 plus will be Q0 into Q2, 1. 1, 0, 1. Q1 into Q2 bar, Q1 into Q2 bar, 0. Q0 XOR Q2, Q0 XOR Q2, 0. Q0 multiply with Q2, 0. So yes, again we have achieved this one. That means we started with 7, then we went to 0, Then from 0 to we went to 1. From 1 we went to 3. From 3 we went to 5, and 5 again we went to 0. So this is our mode 4 counter, right? Mode 4 counter. This is nothing but a mode 4 counter it is, right? So after first clock pulse, this will be the output. Second, this will be the output. Third, this will be the output. Fourth, this will be the output. After fifth, this will be the output. Note this, right? Started from here, first clock pulse, this was the output. Second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. After 10th clock pulse, this will be the output. So answer would be 1. Okay, that would be the answer. How you could have solved it? Sir, after 10 clock pulses, they are asking, what is the mode of the counter? 4. What is the remainder here? Remainder is nothing but 2. That means after second clock pulse, what will be your output? So after second clock pulse, output will be, after first clock pulse, output was 0. After second clock pulse, output will be 1. So this would be the answer. Okay. So let's just say they have asked for 315. So 315 divided by 4. What that would be? What will be the remainder you will be getting? सात चौके 28, 3. I'm really tired actually. Okay. So 3 remainder we are getting, right? 312. Yeah, 3 remainder we are getting. That means after the third clock pulse, what will be the output? So after first clock pulse, this is the output. Second, third, this is the output after the third clock pulse. Then answer would have been 3 only. Okay. Well and good. So these kind of questions they can ask. Okay. Let's go to the next one. Yeah, so let's see the solution of this one. What we need to find out? We need to find out that what percentage of optical power is received at the output. So power transmission in optical fiber, it is given by P naught 10 to the power minus alpha x by 10. Someone would have said that, sir, we have studied this formula, P naught e to the power minus 2 alpha z. So you studied this one for alpha being in Nepper per meter, right? This is alpha being in dB per kilometer, and most of the chances are there that dB per meter you can say, and most of the chances are there that this they will be asking. So from here only you can see, no, like e to the power minus 2. In place of e to the power minus 2, we are putting 10 to the power minus 1 by 10. That's it. And even if you remember Nepper per meter 1, then you know that 1 Nepper per meter is 8.686 dB per meter. So now you can convert it. Then you can apply this formula. In both of the cases, you will get the same answer. So P naught 10 to the power minus alpha. Alpha is minus 0.2 dB per kilometer, and the length of optical fiber is 50 kilometer divided by 10. So what we are getting? This will become 10 to the power minus 1. So P naught by 10. P naught by 10. So this was your input power, which was 2 milliwatt divided by 10. So at the output, how much power you are getting? 0.2 milliwatt, right? So what does that mean? How much, what percentage of input power is received at the output? 10%, right? Very straightforward. Formula based only. Let's go to the next one.
Consider the analytic function fz equals to this of the complex variable this. Find the derivative of f dash of z. So if it is analytic, right? So we know if it is analytic, if I am able to write my function fz in terms of z, okay, right? So its derivative I can directly do if I differentiate with respect to z if it is analytic, or simply also you can take the derivative with respect to z. That also you can do. Yeah, that also you can do, but yeah, this is the best way to go about it, right? If I take the derivative with respect to z. So let me first write this function in terms of z. Can I write this function in terms of z? So it is x square plus y square plus I to x y. So I see some hints here, right? So what is this? This is nothing but 2 into z, right? It is nothing but 2 into z. This is something else, I don't know what is this. This is simply z, right? And this is z bar, that is z conjugate. Okay. Ha. So if my function is 2 into, like if the derivative is 2 into z, what will be the actual fz? Simply integrate, because it is analytic, I can simply integrate with respect to z, that will be z square, right? That would be z square. So let me calculate what is z square in terms of x and y. So in terms of x and y, z square would be x plus iy whole square, that is x square plus I square y square plus 2i xy. So this would be x square minus y square plus 2i xy, right? So x square minus y square plus 2i xy. So I see exactly it is the function, whatever they have told me, right? So certainly this will be the derivative of my function fz. Now, because the function is analytic, we can only solve this by options, okay? And because it is because it is analytic, that's why the differentiation would follow this particular rule, right? So whenever these kinds of hints are given, make sure you use them and check with the help of options. So option A would be your correct answer for this question. If limit as x tends to 0 is minus 1 by 6, then a plus b by c would be equals to what? So simply I can, if limit exists, right, then I can use the L'Hopital's rule. So L'Hopital's rule would say that if I put x equal to 0 here, this is becoming 0 plus b plus c upon 0. So b plus c, sorry, b upon 0, right? If I put x equal to 0 in the numerator is b, right? And denominator is 0. So b upon 0, limit will exist if and only if b is also 0. Then only I will get 0 by 0 from it. Then only limit will exist, otherwise limit will not exist, okay? So yeah, so b has to be 0, that is for certain. B is gone. So if b is 0, now my limit converts into this a sin x plus cx upon x cube limit as x tends to 0. So I can use the L'Hopital's rule, so I can differentiate the numerator and the denominator. So that would be equals to a cos x plus c upon 3x square, okay? So yeah, now if I put x equal to 0, this would be a plus c upon 0 again. So again a has, like, a plus c has to be 0, otherwise limit will not exist, right? So a will be equals to minus of c. A would be equals to minus of c. So I don't even need to solve further. You can solve further, but you don't need to solve further, right? I can simply simplify. So a is minus c, b is 0 upon c. So this will come out to be minus of 1. So minus 1 will be your answer for the question. Of course you can solve, like you can find out the exact values of a and c, but that is not required for this question, okay? So minus 1 will be your answer for the question. The solution of this particular differential equation, if y equal to 0 is given as minus 3, what will be the solution? So if I try to solve this, right, I'm observing that first of all, this is this a linear equation? I can convert this into a linear equation, but then this will be very complex. Yeah, because y is also here, right? Y into dy is there. So this is definitely not a linear equation. So if I cross multiply dx, right, this will be 2xy minus, this is not a linear equation in x or y, into 9x square into dx plus 2y plus x square plus 1 into dy equal to 0, okay? Now if I observe one thing, right, if I differentiate this function with, partially differentiate this function with respect to x, this will be 2x. If I partially differentiate this function with respect to y, this would be 2x. So what is happening? That means it is, this equation is exact. If this equation is exact, so I can simply integrate this equation, right? So what I can do, I can integrate this side, okay? And for this particular integration, I can assume my y to be constant, and I can integrate my x terms, okay? And here what I will do, I will neglect my x terms, ignore x, okay? Ignore the x terms, only integrate the y terms, okay? So this will be x square by 2 into 2x 2y, that will be anyways 0. So minus 2 x square minus this will be 9 9, sorry, 3x cube plus, I will ignore the x terms, okay, only y terms I will integrate. So this will be y square plus y equals to c. Okay. Now one condition is given that y of 0 is minus 3, right? So y of 0, when x is 0, y is minus 3. So this will be 0 minus 0, this will be minus 3 whole square minus 3 equals to c. So c would be equals to, this will be 9 minus 3, c is 6. So my equation will be converted into this x square just give me 1 second, x square minus 3x cube plus y square plus y equals to 6. X square, yeah, this is minus 3x cube plus y square plus y equals to 6. So option 1 will be your correct answer for this question. Also, like, there is another way to solve this. Simply what you can do, you can differentiate this function, right? And then first of all you check the initial conditions. So you put y of 0, so if you put x equal to 0, right, in this equation, if I put x equal to 0, this will be, this is anyway 0, so this is coming 6 equal to 0, right? That is invalid. If I put here x equal to 0, y is coming out to be minus 6, again invalid, right? If I put x equal to, like, it is not even a uh, function of my uh, x. Okay, so y square plus y equal to 6, which is again incorrect, because at x equal to 0 y value should be minus 3, but if I put here minus 3, right, this will be basically, no, this is actually satisfying. Yeah, this is actually satisfying. This equation is satisfying, that y square plus y equal to 6 at x equal to 0, because it is independent of x, y is coming out to be minus 3, it is satisfying. Okay, but y is always minus 3, right? But it will not be, right? It has to be some function of x as well. You can further, like, already two options are eliminated. Whatever you do, you have to differentiate this function only once and then see if this differential equation is matching here. Otherwise only option A will be your answer. That's how you can solve smartly in the exam hall. Okay, the Nyquist plot corresponding to the open loop transfer function is shown. Okay, so I'm only plotting the positive frequencies. Nyquist plot for the positive frequencies, it is shown. Okay, so x is this distance and y is this distance. Okay, determine the magnitude of the ratio y upon x, where y and x represent their distance along real. Okay, y is the distance from the real axis, sorry, so it should be from the imaginary axis. Okay, y is the distance from the imaginary axis and x is the distance from the real axis. Okay, respectively. So like they are, like, don't worry about this, like, round off your answer to 3 decimal places. So y is this distance. Okay, so y is the value of my uh, this Nyquist plot when it is cutting the negative real axis, right, negative side. When the angle is minus 180, then the magnitude, right, magnitude of my function g of h of j omega is basically my y, the distance, right, that is my y. Okay, that is one thing. And what is x? So x, right, is this value, right, this value, this distance x, correct? So x is the magnitude of my OLTF when when my uh, when my angle of the OLTF is minus 90. Okay, so we can easily find out the values of x and y with certain conditions, correct? So uh, so what is the value of y? So for that, I need, first of all, need to find out, calculate the frequency at which the phase becomes minus 180. So what is the phase function? G of h of j omega, it would be minus of tan inverse omega uh, plus tan inverse omega by 2 plus tan inverse omega by 3. Okay, so yeah, so once I will equate this equals to minus 180. Okay, when does it become purely 180? So there is another way to solve for that minus 180 case, right? So when the phase will be totally minus 180, then there will not be any real parts present. So an easier way to find out is if I write the g of h of j omega directly. Okay, that would be basically 100 upon, this will be uh, s plus 1 into s square plus 5s plus 6. Okay, this would be 100 upon s cube plus 5s square plus 6s. Okay, uh okay, plus 6s is there, and this will be plus 5s, so 11s, and this will be s square plus 5s square, that is 6s square plus 6. So what happens is when it will cut the real axis, right, the phase will be minus 180. Basically there will not be any imaginary part. So if I replace my s with j omega, right, this will be 100 upon minus j omega cube minus 6 omega square plus 11 omega j plus 6. So when it is cutting the negative real axis, basically there must not be any imaginary term present, because the numerator is completely real, the denominator also has to be real, right? So this has to be 0, the imaginary part. That means basically omega cube uh, will be equals to 11 omega. So omega equal to 0 is not a solution, obviously. Omega cannot be equal to 0, because at omega equal to 0 I am lying here, right? So I will not consider that part. Omega equal to 0 I will not consider, I will only consider the omega equals to some other value. So that would be omega square would be equals to 11. I will consider that value, right? Because at omega equals to 0, the value of the function is something positive. So at omega equal to 0, this will be 100 upon 6. That is something positive, right? That I will neglect. I will only consider the negative part, wherever the value of the function is negative. So at omega square equal to 11, this will satisfy. So if I put omega square equal to 11 in this function, right, this will be 0. The actual value of the function would be 100 upon omega square equal to 11, that is minus 66 plus 60, that is minus 60, right? So this would be uh, 5 upon 3, minus 5 upon 3, which is absolutely correct, because it has to be something negative. But what I'm concerned regarding the uh, magnitude. So y would be 5 upon 3, because y is the magnitude of the gain, right? Magnitude, length, it is the distance basically. So y value I have got, that is 5 upon 3. Okay, what about the x value? So x value is the portion when the function is purely imaginary. There is no real part here, right? It is purely imaginary. So that means now I will equate this one to be 0. I will equate this to be 0, because it is purely imaginary. There is no real part here, right? At this point it is purely imaginary. It is cutting the j omega axis. The function is purely imaginary, so the real part will be 0. So basically your minus 6 omega square will be equals to minus 6 omega square plus 6 will be equals to 0. So from here I can say that omega square will be equals to 1. Okay, or omega will be equals to 1. I will ignore the negative solution, negative minus 1. So omega will be equals to 1. So if I put omega equals to 1 in the value of the function, right, that would be 100 upon minus j1 and plus 11j, correct? So that would be minus j will go, so j, hold on a second, so plus j 100, so minus j 100 upon 10, that is 10 minus j 10, which again makes sense, because this is the negative part of the imaginary axis, right, not the positive. So minus j 10 is absolutely correct. I was expecting negative only, right? I mean the negative side. So minus j10 I have got, but what is my x value? X value is the basically magnitude, right? Basically the length. X value is just the length, right? So x would be equals to 10 basically. Okay, so we have to find out y over x, y over x. So y is 5 by 3 over x, that is 10. So this would be 1 over 6. 1 over 6 would be 0.167. Okay, so your answer of the question would be 0.167. A system is described by the characteristics polynomial. This n1 be the number of poles lying on the imaginary axis, n2 be all the number of poles lying on the left hand side, n3 be the number of poles lying on the right hand side. Then this value n1 plus 2 n2 plus 3 n3 would be. So it is simply a Routh-Hurwitz quotient, right? RH quotient. So we have to basically first of all make the Routh table. So first of all I will have, let me write the things here. I will have s raised to power 6, s raised to power 5, s raised to power 4, s cube, s square, s raised to power 1, s raised to power 0. Okay, then I have yeah, this 3 and 12 and 3 and minus 18. 3, 12, 3 minus 18. Okay, 2, 4 minus 6, 0. Okay, so this would be 24 minus 12 uh by 4, correct? Sorry, by 2. 24 minus 12 by 2. So if I solve this, 24 minus 12, so 24, yeah, minus 12 by 2, that is 6. Okay, so we get 6 over here. I'm doing this correctly, right? 2 2 2 4, yes, 3 yeah. Okay, so yes, this will be 24 minus, yeah, 6. Then I have 6 minus 18. Okay, 6, sorry, plus 18. 6 plus 24 divided by 2, that is 12 only. Okay, this is also 12. Now what about the last one? Last one will be just this one will be copied correctly, minus 8, 18. That will be just copied, correct? Okay, okay. Now then this will be 0. This will be 24 minus 24. So I get a row of 0 here, right? I get a row of 0 here. This will be minus 36. Okay, plus 36. This also row. So basically I'm getting a row of 0. To solve the row of 0, what you do is we first of all write the auxiliary uh, equation, that is 6s raised to power 4 plus 12s square minus 18 equal to 0. So the coefficients of differentiation, like this is my auxiliary equation. Okay, the differentiation of this will be 24s cube plus 24s. Okay, so the coefficient of this auxiliary equation would be my the values here in the row table, that is 24, 24. And how do I find out the roots? The roots would be, let me do one thing, let me divide by, let me assume s square to be some x. Okay, and divide by 6. This will be x square plus 2x minus 3 equal to 0. So this would be uh, x minus 1 into x plus 3 equal to 0. So of course I will ignore the negative solution because like the roots are purely imaginary. So I will assume my s square to be, sorry, I have to choose the negative solution only, right? I have to choose the negative solution because in a row of 0 we get purely imaginary uh, roots. Okay, so here this will be uh, like your s square, x would be minus 3. So your s square is minus 3, or I can say my s is plus minus j root 3. So these are my imaginary roots. They got my imaginary roots. Now we can further solve it. Okay, okay, we got these roots. Okay, actually no, this also will be, no, we'll get 4 roots. Sorry, this also will be valid, right? We will not neglect this. S equal to like x equal to 1, that is s square equal to 1 also is a solution. I'm sorry, this also will be a solution, right? Yeah, these are valid. So s equal to plus minus 1, these are also my solutions. So I got 4 roots. Okay, 4 roots. Now if I further solve my route table, this will be again 24 is here, correct? So this will be 24 into 12 minus 6 into 24, that is 12 minus 6, 12 minus 6, 12 minus 6 is 6. Okay, this will be simply minus 18 again, this will be 0. So this will be 6 into 24 minus 6 into 24, so 24 plus 3, 24 plus 3 into 24, right? That is 4. So this is 96 actually. This will be 0 and this will be minus 18. So ultimately, right, there is only a single sign change, okay, in the last. So there is one sign change. That means how many number of right hand poles I will have? 1. Okay, I will have 1 right hand poles. Now that is already, that can be seen from here, right? This pole is the right hand pole, basically s equal to plus 1, right? Now okay, I have 3 right hand poles, and because I have one row of 0, from the row of 0 only there is a possibility that I will get my imaginary poles, right? So I have, how many imaginary poles I have? Imaginary poles 2. Only row of zeros can give me imaginary poles. Other than that, I'll never be able to get imaginary poles. Only auxiliary equation will give me symmetricity poles, okay, with respect to origin. So number of imaginary poles is 2. So how many left hand poles I will have? So overall, of course, it's a 6th order equation. I have 6 poles, out of which 1 is right hand, 2 is left imaginary. So 3 will be my left hand poles. Now what are they asking? So n1 is what? N1 is the pole number of poles lying on the imaginary axis. N2 is the poles lying on the left hand side, that is this N2, and N3 is the right hand side poles. So it is N1 plus 2 N2. So N1 plus 2 N2, that is 2 into 3 plus N3. N3 is 1. Okay, that is equals to 2, 6, 8, 9. So 9 will be your yeah. I hope I'm sorry. So what I'm doing, 6 plus 2, no, 9 is, sorry, 3 into N3, right? 3 into N3. So yeah, 11. 11 would be your correct answer for the question. The signal flow graph of a dynamic system is given, and the state variables x1, x2, x3 are defined according to the standard state space formulation. U and y are inputs and outputs respectively, right? U and y are inputs and outputs respectively. The controllability matrix of the system is shown. Determine of the product A cross B cross C rounded to 1 decimal place. So they are telling me that for a state space representation, the controllability matrix is shown. So do you remember, if I have a state space representation, x dot is equals to ax plus bu, right? Ax plus bu. Now what you will do? You can actually find out the controllability matrix. What is the controllability matrix? Right? Actually, this is QC. This is called as QC. That is equals to B into EB if it's a second order system, into, or A square B, right? Where all of these, right, each tells us the row. So not the row, the column. So these are all column vectors, right? I hope you remember the controllability matrix. And if we say that if the determinant of the controllability matrix is 0, then we say that the system is not controllable. Basically, if the rank is less than the order, right, then we say system is not controllable. Basically, that states that if the determinant is 0, that's all. So let's actually see here what is my B matrix. So for that, first of all, I need to properly write the state equations. So let me write state equations one by one. So this is the first state equation, right? X1 dot. So X1 dot is equals to what? So there are two nodes that are incoming to X1 dot. One is 2 in minus 2 into X1, minus 2 into X1. Another one is this one, right? X2 into 2. Two into X2. This is my X1 dot. What about your X2 dot? So X2 dot would be equals to minus 2 into X2 and plus U. Again, there are two nodes like that are incoming. So plus U. And this is actually 0 into U, right? There is no U term, so that's why 0 into U. In the third case, X3 dot will be equals to how many nodes are incoming? One node, two node. So this would be minus X3 minus 1 into X3 plus U, right? Other terms are 0 basically. So can you now tell me what is my A matrix, B matrix? So A matrix will be equals to, so let me properly write it actually. So your X dot, right? X dot is nothing but the vector X1 dot, X2 dot and X3 dot. That is equals to that is equals to this, right? X1 dot, this will be minus 2, this will be 2, this will be 0. Let me write the matrix properly, then I will explain, don't worry. This will be 0, this will be 0, minus 1, and then we can certainly write this is into the X vector, that is X1, X2, X3 plus then U, right? BU. Okay, so what is your B matrix? So you see that UE term is present here, this is 0, right? So this will be basically 0, 1 and 1. So like I have formed the A matrix, but you can understand, right? So minus 2 into X1, that is minus 2 X1, 2 into X2, that is 2 into X2, then 0 into X3, there is no X3 term, that's why 0 into X3, right? Similarly, you can do it for the other rows as well. Similarly, you can do it for here as well, right? So the first row will be equated with X1 dot, right? This first row. The second row will be equated with this equation. The third row will be equated with this equation. Got it? That's how we form the ABC matrix. So yeah, so now we need to solve this. So I know my A matrix, I know my B matrix. So my A matrix would be, so my controllability matrix would be B, then AB, and then A square B. Why? Because it is a third order system, right? Because there are three state variables. So B matrix, this is 0 1 1. Now what is A into B? So A into B would be this into this, right? So this is minus 2 into 0, 2 into 0, 2. 0 0 minus 1. And this will be okay. What about hold on a second, A into B, sorry, this is not the correct, right? So this is A into B, so this is the first element, minus 2 into 0, that is 0, 2 into, that is 2 only, and this is 0, yeah. So first row is 2, and this is minus 2, and this is minus 1. Okay, this is correct only. Okay, I already did the multiplication, so I'm a bit fast. So minus 2 minus 2 minus 1, it is just simply multiplication of this matrix with respect to this. So this is my AB, correct? Now I need to do A square B. So again, with this matrix, with this column matrix, I need to multiply A. So A is minus 2 to 0, 0 minus 2 0, 0 0 minus 1, right? So this would be minus 2 into 2 minus 4, this is minus 4. So this first row is minus 4, this is also minus 4, right? This is 0. So minus 4 plus minus 4, that is minus 8. Can you see, like, are the things matching? You see minus 8 here, you see minus 8 here, you see 0 here, you see 0 here, right? Things are matching, right? More things will match. Next row, right? So 0 into 2 is 0, minus 2 into minus 2 is 4, and this is 0, so this will be 4. So you see 4 here, you see minus 2 here, you see minus 2 here, you see 4 here. So this will be 0 into 2, 0, 0 into minus 2, 0, minus 1 into minus 1, that is 1. So yeah, you see 1 here, you see 1 here, you see minus 1 here, you see minus 1 here. So everything is matching. So all you need to calculate is A, B, C. So A is 2, A is equals to 2, B is equals to 1, C is equals to 4, C is equals to 4, A is equals to 2, B is equals to 1, C is equals to 4. So A cross B cross C is 8. A cross B cross C is simply 8, right? Hold on a second. C is 1. Sorry. C is not 4, right? What am I doing? C is 1. Sorry. C is 1. So A cross B. So C is this, right? This value. C is this value, the last element. So A cross B cross 3 will be actually 2, not 1, sorry. 2. So 2 will be your answer for the question.
Yeah, so this was a good question. You need to implement it using CMOS logic. So first, let's try to reduce it. Like, no matter from whichever the portion the question is coming, first task would be that always we will try to reduce the expression. Let's just say they would have asked that what is the minimum number of NAND gate required, what is the minimum number of NOR gate required. First task would be to reduce the expression. That's it. So let's make the K-map. So we are going to make the K-maps. Although this is a standard one, like AB plus BC plus CA bar, that is standard. But still, if you don't remember the standard results, still you can make the K-map. Okay. In the examination, again, relying on the standard results, I would prefer making the K-map. It will take me very less time. Okay. So this will represent A bar, A, B bar, C, B, 0, 0, B bar, C, BC, B, C bar. Right. Now AB would be here, AB, and A bar C, A bar C, A bar C, then BC. This is BC. BC is redundant, right? So what you are getting? You are getting as BC is redundant, so AB plus A bar C. This is the scenario that you are getting. Now what they are saying that complements are available and the input is also available. So A is also available, A bar is also available, B and C are also available. So what do you think? AB would require 2, this would also require 2, so total 4. But total 4 NMOS will be required. 4 NMOS will be required. Along with that, CMOS logic it is, no? So 4 PMOS will also be required, no? So I know a lot of people would have clicked on 4, but answer would be 8. Okay, 4 NMOS and 4 PMOS. So AB, A bar C, right? So how do we design it? Let's design it. So Y is equals to AB plus A bar C. So how do we design? We always design for Y bar. So AB plus A bar C bar. What we are getting? X plus Y bar. This could be written as, Y bar could be written as, this is X plus Y bar. So it could be written as X bar dot Y bar. Now this could be written as A bar plus B bar dot A plus C bar. So this is what we need to design. A bar plus B bar. A bar here, B bar here. Then AC. A C bar, right? This is grounded and this is your B node. So here complement would be coming, right? This would be made from PMOS. This will be pull up network, this will be pull down network. So pull down network I have designed. So what is the pull down network? A bar plus B bar dot A plus C bar, and bar of that would be your output Y. So basically here we will be getting Y equals to A bar plus B bar plus, sorry, A bar plus B bar dot A plus C bar, then whole bar of it. This is what we will be getting. So what will be the whole bar of it? This is something that I will be getting, right? X dot Y bar would be X bar plus Y bar. What is the bar of this? AB plus bar of this would be A bar C. A bar C. This is something we will be getting. So this is how we are going to design it, and PMOS circuit you can design on your own. This parallel will become in series, and this series will become in parallel, right? So A bar, B bar, and here A, C bar. So total 8 will be required. Okay, let's go to the next one. Flat band voltage we need to find. Flat band could be coming because of two guys. QSS, like the oxide charges, because of the oxide charges, right? And metal work function difference. Oxide charges are 0. It could be mentioned, it would have been mentioned. There is no fixed charges in the oxide, so this is 0. So your work, your flat band voltage is nothing but 5 ms. That means metal work function minus semiconductor work function. So 5 msi you can put semiconductor work function. Okay. So metal work, work function is already given. You need to find out the semiconductor work function. So electron affinity is also given, EC, EV, and this is our vacuum. So electron affinity 4.05 electron volt. 4.05 electron volt. This is conduction band, this is valence band, right? And this is a p-type semiconductor, so it will have some EFP as well, and in between there will be EFI as well, right? This will be EFP, in between there will be EFI as well. So middle one, like this band gap is given, so what will be this particular length? This is 1.12, so this will be half of it, which will be 0.56 electron volt. Now we need to find out this particular length as well. Then this total will be your semiconductor work function, right? So what will be this length? EFP, EFI minus EFP, that would be KT ln 0.0259 ln Na by Ni. Na value is also mentioned, 10 to the power 17 divided by Ni, 1.5 into 10 to the power 10. ओके अरे यार ये थोड़ा साइड ही हो जाए भाई. तो 10 to the power 7 divided by 1.5 ln 0.0259 0.0259 0.406. This is what we are getting, 0.406. Right, now all these things we are having, so 5 SI we can find out, 0.406 plus 0.56 plus 4.05, so it is coming out to be 5.01. Now our answer would be 4.1 minus 5.01. So minus 4.1. So what we are getting? Minus 0.917. That's the answer. Okay, this is your flat band voltage. Very straightforward it is. Let's go to the next one. What we need to find? Power spectral density we need to find. So for a LTI system, can you write down the power spectral density? The input is x of f, the transfer function is h of f, output is y of f. What will be the power spectral density of output? That would be h of f mod of h of f whole square s x of f, right? So in this particular scenario, what is the scenario? If this is your x of f, this is your y of f. So first let's find out the h of f. This is not the h of f, right? This is the whole system. This is the whole system. So what is the scenario here? Sir, x of f multiply with h of f plus, let's call it h dash of f. Okay, so this is your h dash of f. Then not plus, minus from here x of f would come, and that would be equivalent to y of f. This is the scenario, right? So x of f would be common, h dash of f, that would be j 4 pi f minus 1. That would be y of f. So what is the h of f you are getting? H of f you are getting as j 4 pi of f minus 1, right? So mod of h of f, what that would be? And then do the whole square. That would be nothing but 16 pi square f square plus 1. So this will be mod of h of f whole square. So what will be your s y of f? That would be nothing but 16 pi square f square plus 1 multiply with s x of f. Now you need to find out s x of f. What that would be? Simply the Fourier transform of this one. Fourier transform of this would be s x of f. So what is your rx of tau? Rx of tau is e to the power minus tau square by 2. I need to find out its Fourier transform. That would be nothing but s x of f, right? So e to the power minus at square. Do I ask you to remember it? Yes. Again and again the questions have been asked on this particular scenario in the gate examination. So under root pi by a, e to the power minus omega square by 4a. This is something that I ask everyone to remember. In place of a, what they are putting? 1 by 2. In place of a, they are putting 1 by 2. So this will become under root 2 pi e to the power minus omega square divided by 2a. In place of omega, you need to put 4 pi square f square. 2 pi f I need to put, so it will become 4 pi square f square divided by, this is simply 2 only, right? Because a is 1 by 2, no? So this is simply 2. So what we are getting? Under root 2 pi e to the power minus 2 pi square f square. So what we are getting? S x of f is coming out to be under root 2 pi e to the power minus 2 pi square f square. This is your s x of f. That means what will be your s y of f now? Mod of h of f whole square, which is nothing but 1 plus 16 pi square f square multiply with this value. So under root 2 pi I can take outside. Under root 2 pi I can take outside. And here it is e to the power minus 2 pi square f square. There you go. This is the answer, which is first option. That's it. This you would have cancelled out. And here these two are also getting cancelled out. Okay, well and good. Again, very straightforward question. These kind of questions are also asked in PYQs as well. Let's go to the next one. Yeah, so these are our symbols. Okay, sorry, these are our basis function and these are our symbols that we need to transmit. Then we will make the constellation diagram and we need to find out the distance. Okay, this question is not written properly. So D1 to we need to find out. Like basically, I will draw the constellation diagram and the distance between D1, the point of phi 1 and the point of phi 2, that distance we need to find out. Okay, the question is clear to you. It is there in front of your screen, although here it is not completely written. So let's check it out. What is your phi 1t? So they are the basis function. So I don't need to check whether they are basis or not, but still we can check it here. Although they are already saying that they are orthonormal basis functions, that means they have to be orthonormal to each other. Their power has to be 1. All these things should be already verified and they would have surely verified it as well. You don't need to check it, but still we are drawing the waveform so that we can proceed in a better manner. So what is the waveform? 1 by under root TB between 0 to TB. Energy is 1, I can directly sense it, right? Because these kind of things we have already seen. 1 by under root TB. What is the energy? Square of this multiplied by TB, it would be the same. And here first minus ut, then going upward by 2, then coming downward. That means the scenario would be somewhat like this. Minus 1, then going upward, then coming downward like this. This is your phi 2t. Okay, this is your phi 2t. So what this would be? This would be minus 1 by under root tb, minus 1 by under root tb, and this would be plus 1 by under root tb, right? This is something that we have made, and this would be tb only. This is your phi 1t, this is your phi 2t. You need to make phi 1t. Okay, this is not phi, this is psi actually. Psi 1t, psi 2t. The notation are actually very confusing. Psi 1t, psi 2t. You need to make phi 1t from psi 1t and psi 2t. Can you make it? Yes, sir. Very straightforward it is. Phi 1t is this, and this is your psi 2t. What do you need to do? A into under root tb minus a into under root tb. If I multiply this particular graph with minus a into under root tb, what I will get? This value will become plus a, this value will become minus a. Plus a, minus a, this particular graph I will be getting. So minus a into under root tb into phi 2t into psi 2t is your phi 1t. Is that equation clear to you? What about phi 2t now? Sir, phi 2t I need to make. So phi 2t is somewhat like this. It is like b, like this much portion is same, right? This much portion is same, b and minus b. It's just that here there is something more. Minus b more is there. Say yes or no. So first let's make this much part. How will I make this much of part? Similar thing, minus b into under root tb phi 2t plus. Now what I need to make? I need to make this much of part. How can I get this much of part? If I add both of them, phi 1t plus phi 2t. If I do phi 1t plus phi 2t, what I will be getting? Phi 1t plus phi 2t if I do. Sorry, psi 1t plus psi 2t if I do. What I will be getting? This plus 1 by under root tb minus 1 by under root tb will be getting cancelled out till tb by 2. Then from tb by 2 to tb, 1 by under root tb, 1 by under root tb, this will become 2 by under root tb. Right? But what do I need? Basically, this phi 1t plus phi 2t would be somewhat like this. 2 by under root tb between tb by 2 to tb. What do I actually need? I actually need minus b. That means under root tb b under root tb by 2. I need to multiply. So what I will be getting? Minus b there. Right? So minus b under root tb by 2. This is something I need to multiply. Is that clear to you or not? This is how I can write down my phi 2t. Phi 1t plus phi 2t I added. Then I know that, sir, what you will be getting is that the color of pen could be better. So what you will be getting is that 1 by under root tb, 1 by under root tb, 2 by under root tb. You need to get minus b. Minus b you need to get. Minus b you need to get between tb by 2 to tb by 2. So this graph should be multiplied with b under root tb by 2, and then there is a negative sign. So under root tb, 2 get cancelled out. So minus b you will be getting in this manner. Is that graph clear to you? So phi 2t could be written in a better manner, somewhat like this. So minus b by 2 under root tb psi 1t minus 3b by 2 under root tb psi 2t. Say yes or no. This is the equation 2 we should code. This is minus b by 2, this is minus b, so minus 3b by 2 psi 2t. Is that understandable to you? So can I make the constellation diagram now? Yes, sir. Make the constellation diagram, find the distance, that's it. So phi 1t, phi 2t you can show anywhere. I am showing what is our basis function. These are our basis functions. So psi 1t, psi 2t, psi 1t, psi 2t. So how you can get phi 1t? Phi 1t you can get if you work for minus a by under root tb in the direction of psi 2t. That means you need to work for this much. So 0 minus a under root tb, right? Minus a under root tb. This is your phi 1. This is your phi 1. And how you can get phi 2? So for getting phi 2, what you need to do is that you need to work for minus b by 2 under root tb in phi 1t direction, minus b by under root tb here, and then in psi 2t direction you need to go minus 3b by 2 under root tb. So let's just say this is your point. This is your phi 2. Phi 2 is nothing but minus b by 2 under root tb. Sorry, in the direction of phi 1t, in the direction of phi 1t you are going minus b by 2 under root tb. Yeah, it is fine. Minus b by 2 under root tb. And in the direction of phi 2t you are going minus 3b by 2 under root tb. Minus 3b by 2 under root tb. There you go. This is the scenario. So what distance we need to find out? This distance we need to find out. That's it. So what will be your d12? 0 minus this, that would be b by 2 under root tb whole square plus this minus this, and then you need to do the whole square. So a under root tb plus 3b by 2. Basically, okay, subtract I need to do, no? Subtraction I need to do. So 0 minus this would be this. Now minus a under root tb, then minus of this, that would be 3b by 2 under root tb under root tb whole square, and then take the under root. This is your d12. Now put the values of a and b and match the answer. So if a is 1, b is 2. If I put a equals to 1 and b equals to 2, so a equals to 1 and b equals to 2. So what is the value of d12 I am getting? B equals to 2 I am getting, this is becoming tb. A equals to 1 and b equals to 2. So this will become 3 under root tb, and this will be under root tb only, right? So this will become 2 under root tb, that means 4 tb. So we are getting under root 5 tb, under root 5 tb, under root 5 tb. That's it. A equals to 6, b equals to 4. A equals to 6 and b equals to 4. So what is the d12 value we are getting? B equals to 4, so this will become 2. B equals to 4, so 2 tb plus a equals to 6, so 6 and 6. So this will become, sorry, 4 by 2, 2 under root tb square, so this will become 4 tb. This will become 4 tb plus here if you put 6, so this will become 6 only. Here if you put 4, this will also become 6 only. So this part would be 0. So answer you are getting is 2 under root tb. So this is your d12. So 2 under root tb, 2 under root tb. There you go. That's it. So 2 and 3 are correct. Okay, well and good. So this was a good question, I would say, but again based on basics, based on very basics, right? Let's go to the next one. Yeah, let's see this one. Electron concentration and hole concentration graph is given, and like electron and hole concentration graph is given, right? So holes are diffusing in this positive direction in this manner. This is the diffusion of holes. Are bhai. Exponential diffusion is there, no? Sorry, this is not the diffusion, I should say. This is the profile of holes. And what is the profile of electrons? The profile of electrons goes somewhat like this. So this is about electrons, and this is about holes, right? So this waveform also I know, this waveform also I know, LP, Ln value I know. Now here there are more holes, here there are lesser holes. That means holes will be diffusing in this direction. That means what will be the direction of current? This will be the direction of current. Electrons will be diffusing in this direction. So direction of current would be opposite to it. Both currents will be added. Holes are diffusing in this direction. That means this will be the current. Electrons are diffusing in this direction, so this will be the current. So at x equals to 0, both of the currents would be added actually. So both currents would be added. This is like a derivation of PN junction only. Derivation of current of PN junction. But a different scenario is there. Right? So both currents would be added at x equals to 0. They are asking at x equals to 0 only. So both of the currents would be added. So what is our target? Our target is to find out the currents at currents because of the diffusion of electron at x equals to 0, current because of the diffusion of holes at x equals to 0, both we need to add up. That's it. Okay. So, and the current density they are asking. So what will be JPX? Don't care about the sign. Although here negative sign would come up, but don't care about the sign. We know that we need to add up both of the current. That's it. So I don't care about the sign at all. Although if I care it, you know that for in case of holes, negative sign would come. In case of electrons, negative sign would not come. 10 to the power minus 19. What is the value of dP? dP is 18. Now dP by dx 9 into 10 to the power 14. Then differentiation of this divided by LP. So LP is 5 into 10 to the power minus 4. So 10 to the power 18, 10 to the power minus 1. Now 18 into 9 divided by 5. 18 into 9 divided by 5. 18 into 9 divided by 5 into 10 to the power minus 1 into 1.6 divided by 10. So it is coming out to be 5.184. Everything is going in ampere only, ampere per centimeter square. What about GNX? So again Q into Dn, so minus 1.6 into 10 power minus 19. What is the value of Dn? 33. And here why I am putting minus sign? Here minus sign will not come. It will come by default. Now if you differentiate it, what you will get? 5.5 into 10 power 14 divided by ln. The negative sign would come here. What is the value of ln? 1.2 into 1.02 into 10 to the power minus 3. So this will become 10 to the power 17, 10 to the power minus 2 you are getting here. So 33 into 5.5 into 1.6 divided by 1.02 divided by 100. 2.847. So this was your JPX, and JNX is coming out to be minus 2.847 ampere per centimeter square. What will be the direction of current? Direction of current would be in the positive X. Okay. So just add up 5. So 8.03. So if we add both of them, the answer is coming out to be 8.03 ampere per centimeter square. Again, straightforward question. Okay, this is also done. Let's go to the next one. Power dissipated in the resistor they are asking. Whenever they ask about the, energy dissipation. So whenever they ask about the energy, our concern would be PT dot dt. That's it. And what is PT? Vt dot it dot dt. That means my concern is that I find out the voltage expression in the resistor and current expression in the resistor, and my job would be done. Multiply both of them, dot dt, circuit is starting at t equals to 0, so 0 to infinity. That's it. So voltage and current you can find out. Any way you can put, whatever the way is feasible for you. If you have studied from some other platform, then you will be applying Laplace transform. If you have studied from here, then you would know that just as I close the switch, then infinite current would flow, impulsive current would flow. C1, C2 both are equal. That means immediately voltage will change to 2.5 volt. Here also 2.5 volt. Here also 2.5 volt. And then eventually all the 2.5 volt will be discharging through the resistor R. Right? So what will be the VRT expression? Initially 2.5 volt, but discharging through the resistor R with the time constant of tau. Will be the time constant? What will be the time constant here? Time constant would be nothing but 2 RC, because both are in parallel. Time constant would come out to be 2 seconds. Sir, how did you write down this expression? It is completely based on transient, okay, and an intuitive way of studying the transient. I know you have studied in Laplace domain. It's your choice, okay. When we study in intuitive way. 3 kind of circuits are there: when there is no resistance, when the resistance is in series, and when the resistance is in parallel. This kind of question would be coming. Even educators and students, everyone will be solving with respect to Laplace transform. But those who have studied in a good manner, they will be solving with respect to transient analysis, actual transient analysis. So here impulsive current would flow, voltage will be divided, then complete discharging would be there. This is how the voltage equation is coming. Then directly I can write down the current equation. That would be 2.5 divided by R. That would also be divided by R. R would be 1 only. So that would also be the same. Minus T by 2. This will be volt. This will be ampere. So multiplication of both of them. 2.5 into 2.5, that would become 6.25. E to the power minus T by 2 multiply with e to the power minus T by 2 dot dt. So this will become e to the power minus T. Right? E to the power minus T by 2 multiply with e to the power minus T by 2. That would become e to the power minus T. And integration of e to the power minus T from 0 to infinity. Integration of e to the power minus at dot dt from 0 to infinity, that is 1 by a. So e to the power minus t dot dt from 0 to infinity, that will throw 1. So what is the power dissipated? That means that is 6.25 joule. Okay. So power dissipated would be 6.25 joule. That would be the answer. Let's go to the next one. So this was the pole zero diagram that was given, and you need to find out the frequency response. So what kind of h of z you will be getting? There is any zero? No. It could have some gain. I don't care about it. Where will be the pole? Pole is less than 1. Let's just say this is 1 by 2. I can assume anything, no? 4 options would be given. There 4 options are given. Okay, in your question, you can see the question, 4 options are given, right? So I can assume it to be 1 by 2. Let's assume it to be 1 by 2. I can assume anything. So what will be your h of e to the power j omega? K e to the power j omega minus 1 by 2. Now you need to draw the frequency spectrum, right? frequency spectrum you need to draw. I guess they asked about the magnitude spectrum only. Okay, they were asking about the magnitude spectrum. So magnitude spectrum you need to draw. So I told you always check at 3 points. At omega equals to 0. At omega equals to 0, what is the scenario you are getting? E to the power j0, that would be 1. So 2k, some constant value you are getting. Check at omega equals to j pi by 2 as well. So k e to the power j pi by 2. What that would be? J only. J minus 1 by 2. So that would be k under root 1 plus 1 by 4. That would be 5 by 4. So this is coming out to be 2k by under root 5. So 2k by under root 5 is surely less than this. This value is more, this value is less, right? And at pi you need to check. If you check at pi, e to the power j pi, what that would become? Minus 1, right? So minus 3 by 2. So that would become 2k by 3. 2k by 3. So which value is more? This is the highest one. Then between these two guys, who is higher? Under root 5 is higher or 3 is higher? 3 is higher, no? That means this value is least. So you can sense that from 0 to pi. From 0 to pi, from 0 to pi, your magnitude is constantly decreasing. Here also I have written down the magnitude. You would say, sir, where the negative sign goes? We are talking about the magnitude spectrum. So from 0 to pi, your magnitude is constantly decreasing. It will work as a low pass filter. And after pi, it will keep on repeating. Not after pi, after 2 pi, it will repeat. Right? So here, this kind of spectrum would be there, and then it will repeat in this manner. Okay? So low pass filter, it is working as a low pass filter, and this was there in the options. Very straightforward, very, very simple question. Let's go to the next one. So frequency modulation is there, and kf value is mentioned. What does that mean? Can I write down the instantaneous frequency? Yes, sir. It would be nothing but fc plus kf mt. Right? So fit would be nothing but what is the value of fc? Fc is, let's not write it down because we have to divide it. So let's not write down the value. So what will be your omega it? So omega it would be nothing but omega c plus 2 pi kf mt. So what will be your theta it? So theta it would be nothing but omega ct plus 2 pi kf running integration of mt. Right? So what will be your theta it? What is omega ct? That would be 20,000. This is your 20,000. 20,000 t plus 2 pi kf m of tau dot d tau. From here I can see that, sir, my theta it is nothing but 24,000 t. What does that mean? It is 20,000 t plus 4,000 t. That means this particular thing would be equals to 4,000 t. That means 2 pi kf, value of kf is 2k minus infinity to t m of tau dot d tau is coming out to be equals to 4k t. This 2k, 2, and this is getting cancelled out. So what you are getting? Minus infinity to t m of tau dot d tau is coming out to be equals to t by pi. T by pi. When this running integration goes here, what you are getting? M of t is nothing but d by dt of t by pi. That means m of t is coming out to be nothing but 1 by pi. It is not even a function of time. This is given just to confuse you. This is your m of t. That's it. Which is 1 by pi. Okay, so at any time I can ask you 0.5 second wherever I want to ask. It is not even a function of time t. Just to get you confused, this was given at plus b. So just to take the reciprocal of pi, 0.318. 0.318, that would be the answer. Okay, very straightforward question, very, very straightforward. These kind of questions are there, would be there in your class notes as well. Let's go to the next one. Yeah, that's a good question. Let's see the solution of this one. Like, you are not confused between these two, but you are actually confused between these two, right? So let's see the first one. If HT is periodic, impulse response is periodic. If your impulse response is periodic like this, if it is periodic like this, then it is surely not absolutely integrable. That means minus infinity to infinity mod of h of t dot dt. Will it be a finite value? No. If it is not a finite value, what does that mean? That means it will be unstable. Right? So this is something that has been written. Now mod of h of n is less than k. Will that be satisfying the condition of stability? No. This is the condition of stability, no? That mod of h of k, where k goes from minus infinity to infinity, this should be less than or equals to m. Or you can say that it should be finite. It should be finite. This is the condition of stability. Now here I can take the example that h of n is un. If your h of n is un, This is the graph. All the values are less than a particular value. That means all the values are finite values. But still, is it absolutely integrable? No, it is not absolutely integrable. What does that mean? That h of n equals to un. That is a unstable system, right? And it is pretty obvious as well, because it is not absolutely integrable. So it is stable? No, right? This is the condition of stability. Now the second one. For a discrete time LTI system, if a discrete time LTI system is causal, then its step response is 0 for n less than 0. What will be the step response? What is the meaning of step response? Step response means simply input is un convolved with h of n, right? Where this is your impulse response and this is your input. So your step response could be written, anything convolved with u of n could be written as running summation. Say yes or no. So S of n could be written as minus k going from minus infinity to n h of k. Say yes or no. Now what they are saying? They are saying that if a discrete time LTI system is causal, your LTI system is causal, that means this is a causal signal. Say yes or no. That means h of n equals to 0 for n less than 0. Say yes or no. That means let's just say if I put n equals to minus 1. So what will be your s of minus 1? So that would be summation k going from minus infinity to minus 1 h of k. That means all the samples will be added which are present between minus infinity to 1. That means h of minus infinity dot 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 h of minus 3 plus h of minus 2 plus h of minus 1. What that would be equivalent to? That would be equivalent to 0 only. That means s of minus 1 will be 0. What will be s of minus 2? Similar thing would happen here, no? All the samples are 0 only. So what does that mean? That means s of n is coming out to be 0 for n less than 0. This is something that has been written. This statement is correct. Now next one. If the step response s of n of a discrete time LTI system is 0 for n less than 0, that means if this guy is causal, then this will be also causal. This is what they are saying. So shall we check it? From here, if I need to write down h of n, how I can write it down? This is running summation. When it goes here, it will become difference. That means this is how I can write it down. Like basically s of n was nothing but h of minus infinity and so on h of n. Right? Basically it could be written as s of n was nothing but, although I have proved it in the class itself, but say here again I am proving, h of n plus h of n minus 1 plus h of n minus 2 and so on till infinity, right? So what will be s of n minus 1? In place of n you need to put n minus 1. So in place of n I am putting n minus 1. In place of n I am putting n minus 2. Then n minus 3 and so on. When you subtract both of them, s of n minus s of n minus 1, what you are left with? This and this will get cancelled out, this and this will get cancelled out, only h of n will be left. So there you go. So this is how I can write down my h of n, right? Now what they are saying? That s of n is 0 for n less than 0. This is what they are saying. So surely s of n minus 1 would be 0 for n minus 1 less than 0, or you can say n less than 1. So your s of n minus 1 would be 0 for n less than 1. So for n equals to 0, what will happen? At n equals to 0. At n equals to 0, if you check the value, h of 0 would be this particular thing. Now this could be non-zero, h of 0 could be non-zero as well. What will be h of 1? What will be h of 1? H of 1 would be s of 1 minus s of 0. Both could be non-zero, I don't care about it. But what about h of minus 1? H of minus 1. So that would be s of minus 1 minus s of minus 2. S of n is 0 for n less than 0. This will also be 0, this will also be 0. That means h of minus 1 will also be 0. What about h of minus 2? Sir, s of minus 2 minus s of minus 3. 0, 0, 0. H of minus 3 and so on. What does that mean? That means from here also you can say that h of n is coming out to be n 0 for n less than 0. What does that mean? That means that if this is the condition, what does that mean? System is causal. System is causal. This is the statement that has been written. The system is causal. So both sides it is going. What does that mean? that if h of n is a causal signal, then then the step response will be causal, and if step response is causal, then your system will be causal. Is that understandable to you? So again, very important statement in the examination, it can be surely coming in the future. But again, solving these kind of questions in the examination hall will be very difficult. But this is how you can think. Is that understandable to you? Okay. So this was a good question. Let's go to the next one.
The residue of the function fz equals to this at z equal to 1 would be, sorry, this will be square here. By mistake, this is raised to the power 4. This will be square. Okay. So what is the formula for residue of a repeated pole? It's a like pole, repeated pole, right? So the formula for residue of a repeated pole is basically, if let's say it is repeating n times, right? So the formula would be, residue would be 1 by n minus 1 factorial into d of raised to the power n minus 1 divided by d of z n minus 1 into fz. Okay. Z basically multiplied by the, of course don't forget to multiply by the location of the pole, z minus a basically, where z is equals to a. I put at the end. Okay, z minus a raised to the power n. Okay, so here this will be 1 by 3 factorial into dn minus 1, sorry, 1 by 2 factorial, because it is repeating, sorry, it is 1 by 1 factorial because it is repeating only once, correct? So d raised to the power 1 dz into z cube upon, this will be, I can simplify, z square minus 5z plus 6. Okay, so this will be equals to 3z square into z square minus 5z plus 6 and minus z cube into differentiation of the other function, that would be 2z minus 5 upon z square minus 5z plus 6 whole square. So now I can put the value of z, that is z equals to 1. I can put the value of z equals to 1. So this would be 3 into 7 minus 5, that is 2, minus 1 into minus 3 divided by, this would be 7 minus 5, that is 2 square. Okay, so 6 plus 3, 6 plus 3, that is 9 by 4. So 9 by 4 would be your answer for the question. For a certain binary communication channel, okay, it's a binary communication channel, that is either 0 or 1 will be transmitted. The probability that it transmitted 0 is received as 0 is 0.95. Okay, so if I'm transmitting 1, there is a probability that I will receive, sorry, if I'm transmitting 0, there is a probability that I will receive 1 due to some error in the communication line, and the probability is 0.05. Okay, the probability that transmitted 1 is received as 1 is 0.9. Okay, and it is received as 0 is 0.1, then the remaining would be 0.1 basically. If the probability that 0, if the probability that is 0 is transmitted, if the probability that is 0 is transmitted is 0.4, so probability that I am transmitting 0 is 0.4. Okay, 0 is transmitted is 0.4. What is the probability that 1 was transmitted given that 1 was received? Okay, what is the probability that 1 was transmitted given that 1 was received? So they are asking me what is the probability that 1 was transmitted given that 1 was received. So simply, what is the probability that 1 was transmitted? It was 0.6. Now you say this is the answer. No, this is not the answer, because it is conditional probability. Some information is given to you, right? What is the information? That we already know that we are receiving one. If I am receiving one, right, that means there is a high probability that one will be transmitted, because if I'm receiving one, then like there is 90% chance, right, one was transmitted. Okay, if I'm receiving the correct value, but I don't know whether I'm receiving correct or not. So there are two cases here, right? Two cases. Either I was transmitting 0 and I received 1, because this is given to me in the question, or I transmitted 1 and I received 1. So we need to find out the condition case for which I was transmitting 1, given that I received 1. So what is the total probability of receiving 1? There can be two things. Either I transmitted 0 and due to some error in the communication line, right, I got 1. So what is the probability? 0.05. So first we need to transmit 0. So probability for transmitting 0 is 0.4. And what is the probability of error in transmission of 0? 0.05. So then I will receive a 1 at the receiving side. Or other probabilities, if I am transmitting 1, the probability to transmit 1 is 0.6, and of course I'm receiving 1, that means the communication line has to be error free. What is the probability of error free communication line when I'm transmitting 1? 0.9. So this will be 0.9. Okay, now this is the probability of receiving a 1. Now they are not asking me this, they are basically asking me what is the probability that I transmitted 1 given that I have received 1, right? So how do I calculate this? It is the probability that I transmit 1 and receive 1 intersection upon probability of receiving 1, correct? So what is this intersection? When I am both transmitting 1 and receiving 1, it is this value, right? This value. When I am both transmitting 1 and receiving 1. So if I solve this, this will be 0.4 into 0.05 plus, sorry, no, not this. This will be 0.6 into 0.9 upon this whole value, right? This whole addition. So let me just calculate this value. 0.4 into 0.05 plus 0.6 into 0.9, that is 0.56, right? 0.56, this into 0.6 into 0.9, that is 0.964. So yeah, approximately your answer would be 0.964. This will be your answer for the question. What is the area bounded by the curves y equals to x into mod of x and y square equals to mod of x? Assume range of y for second function is this, right? Range of y for second function, basically this range of y, right, with output of this function, right, that is y value can only lie between 0 to infinity. Okay, okay. The area bounded by the curves y into mod of x, so y equals to x into mod of x. So what is mod x? Mod x function is this. This is my y equals to mod of x. And what about my y equals to x function? Y equals to x function is this, right? Or we don't even need to multiply these functions. Like what you can simply do is you can define the function for y greater than 0, sorry, x greater than 0 and x less than 0. So y is equals to minus of x square when x is less than 0, because mod of x will be replaced with minus x, and y will be equals to plus of x square when x is greater than 0, because mod of x will be replaced with plus x. So if I plot the function, right, like x square is something like this, right, but I have to write in the negative region, I have to write minus of x square, so it will be something like this. Okay, and positive, it does not matter, like it will be same, it will be concave of, so here it will be same only, right? So it somewhat looks like a cubic function, this is my y equals to x into mod of x. What about the second function, y square equals to mod of x, right? Now they're telling me that the range of y is always it is between 0 to infinity, right? Like these are real numbers, it is between 0 to infinity. So y square is between 0 to infinity. What you can do, you can take the under root on both sides. If I take under root, so my this value, right, is always positive. Y square is always positive, right? It is real, y square is always positive. So if I take the under root on both sides, what will I get? This will be plus minus under root of mod of x, correct? If I take the under root on both sides. So already what they are telling you that your y value is always positive. Y value is always positive actually. And I should also mention the domain of x as well, right? So your range of y is between 0 to infinity. So obviously I will choose the positive number. I will not choose a negative number. And here I will mention the domain of x. Domain of x will be also same. It will be between 0 to infinity. Okay, infinity actually should not be included here. That's a mistake on my behalf. This should also be curly bracket. Right. So basically your y will be equals to plus under root of x, because the domain of x is positive. So mod of x will always be replaced with plus x only, right? And your y, range of y is also positive. So this negative sign I will not choose. I will always choose positive value. So do you know how to plot mod of x? So mod of x plot would be not mod of x, sorry, under root of x. It will be somewhat like this, right? And they are finding, they are asking me to area bounded by this curve. So basically they are asking me the area of these two curves, right? So this is nothing but my y equals to under root of x, and this curve is nothing but y equals to x square. Very simple. So they are technically asking me this value. What are the common points? X equal to 0, y equal to 0. Here this, what is the common point? X equal to 1, y equals to 1. Right? These two are my common points. So you can solve using anything, vertical strip or horizontal strip. It is totally up to you. So this will be double integration dx dy, right? Because I have to compute the area. Now if I choose dx, right, that will be a problem. Let me choose dy, because I'm choosing the limits of y, right? I'm choosing the limits of y. So let me choose dy. Y, this bottom curve is y equals to x square, and this top curve is y equals to under root of x. And x is going from what? X is going from 0 to x equal to 1. 0 to 1. So this value would be 0 to 1 under root of x minus x square dx. This would be x 3 by 2 by 3 by 2 minus x cube by 3. X is going from 0 to 1, right? So for 0 this is 0 only. For 1 this will be 2 by 3 minus 1 by 3. That would be 1 by 3. So 1 by 3 would be your answer, that is 0.33. So 0.33 would be your answer for this question.
Now, is it tough? Is this particular question tough? No, it might be a bit time taking if you do it in a hurry. Have some patience. Hilbert transform, I need to take Hilbert transform. All these things I know. What is xt? Xt is a baseband signal 1 megahertz. Can I draw it? Yes, sir. What will be the Hilbert transform of xt? X conjugate t. What is the meaning of Hilbert transform? If x of t is having a Fourier transform of x of f, then x Hilbert transform t would have a Fourier transform of minus j signum f x of f. That means positive frequency will be multiplied with minus j, negative frequency will be multiplied with plus j, right? So x conjugate f I will be able to make. So this is how x of f, this is your x conjugate f. Positive frequencies, here I am assuming the magnitude to be 1. Positive frequencies multiply with minus j, negative frequency multiply with plus j, right? This much is clear. Now Hilbert transform of sine omega ct. Let's just put sine omega ct. This is our sine omega ct only, where our fc is nothing but 10 megahertz. You can sense that fc is 10 to the power 7, that means 10 megahertz, right? So sine omega ct, what is the Hilbert transform of sine omega ct? Hilbert transform is the 90-degree phase shifter. So what that would be minus cos omega ct. So here minus cos omega ct would come, and that will be multiplied. So when cos omega ct was multiplied, then what would have happened? Center will move to 10 mega. Here center of this particular thing will move to 10 mega and minus 10 mega, and amplitude will be divided by 2, but this time it will be divided by minus 2. Why is that so? Because here what is the scenario? Here minus cos omega ct is coming. Here minus cos omega ct is coming. When you multiply a signal with cos omega ct, xt multiply with cos omega ct, what happens in the frequency domain? One center moves to fc, other center moves to minus fc divided by 2, amplitude divided by 2, but here there is a negative sign, minus cos omega ct. So amplitude will be divided by, this negative sign can go here, amplitude will be divided by minus 2. So this will move to tan mega, amplitude will be divided by minus 2. So this will become minus j by 2, this will become plus j by 2. So this is the scenario you will be getting, plus j by 2 minus j by 2. Similarly, this will move to the negative hand side as well. Plus j will be divided by minus 2, that will become minus j by 2, right? And minus j divided by minus 2, that will become plus j by 2. Is that clear to you? This is the scenario that would happen. Let's call this particular thing as xt alpha t. So this is your alpha f. This is the alpha f I have drawn. Okay. This center will be moved to 10 mega. This was already minus 1 mega, 1 mega. So this will become 11 mega and this will become 9 mega. This is minus 9 mega. This is minus 10 mega and this is minus 11 mega. Let's go to the next one. So till this point we have find out. Now here xt multiply with sin omega ct. What does sin omega ct do? X of f minus fc divided by 2j minus x of f plus fc divided by 2j. Positive frequency will be divided by 2j, negative frequency will be divided by minus 2j. Center will move to 10 mega, this will be divided by 2j. 1 divided by 2j, what does that mean? Minus j by 2. So this is how I am showing, j by 2. So minus j by 2 I will show downward and this will become plus j by 2. Is that understandable to you? Positive frequency divided by 2j, that means it will become minus j by 2. So this 1 will become minus j by 2. 1 will become minus j by 2 and this will become plus j by 2. Is that understandable to you? Right? And what all these are frequencies are there? This is 10 mega, 11 mega, 9 mega. Look here, it requires patience. Okay. This particular question requires the patience. If you just solve it in a hurry, then you will be messing it up. Then you need to add both of them. Just add both of them. What will happen? Sir, this and this will get cancelled out and this and this will get cancelled out. These two guys would be added and these two guys would also be added. So this is minus j by 2, minus j by 2, it will become minus j. This will become plus j by 2, plus j by 2, it will become plus j. So this is something I will be getting. Just waveform is not correct. It will be looking like this. This will be your plus j. And what about this one? Minus j, it would be looking like this only. So let's call this as, this is your beta t and let's call this as gamma t. Not gamma t because it will look like y only. Let's call it pt. Okay. So this was your beta f and this is your pf. Now what is your yf? Yf is simply the Hilbert transform. Again Hilbert transform you need to take. Positive frequency multiply with minus j. So minus j, this will be minus only, right? This is already minus j, right? When we added, this was already minus j. Multiply with minus j. Minus j multiply with minus j. Positive frequency multiply with minus j. What you will be getting? Minus sign plus j square. What that would be? Minus 1 only. So this will be minus. This will be minus 1. This you are getting as minus 1. And don't forget about these frequencies. These two are, 9 mega, 10 mega. 9 mega, 10 mega. This is your minus 9 mega and this is your minus 10 mega. Now, positive frequency multiply with plus j. So j multiply with j. What you will be getting? Minus only. Positive frequency multiply with plus j. So here also you will be getting negative only. So this is the scenario you will be getting. Say yes or no. Minus 10 mega and minus 9 mega. This is what they are saying. Okay. So these frequencies are 9 mega and 10 mega. What they are saying? Maximum frequency of yt is 11 mega? No. Maximum frequency of yt is 11 mega? No. Maximum frequency of yt is 10 megahertz? Yes. Maximum frequency of yt is 10 megahertz? Yes. With the bandwidth of 1 mega? Yes. With the bandwidth of 1 mega? With the bandwidth of 1 megahertz? Yes. Now if yt is multiplied with cos 2 pi fct again and it is passed through a low pass filter of cutoff frequency 2 megahertz and pass band gain of 1, then we will get the information of xt. So if it is multiplied with cos 2 pi fct, cos 2 pi fct, what does that mean? This center 0 will move to 10 mega and minus 10 mega. So this will become 0, this will become this center will be moving to plus 10 mega and minus 10 mega, right? So what will happen? When it is moved to plus 10 mega, what does that mean? That means I need to add a page. And here this magnitude was -1, this magnitude is -1, right? Now this will become 0, this will become, when it is moved to, when the center is moved to 10 mega. So what will happen? This will become 0, this will become 1. 0 and 1. 0 and 1. This is the scenario. Then it is 10 mega. Now next, this 9 will become 19 and this 10 will become 20. 19 and 20. 19 and 20. Right? So this is 0, this is 1 mega, 19 mega and 20 mega. Similarly, it will move to minus 10 as well. So this will become 0. This particular thing will become 0 and this particular thing will become -1. So here the scenario you will be getting is this one, 0 and -1. And don't forget that amplitude will be divided by 2, right? Here amplitude will be divided by 1 by 2. Here also it will be divided by 1 by 2, right? So this is something we will be getting, and here this is the scenario we will be getting. What will happen is that this will be moving to 11m, sorry, minus 20m, and this will be moving to minus 19m. I don't care about all these things, just I care about one thing, that sir, this is 1 mega, this is -1 mega. Now if I pass it through a low pass filter, of a cutoff frequency 2 megahertz, cause cutoff frequency 2 megahertz and pass band gain of 1, right? So cutoff frequency of 2 megahertz, cutoff frequency, what is this point? This point is minus 19 mega. Cutoff frequency of 2 megahertz, this could be the low pass filter. So if I am passing from here, this is -2 mega, this is +2 mega. What does that mean? This information would be passed, and it is looking like just the inverted version of this, right? So it is looking just like a inverted version of this. That means minus xt by 2. So are you getting the information of xt? Surely you are getting the information of xt. We get the information of xt, yes sir. This is nothing but xt by 2 only, minus xt by 2 only. So you pass it through a inverting amplifier which provides a gain of 2. Inverting amplifier which provides a gain of 2. What you will be getting? You will be getting xt only. I hope there is no calculation error. 1 by 2, 1 by 2 only. So yeah, 1 by 2, 1 by 2. Yeah, everything is fine. Okay. So yeah, we are getting the information of xt. Yes, we are getting the information of xt. So it was a straightforward question only, not very difficult. It's just that you need to have some patience. You have some patience, you will be able to solve it. Let's go to the next one. Yeah, so that's an interesting problem. So here, what is the conventional way, like if you need to apply the mathematics? So you can find out V naught s divided by V in s, you will get the transfer function, or you can do then is divided by V in s, you will get that transfer function. You can tell whether it is first order or second order, whatever it is. This is the mathematics. If you need to see the intuitions, so across the inductor L, if I say that my voltage is V naught, this is one variable that I am introducing. This is already input voltage that I already know. This is one state variable that I have introduced. Then that means across this inductor L, I can write down the potential in terms of known state variables. This is also known to me. This is also known to me. This is also this is not a state variable. This is a fixed input voltage, right? This is a state variable that is known to me. So here I don't need to introduce another state variable. That means with respect to the voltage, with respect to V naught T voltage, it is a first order circuit. It is a first order circuit. So the transfer function would be somewhat like this. V naught as V in S. What will come in the numerator, I don't know. But in the denominator, I know that, sir, S by A plus 1. This kind of scenario would come. First order circuit it is, you know. So this is first order. Now what about the current? What will be the current? What is your IS? IS is nothing but V naught S divided by the resistance LS, right? So if I need to replace this V naught S, so V naught S would be written as IS into LS divided by V in S. That would be something in the numerator divided by S upon S by A plus 1, and this LS can go here. This LS can go downward now. So IS by V in S is looking somewhat like this. IS by V in S is looking somewhat like this. Yeah. So IS by V in S is looking somewhat like this. Now, can you directly say that, sir, it will be second order? Luckily, if you have said that this is second order, then it would be okay for you. You would get the correct marks. But it might happen that here there is a 0 at S equals to 0. If there is a 0 at X equals to 0, let's just say here there was some term of AS, then what would have happened? This and this would have got cancelled out and it would become a first order circuit. Similarly, you see this simple RL circuit, no? Simple RL circuit. This is your V in S, this is your V naught S. So what is your V naught S by V in S? That is, you simply know that, sir, it is LS plus, that is LS upon LS plus 1. So here, if I talk about this current as well, I naught S. So if I find out I naught S divided by V in S, so what will happen? I naught S is nothing but V naught S into V naught S divided by LS. That means V naught S is nothing but I naught S into LS. So this LS will go here and LS plus 1, and then there is LS. So LS is getting cancelled out. So with respect to current as well, it is first order. With respect to voltage as well, it is first order. With respect to voltage, with respect to current, in both of the cases, it is first order only. Why is that so? Because here pole 0 cancellation was there. So always you need to check at omega equals to 0. At omega equals to 0, what is the scenario? If you are getting a 0 at omega equals to 0, then there is an issue, right? So are we getting a 0 at omega equals to 0? So let's go to this particular circuit and check at omega equals to 0. At omega equals to 0, what is happening? At omega equals to 0, this will provide 0 impedance, this will also provide 0 impedance. Whole circuit is shorted. What does that mean? Voltage will be simply divided. So how the voltage will be divided? 2 by 3 into V. So at omega equals to 0, you are getting a gain of 2 by 3 at omega equals to 0. That means omega equals to 0 is not a 0. What did I did? I put omega equals to 0 here. So this is also becoming 0, this is also becoming 0. Whole circuit is shorted. What does that mean? Voltage has to be divided now. So how the voltage will be divided? This is L by 2 and this is L. So it will be divided in this manner. This is L by 2, this is L. So it will be divided in 1 by 2 upon 1 by 2 plus 1. So it will be divided as 1 by 3 into V. That would be your V naught. So at omega equals to 0, at 0 frequency, this is what you will be getting. So your 0 frequency, at 0 frequency, your gain is 1 by 3. At 0 frequency, your gain is 1 by 3. So at 0 frequency, surely you are not having a 0. That means, yes, this pole 0 cancellation will not take place. Pole 0 cancellation will not take place. That means it is a second order circuit. So this was the first order circuit, this is the second order circuit. So value of X is 2, value of Y is 1. That's it. Okay. So with respect to V naught S, V in S, only one state variable is there, first order. With respect to IS divided by V in S, it will be second order. Why is that so? Because, sir, in place of V naught S, when I am putting IR, IS into LS, so LS goes here. If this LS goes here, then what do I see? Pole 0 cancellation I need to check. I checked at omega equals to 0. I go to know that, sir, both whole circuit is being shorted. That means the gain is becoming 1 by 3. V naught is not coming 0. If V naught was coming 0, then you would have said that, yes, sir, there is a 0 at 0. Like here, if you put omega equals to 0, what will happen? This inductor will be shorted. That means V naught S is coming out to be 0. So from here, intuitively, you can say that, yes, sir, we are having a 0 at 0. We are having a 0 at 0. But in this particular case, you are not having a 0 at 0. So this is a second order, this is a first order. Let's go to the next one. Yeah, so let's see the solution of this one. This is more of a mathematical question than the EDC. Okay. Two diodes are there. You can read the question. We need to compare the depletion width. First, if we are comparing the depletion width, I know that it would require the built-in potential, right? 2 under root epsilon Si by Q 1 upon Na plus 1 upon Nd into built-in potential. So Na and D I can compare, but again, sir, built-in potential. So again, built-in potential would be required, because what is the formula of built-in potential, sir? I know that Kt ln Na and D by Na square. So first I will tell you that how it should have been solved in the examination. Then we will go by the conventional approach as well. So first let's see how it should have been solved in the examination. Now you know that, sir, in this case, in diode A, this Na value is more. If Na value is more, that means built-in potential will be more. So this value will be more in case of A. In case of A diode. In case of diode B, what is the scenario? That, sir, ND same everywhere, ND is same. What about Na? So sir, this NA value is lesser here. That means this value will be more. So here your B is winning. B is saying that NA is lesser, so built-in potential, so this depletion width would be more. But A is saying that built-in potential is more. So who will win? So built-in potential is having the Ln relation, logarithmic relation, and doping is having 1 by x relation. Basically, if I talk about the doping, so doping is having this relation, right? But built-in potential is having Ln relation with the doping. Like basically the scenario is this versus this. So logarithmic doesn't move very fast, but this will move very fast. So we have to listen to the doping thing. So if doping is lesser, then width will be more. Built-in potential of A is more. That would say that sir, width is more. But you need to look at the doping. Doping will be the deciding guy. Don't care about this guy. And you can check as well. But this is how we should be looking at the problem, that sir, here logarithmic relation is there, and here 1 by x to the power 1 by 2 relation is there. This is more stronger. Or let's check by the formula as well. So let's put the value. Built-in potential of A we need to find out. Temperature and everything I will mention in the problem. Okay, that I will give in the problem. 300 Kelvin I will mention. Along with that, Ni value I will give 10 to the power 10. So 0.0259 ln NaND by Ni square. So first one is that sir, I will be able to answer this particular thing, right? Total depletion width is larger in B than A. Then built-in potential also I will be able to tell that in built-in potential in A will be larger. Why is that so? Because Na is more. Then what about these two guys? Depletion region extends more in the N side in diode A than in B. If there is, like, we need to compare both of them. Here there is more doping. Here there is more doping. That's why most of the depletion will be in the N side only. Here there is lesser doping, and this is more doping. So most of the depletion region would be in the P-N side, right? What does that mean? That in N side more depletion would be there in case of diode A. So in the depletion region extend into the N side in diode A than diode B. Understandable? And what is the last one? What about the peak electric field? Peak electric field. What is the formula of peak electric field? Sir, half into base into peak electric field, which is E naught, that would be equals to built-in potential. So E naught would come out to be 2 built-in potential divided by W. Right? So what you can see here, sir, built-in potential will not be, both of them will have different built-in potential, and I know that built-in potential of A will be larger than built-in potential of B. But again, Ln relation, and here this particular relation. Basically, what I mean to say is that this is increasing very less and this is increasing much more. Are you able to understand this point? We know that WB is greater than WA and VBA is greater than VBB. But like both are not having the same relation. Like if I talk here VBA divided by WA, VBA divided by WA, this ratio is not same. That WB divided by WA will not be equals to V built in B divided by V built in A. These are not equal. This will be much higher. This ratio will be much higher than this ratio. That means surely the peak electric field, it cannot be same. 1 to 4 will be the answer. This is how I will be solving it. Let's go by the conventional approach. This is the mathematics. As much as you think, you will be able to solve it. Otherwise, conventional approach is there. So Na and D, for A we are finding out. So it would be 10 to the power 33 divided by 10 to the power 20. So what is the answer we will be getting? 10 to the power 13 into 0.0259. So, 10 to the power 13. Then I need to take ln as well. 10 to the power 13, then take ln into 0.0259. So 0.775. And V built in of B, what that would be? Na and D would be here 10 to the power 33 is the scenario here. Here the scenario is 35. So actually we have find out 0.775 for this one. It is 35 here. Into 0.0259. So 0.894. So you can see that built-in potential of B is more than A. But you see that like very less difference is there, no? Very less difference is there. Very, very less difference. Right? And what about the width now? Width. What will be the ratio of the width? 2 epsilon by Q, I don't care about it. 2 epsilon by Q, I don't care about it. If I talk about B, right? So if I talk about B, so 1 upon NA, 1 by 16. So 1 by 10 to the power 16, can I write it down as 10 by 10 to the power 17? Say yes or no. Plus 1 by 10 to the power 17 into V built in, which is 0.775. So this is becoming 11 to the power 11 by 10 to the power 17. And what about width of A? That would also be 2 epsilon by Q. 1 by 10 to the power 18 could be written as 0.1 divided by 10 to the power 17 plus 1 by 10 to the power 17, 0.894. Just take the ratio WB by WA. What will be the ratio you will be getting? WB by WA. So the ratio will be 11 by 1.1. 10 times under root is there. So 10 times this will be 11, 10 to the power 17, 10 to the power 17 will get cancelled out. This is 1.1. So 11 divided by 1.1, that would become 10. 10 into 0.775 divided by 0.894. So can I find out the ratio? What will be the ratio, sir? 11 divided by 1.1, that would be 10. 10 into 0.775 divided by 0.894 and then take the under root. Almost 3 times. Almost 3 times. So depletion width is almost 3 times in B than A. Almost 3 times. Is that understandable too? Can you find out this ratio? Very easily I can find out this ratio. I don't need to put these values. Just simply this is how I can find out the ratio. So this ratio I have find out. This particular thing I have find out. Right? Now you know that, sir, if I need to find out the peak electric field of B. So that would be 2 into V built in divided by W width of B, and peak electric field of A, that would be 2 into V built in divided by width of A. If I take the ratio of both of them, EB by EA, peak electric field of B divided by peak electric field of A, that would be V built in of B divided by WB into WA divided by V built in of A. So V built in of B divided by V built in of A. Although I don't know why I'm doing this mathematics, you should be able to do it on your own. V built in of B is 0.775 divided by V built in of A, 0.894. My aim was not to let you do this particular calculation. My aim was to think that how would you think and how would you take the correct option. Otherwise I would have asked the values, no, find out the built-in potential, find out the built-in potential, find out the electric field, find out the depletion width. I don't want you to find out all these things. I just want you to think. But if you are not able to think, then this is how you can solve it. WA by WB. WA by WB is 1 by 3. So you can sense that surely it is not coming out to be 1. For sure it is not coming out to be 1. Right? It is coming out to be 0.775 divided by 0.894 divided by 3. It is coming out to be roughly around 0.3. 0.3. This is the scenario. Okay. So peak electric field will be higher in diode A. Why is that so? Because in diode A, depletion width is lesser. If depletion width is lesser, then surely your peak electric field, this value is lesser. So this value will be more only, which is pretty obvious. Okay, so this is not same. Now depletion region would extend. How it would extend? So in N side, in B, how it would extend? So depletion width of B multiply with, in B what is the scenario? 10 to the power 17 divided by 10 to the power 17 plus 6 plus 10 to the power 16. So it would become 11 into 10 to the power 16. Right? and xn in A, WA into 10 to the power 17 upon 10 to the power 18 plus 10 to the power 17. So what it would become? So this would be 0.11 into 10 to the power 18 and this would become 1.1 into 10 to the power 18, right? 1.1 into 10 to the power 18. So xn in B divided by xn in A, that would come out to be WB by WA 10 to the power 17, 10 to the power 17 plus 18, 1.1. Yeah. So now simply take the ratio 1.1 divided by 0.11. 1.1 divided by 0.11. So WB by WA we have already find out. WB by WA, that was 3. So 3 into 1.1 divided by 0.1. 1.1 divided by 0.11 into 3. So almost 30 times. So in B, the depletion width would be extending 30 times that it is extending in A. So what is written? The depletion region extends into the N side in diode A, more into in the N side in diode A than in the B side. Something wrong we are doing. Okay, it will go in the inverse proportion. No, here I did the blunder. It will go in the inverse proportion. No, here we have find out towards the P side. More doping means lesser depletion width. So here I have done the blunder. Actually, I am very tired, but all this calculation you should not be looking at it. You should be able to solve it on your own, right? This calculation is not the major task. Just how would you think that is the major task? So the scenario is, what is the scenario? Are you will be able to do it on your own, no, right? WB into, in B the scenario will be 10 to the power 16 upon 10 to the power 16 upon 10 to the power 16 plus 10 to the power 17, and here it would be 10 to the power 18 upon 10 to the power 18 plus 10 to the power 17. Say yes or no. This will be the scenario. Now you can check it out. Almost it will come out to be 30 only. You can take the ratio. It will come out to be almost 30. Okay, but opposite. Oh, in opposite manner 30 or whatever it is. Let's take the ratio. Xn of A divided by Xn of B. So this is coming out to be WA divided by WB. This is 1 by 11 and this one is 1.1. Now WA by WB is 1 by 3. So 10 by 3. So almost 3.3 times. So in A, the depletion width will be extending almost 3.3 times than compared to B. So almost 3.3 times. So this will also be correct. Intuitively, within 2 minutes, you will be able to answer it. If you just know that logarithmic will be making lesser impact and this 1 by under root x would be making more impact. That's it. Okay. Log versus 1 by x. So 1 by x will be winning. We need to look at the doping. Then everything would be clear. So built-in potential will not change much, right? But depletion width will be changing significantly. If you are just doing the doping 10 times here more, then depletion width is changing significantly, but built-in potential is not changing significantly. This is not significant change. 0.9, 0.8, right? Almost the change is of 0.1 volt only, but depletion width is becoming 3 times. Significant change is there. It is not even 1.1 times, right? Hardly it is 1.1 times, but this is becoming 3 times. Understandable? So every question you will be able to answer very easily, right? Let's go to the next one. Again, very straightforward question. If this is 0, what this node will be? Minus V1. This is a simply inverting amplifier. Here, this is V2, this would become V2 by 2. This is a non-inverting amplifier which will provide a gain of 1 plus RF by R. which will provide a gain of 2. So this node will become V2, right? So this is minus V1, this is V2. So if I only consider minus V1, then what will happen? This hole will be shorted, so this will become V1 only, right? If I only consider minus V1, V2 is 0. If V2 is 0, that means from here nothing would come up. Again, it will simply become a inverting amplifier. So minus V1, it will become plus V1. Plus, if I only consider V2, I don't consider this one. Then again, here V2 by 2 would come. Again, it would provide a gain of half. Sorry, gain of 2. 1 plus R by R. So again, it will provide a gain of 2. So this will become V1 plus V2. Very simple thing, very straightforward. These kind of questions are also asked in PYQs as well. You will be able to solve it. Just simply apply the superposition. From V1 to minus V1, from V2 to here V2. Then minus V1 is there, V2 is there. Again, apply the superposition. When I only consider minus V1, then what will happen? This V2 is 0, this will be 0 only. So from minus V1 to V1 I will get. What about this V2? If this is V2, this will become V2 by 2. Right? This will become V2 by 2. 1 plus R by R. From here the gain will be 2. So V2 by 2 multiply V2, V1 plus V2. This is the answer we will be getting. Okay, a lot of people would have done minor mistake here. I know that. Now you would be saying that, sir, I could have easily solved it. I did the minor mistake. If you are doing it, then ask yourself that why this error was there. A lot of people would have answered minus V1 plus V2. Someone would have done V1 minus V2. Why all these errors are happening? Should not happen, no? Right? So who is to blame here? Minor mistake? No. You are to blame here, no? That if I am able to score maximum marks in this particular question, why I am reluctant here? Why I am not putting up my full concentration? Okay, let's go to the next one. Yeah, so it is NMOS given. Okay, when the switch is at node A, when the switch is at node A, so what is the scenario? This is 3 volt, this is 2 volt, and this is 5 volt. So what is the scenario here? Which one will be drain? This one will be drain, this one will be source, and this one will be gate. Okay, what is the VT value? Threshold potential is 0.5 volt. Okay, so VGS is here 1 volt, threshold potential is 0.5 volt, and VDS here is 3 volt. So VDS is greater than VGS minus VT. VDS is greater than VGS minus VT. Yes, sir, that means it is in saturation region. If it is in saturation region, so what will be the current? That ID current would be equals to X, that would be mu n CXW by 2L. 100 microampere multiply with VGS minus VT whole square. What is the value of VGS minus VT? That is 0.5 whole square. So that would become 1 by 2, 1 by 4. So current would come out to be 25 microampere. So value of X is coming out to be 25 microampere, which is wrong. Okay, although it is a MSQ, but only one option is correct here. What about Y now? What will be the value of Y? 0? Absolutely not. Why is that so? Because again it is NMOS. Right? So this potential is 3 volt only. So downward potential is 2 volt only. And here there is, sir, 1 volt. So sir, drain is at lower potential. That's why VDS is less than 0. Sir, the current Y is 0. Wrong. This does not happen, no? Because MOS is a symmetric structure, right? MOS is a symmetric structure. That means drain and source are interchangeable. In case of NMOS, the one which is at higher potential, that will be drain. I say this line again and again in the class. And the one which is at lower potential, that will be source. Right? So this will be drain now, this will be source. Now what is your VGS value? Sir, VGS value will be 2 now. Right? What is the VT value? VGS value is 3 minus 1, 2. What is the VT value? 0.5. So what is your V overdrive? That is 1.5. What is your VDS value now? Drain to source potential, that is 1. That means VDS is less than V overdrive. What does that mean? It is in linear region. Is that understandable to you? So always check, first check the type. NMOS it is, that means higher potential will be drain, lower potential will be source. So what will be the drain current now? Mu n CXW by L, that would be 200 micro into VGS minus VT. V overdrive value is 1.5 into VDS. How the current would be flowing? From the higher potential to lower potential. This will be the direction of current. Into VDS. What will be the value of VDS? 1. Yeah. Then 1 square by 2. So what is the answer you are getting? 200 microampere. Right? VDS square by 2, 1 square divided by 2. So this will become 1.5 minus 0.5. That would become 1. So 200 microampere. This is the current you are getting. So this is the option. This is also wrong. Why is that so? Because the direction of current would be upward, no? Current will always flow from higher potential to lower potential. Higher potential to lower potential. So current will be flowing upward. But the value of I is Y microampere. So Y will be negative. Right? So this will be the correct answer. This is also wrong. Well and good? Yeah. So that's it. This is the solution. So from my side, solutions have ended. Last two questions are mathematics. Okay.
If two eigenvalues of the matrix A are -1 and 4, then the magnitude of the determinant of A inverse would be. Okay, so if I know the two eigenvalues, right, then I can actually calculate the other eigenvalue. Okay, uh, so I know the determinant of matrix A would be the product of all the eigenvalues. Okay, so okay, still I don't know. So what is the determinant here? This value. What is the, okay, two eigenvalues I know. Okay, so okay, so if I correctly remember, like the trace of my matrix A, right, for a third order uh, matrix, 3 cross 3 matrix, would be equals to the sum of all the eigenvalues. So let us assume that the third eigenvalue is lambda. Okay, if the third eigenvalue is lambda, then trace of A, right, trace of A is nothing but the sum of the diagonal elements, that is 5 plus x will be equals to -1 plus 4 plus lambda. So from here I can get the value of x would be equals to lambda minus 2. Okay, that is what my x value is. Also I can say the determinant of A, right, will be equals to the product of all the eigenvalues. These two properties will always hold no matter what. Okay, determinant of A will be product of eigenvalues. Okay, so determinant of A in this case is what it is, basically 3 into 2x minus 6 equals to product of the eigenvalues, that is -1 into 4 into lambda. Okay, so I know my x is equals to lambda minus 2, right? Either way you can solve this. uh, uh, Let me solve it like this: lambda equals to x plus 2, that will be easier. So this will be 6x minus 18 equals to minus 4x minus 8. So 10x will be equals to 10. So x will be equals to 1. So lambda would be equals to 3. So they are asking you the determinant of A inverse. So determinant of A inverse will be basically 1 by determinant of A, correct? Okay, so determinant of A is product of the eigenvalues, that is basically minus 4 lambda, lambda is 3, so it is minus 12, so it will be minus 1 by 12 basically. So minus 1 by 12, I can calculate minus 1 by 12, right? 1 by 12, yeah, minus 0.0833. This will be your answer for the question. Yeah, let's solve this question. So like I've already solved this question using method 1, so that will come here later. Something clicked in my mind that we can use method 2 as well, right? So first you watch the method 1. This is the method 1 that will just come after this, right? Make sure you watch the method 2 as well. That is a easier method and a faster method to solve. Okay, let f be equals to yz zx xy and s be the portion of the sphere that lies in the first octant. Then evaluate the open surface integral. What will be the open surface integral, right? So first of all, you will think that I have been given a surface integral, so I will use the divergence theorem, del dot f, right, and they'll compute the volume integral. I can use the Gauss divergence theorem. So del dot f will be very simple. This will be 0, this will be 0, this will be 0. So answer will be 0, and you will be wrong because they have not asked you to uh, find out the closed integration. They have specifically mentioned that they are asking you the open surface integral, right? Open surface integral. Open surface integral. So what is open surface integral? Open surface integral, if I draw the surface, right, what is the first octant? So this is my x, this is my y, this is my z. So first octant would be this part, right, in the positive, and your sphere would be in the first like the sphere in the first octant would be this surface. So they are only talking about the first octant, where my both, I will mention this, where basically my x is greater than 0, y is greater than 0, and z is greater than 0. This is the surface. I will mention this, don't worry. In the question this will be mentioned. First octant basically means x greater than 0, y greater than 0 and z greater than 0. Okay, so basically this outer surface, right, of the sphere, they're asking you how do I compute. You cannot use Gauss theorem. So for this I obviously need to compute the unit normal vector, direction of the unit normal vector, n cap. So n cap, they told me that it is a n cap is a outward unit normal vector to the surface, outward vector. So how do I compute n cap ds? How do I compute that? It's pretty simple, right? What you can do is uh, you can take this surface and you can find out the normal vector along this surface. How to do that? Simply take the gradient. Simply take the gradient of this surface, right? So yeah, I hope you can take the gradient, right? So let's take the gradient. So what is grad of f? Not grad of f, sorry, grad of the surface given, right? Grad of s basically. Grad of s, the scalar point function, and that will give me the gradient. Correct? So yeah, let's do that basically. So grad of s would be what? This would be uh 2x I cap plus 2y j cap plus 2z k cap. That is my grad of s. Now I have to compute the unit normal vector, right? Unit normal vector, because n cap is a unit normal vector. So n cap would be grad of s upon magnitude of s. So this is equals to 2, I can take common. So 2 is anyways outside, divided by 2, that anyways will go away, the magnitude. This will be x I cap plus yj cap plus zk cap divided by under root of x square plus y square plus z square. Now the beautiful thing about this is they have given me the surface of a sphere, and the surface of a sphere must satisfy this relation x square plus y square plus z square. So this will always be equals to 1. So technically your normal vector is this. Now what do? Now you convert everything. Now you do the f dot n cap, right? You do f dot n cap. So what is f dot n cap? F dot n cap. So f dot n cap would be simply this dot this. I think you can do it, right? So the first I dot I will be xyz, second also will be xyz, and third also will be xyz. I think you can do it. I hope you can do it. This dot with this, right? So actually your f dot n cap is actually 3xyz. And what is the magnitude of the surface vector, right? How do I write everything in terms of surface? Bit difficult. So how do I write down the surface vector ds, right? How do I do it? So this surface, right, this surface has what? This surface has r constant. If you see the radius of this radius, right, is always constant. So r is constant, right? What is changing? The theta is changing. Basically xyz, the angle with respect to the positive z axis is actually called as my theta, and angle with respect to my positive x axis is called as phi, right? So I have taught this in vector calculus as well. Again I will tell you how to remember this, right? So what will be the, so ds, right? Ds, your r is constant, r is not changing. What is changing? Your phi and theta are changing. So it will be product of your phi and theta. Now what is the length of this arc? Length of this arc. So let me first of all tell you what is the length of this arc. This arc, right? What is the length of this arc? This is r d theta. I hope you know it. R d theta will be the arc length here, right? And what is the length of this arc? I have to compute the radius here, right? Radius. So what is the radius in the xy plane? It is, this is my radius r, r sine theta, right? This radius is r sine theta. This radius is r sine theta. R sine theta into d phi. This will be the arc length of this, right? And your surface will be formed like this. This and this. These two are my small sides along phi axis and along d theta. So this small length is what? This small length is r d theta, and this small length is actually r sine theta and d phi. And trust me, no one will explain you these small things. Everyone will directly say you that your ds will be r square into sine theta into d theta into d phi. Everyone will tell you to mug this up. But I am explaining you. Actually, this is the small surface, right? And the breadth and the length of the rectangle are these two values. That's how this formula came. Okay, I'm explaining you everything. And of course, your r is constant. R is equals to 1. Right? Radius of the circle, radius of the sphere is 1. So sine theta, d theta, d phi. That is my ds vector. So we got our ds vector, we got our f dot n. So ultimately, we have to compute this value. We can easily compute this value. Okay, one more thing. What is your x? So your x, right, in spherical coordinate. So if I project this r in the xy plane, this will be what? R sine theta. And your x value would be r sine theta cos phi. Correct? And your y value would be r sine theta sine phi. Okay. So these are very basic conversions which you should know. R sine theta cos phi. Y will be r sine theta sine phi. And z will be r cos theta. So replace all these things. And in the first octant, what happens? In the first octant, if you see, your phi goes from 0 to pi by 2 and your theta goes from 0 to pi by 2. Correct? So your phi is going from 0 to pi by 2. Your theta is going from 0 to pi by 2. R is constant, obviously. So what is happening? This will be xyz, that is r cube. So r is 1, so I don't need to worry about that. Sine square theta into sine phi cos phi, sine phi cos phi, and cos theta is also there, right? And here on the in this particular function, what is my ds? Ds is this, right? Sine theta d theta d phi, sine theta d theta d phi. Okay, and obviously your theta both are varying from 0 to 0 to pi by 2. It does not matter, whichever one you solve first, does not matter, right? You can, this is in variable separable format, so you can easily solve it. So sine cube, so if I rearrange the terms here, this will be sine cube theta into cos theta d theta, and this will be this can be written as 1 by 2 into sine of 2 phi d phi. Correct? Okay, I hope I'm solving everything correctly here. So yeah, let us try to solve it. Okay, so what we can assume in this particular integration, we can assume our sine theta to be some t, right? If sine theta is t, your dt would be cos theta d theta. Okay, so this will be t cube dt, correct? And this is pretty straightforward, right? This will be 1 by 4 cos of 2 theta, minus sign would be there. I can change the limits. So pi by 2 to 0. I have just swapped the limits because a negative sign is there. Okay, cool. What about the limits in this integration? So if your if your theta is going to 0, your t is going to 0 as well, right? So t would go from 0 to, if your theta is going to pi by 2, t would go to 1. So this will be 0 to 1, right? So this will be basically t raised to power 4 by 4 going from 0 to 1. So this will be 1 by 4 into 1 by 4 into, okay, okay, one small thing you forgot, right? We're adding, so there is a 3 as well, right? There is a 3, don't forget there is a 3 at the starting. So yeah, these kind of small mistakes can happen, so be very 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 careful, very attentive. And this value, right, this will be what? So cos of 0 is simply 1 and cos of pi is simply -1, right? Because 2 into pi by 2 is pi, so this will be 2 actually, so this will be 3 by 8. Okay, so this was a lengthy question, I do agree, I certainly do agree this was a lengthy question. So your answer is 3 by 8. Let me write this in 3 decimal places because the answer has asked you to compute in 3 decimal places. So 3 by 8 would be 0.375. This will be your answer for the question. So now, like, so let's solve this using method 2. So method 2 actually will use the Gauss divergence theorem, correct? How? So I have already mentioned to you what is the surface. This is my open surface, right? So if this is my open surface, what I can do is I can calculate the closed surface integral, right? And closed surface integral del dot f is actually 0. So your this integration is 0, right? So what does it mean? This, sorry, not closed, yeah, closed surface integration is 0, right, along this whole surface. So how many surfaces do I have? So this is f dot n cap ds. Okay, so if I show you this surface properly, let me show you this surface. So in total, I have how many surfaces? So this is the first part of the surface, right? The outer surface that we actually have to compute, and these other parts are all here. Let's say this is the surface 2, this is the surface 3, and this bottom part is the surface 4, correct? Now all these are interesting in surface 2. So how can I write this particular integration? I can divide them into chunks, right? So this whole closed surface integral is 0. It is certainly 0 because it is a closed surface and I can use the Gauss divergence theorem. This will be equals to what? This will be equals to my integration of the surface 1, right? Surface integration, open surface integration of the surface 1, that is f dot n cap ds, and similarly I will add it with the surface 2. Surface 2, and same thing will happen for surface 3 and surface 4. I can break this down into 4 surface integrals, totally valid, and I hope you will not be mad at me if I do that. Now the interesting part is, what is my unknown? I have to compute this part actually. I will only have to compute the integration for surface 1. So if I have to only compute the integration for surface 1, what will I do? I will simply because this part is, this addition is all 0, right? So I can take all these on the other side. So my this part, right, that I have to compute, I can avoid computing it and I can compute this other 3 minus of all these 3, right? Correct. So these are actually very easy to compute. Why? If we see the surface 2, surface 2 is what? In the xz plane. In xz plane, what happens? Y0. Xz plane, surface 2, y0. Surface 3, what is 0? Surface 3, if you see, it is this surface, that is yz plane, x is 0. Your answers will be very simplified. Surface 4 is the bottom surface, your z is 0, right? things will be very simplified. Minus, now what will be like the surface vector? It is unit normal vector outward. So in case of 2, right, it will be what? It is xz plane, so it is dx dz into minus j cap, right, opposite direction, opposite of y axis. So uh, okay, so I will write here, it will be ds vector would be dx dz into minus of j cap ds vector would be, in this case, like you can do it, right, it is simply the yz plane, and in yz plane it will be dy into dz into minus of ax cap. So dy into dz into minus of ax cap, that is nothing but minus of I cap. And similarly you can do it for here as well, again it will be downward, so ds vector would be dx into dy into minus of k cap. So now this integration can be very easily simplified. So in the first case your y is 0, and if y is 0, what is your function? If y is 0, okay, if y is 0, this will be only this part, zx into j cap. So zx into j cap, give me 1 second, zx into j cap, and minus j cap is there, also dy, dx dz is there. Similarly you will do it for the other surfaces as well. You will see that whatever are the components here, this will come out, right? So y into z will be here, right, because the x is 0, you can put x equal to 0 in the function, you will see this only, and this will be plus I cap into minus I cap. Give me 1 second, let me get more space. Okay, let me keep this a bit smaller here. I cap into dy dz, and similarly for the third part it will be x into y into k cap into minus k cap into dx dy, right? So now what are the ranges of the surfaces? So what is this? This is a semicircle, right? This is nothing but a semicircle. So you can convert this into its own coordinate system. You can convert this into its own coordinate system. So for this particular part, you can assume that I have a rho radius, right? I will convert every particular surface into their own coordinate system. It is a bit difficult. So if you are not comfortable, use method 1. If you are comfortable, great. So this, let's assume this is a like 2D circle of radius rho, and I will assume my angle that will start from xy, and that will start at x-axis and end at z-axis. So angle will go from 0 to pi by 2. So what is the conversion? What is my x? So x would be, if this is, let's say, theta, right? This is, let's say, theta. X would be equals to what? X would be rho cos theta, and z would be rho sin theta. Very simple conversion I am doing. That's all. I am doing very simple conversion. Okay, I am just trying to compute this part. Now here your rho is actually also varying, because my surface is what? My surface is this part, right? This is my surface. So here is my rho constant? No. So here rho will be something else, here rho will be something else, here rho will be something else, right? So rho is also varying. So what is the variation of rho? Rho is varying from 0 to 1. What is the variation of theta? Theta is varying from 0 to pi by 2. If previously I told you rho is not varying, I was wrong, sorry. So rho is varying. Okay, rho is also varying, theta is also varying. Rho, theta, both are varying. Okay, so what will be my dx into dz? It's very simple, right? So dx into dz, right? Dx dz, how will I convert this into this surface? It is very simple. So it will be d rho. So again, if I consider a very small section, right, it will be d rho. That is the small length along the radius of this 2D circular region into rho d theta, right? Because again, if I zoom in on this, right, I will have a length and breadth. Length would be d rho, okay, breadth would be rho d theta. That's how you compute the arc length, right? Rho d theta. So this multiplication will be the small area. So dx dz will be converted into rho d theta. Okay, remember here theta is something else. Theta is not my spherical coordinate system. Theta is something else. Okay, rho d theta. Correct. So yeah, now I'm good. So it is symmetrical. So if I know the value of this part, right, all of them will be same. So there is negative sign. I can take the negative sign common, right? So this will be simply plus. This will become plus. Why? Because there is j cap dot minus j cap. So minus sign will come here. This will become plus. All these are in brackets. So don't worry. Everything will be plus. All I need to do is just to calculate this first part, right? Because it is symmetrical. All these values will be same. So you have to be smart enough. If you're not comfortable, use method 1. So zx, now what is z and x, right? This is basically rho cos theta, rho sin theta. So this will be rho square sin theta cos theta into rho d theta. Okay, and this will be multiplied by 3. Why? Because all these 3 are same. This will be same only, right? These are all symmetrical. Here also you see you have a region semicircular. Here also you see like kind of not a semicircular, sorry, a quarter circle, right? Quarter circle. So all these are same value. This will come out to be symmetrical. This will be same. Okay, again I'm telling, if this intuition is not there, ignore this method. Use method 1. Okay, so this is rho square. This is rho cube, right? So this is a in variable separable format. So rho will vary from 0 to 1 and your theta will vary from 0 to pi by 2. Correct? So theta and rho. So this will be rho cube divided by rho cube integration, that is rho raised to power 4 divided by 4, right? And 3 is obviously there in the front. And this is sin theta cos theta 0 to pi by 2. This is nothing but sin 2 theta divided by 2, that is 1 by 2. So okay, this part will be what? 1 by 2 sin 2 theta, and integration of 1 by 2 sin 2 theta is 1 by 4 cos 2 theta negative. So again I will change the limits, interchange the limits. So this will be 3 into, this is rho going from 0 to 1, this will be 3 into 1 by 4 into 1 by 4 into 2. So this comes out to be 3 by 8. This is same as 0.375, right? So this is a way to solve this faster, but you need to have these much of intuitions, right? And you need to use Gauss, like here also we can use Gauss divergence theorem, but not in a straightforward manner, in a other manner. Okay, so answer will come out to be same, but you will have to be smart to understand this will be symmetrical. You have to assume few things, right? So if you don't want to solve that using basics, so your answer would be 0.375.
Yeah, so you guys are done with the solutions. I hope you have enjoyed this particular test series, I would say, because this was the last test. Now what you need to do is that in the comment section, I want you to comment down that what was your score in Concept X, Killer X, Booster X and ReplicaX. Okay, write down your score and just tell that yeah, this much improvement you are having, or you feel like that's something we are learning. So surely you should be commenting down. Okay, complete discussion we are going to do at 6:30 p.m. This I have already told. At 6:30 p.m. we will come live and we will talk about the discussion that what was the paper level and based on the marks what you can expect. Okay then, yeah. Thank you very much. Happy learning. Now, as of now, we are not thinking of another AIMT. These 4 All India mock tests are more than enough. Mostly from all the topics we have framed the questions. Okay, yeah. Thank you very much. Happy learning.